Yeah.
Good morning. Welcome to the second day of the 26th annual Tcl'2019 conference. A couple quick announcements. Today, lunch is on your own. There's tons of restaurants within really short distance of here, some of which are pretty good. The banquet tonight is at 6 p.m. It'll be held down here, so that's included, so please attend. We have the Birds of a Feather and Hospitality Suite, again in 1805, will be open this evening at 7:30 p.m. and it will be open until 12:30 a.m. for extra partying and hanging out. And we've got the works in progress today. There's slots for that. There's a sign-up sheet for slots, so please sign up. I think the works in progress can be really interesting because they're really quick lightning talks, and even if you haven't done anything, you haven't prepared anything, you can. It's not very much work to whip out like a 5-minute talk, and those can be really, really interesting. So I invite you, if you've got some little thing that you've been sitting on or something that's kind of interesting, that you put together a lightning talk and share it with the rest of us. Okay, so for our keynote today is Will Duquette. Will has been a software engineer at the Jet Propulsion Laboratory of NASA for 33 years. Get that right? Yep. He has code in the Deep Space Network for over 20 years, and the Deep Space Network is the array of like radio telescopes and stuff, or antennas, or whatever, that they communicate.
And everything else.
That they communicate with the spaceships and the probes and things like that with. So that's pretty cool. I assume that that software needs to work really, really well and not lose a lot of bits. So that's pretty cool. He has a graduate degree in math and operations research. I think he's a fallen operations research guy. He built a PDP-11.
Well, ascended.
He's ascended. Okay, great. He built a PDP-11 from a kit. If those of you are old enough to remember Heathkit. And booted an operating system off of paper tape. And I don't know if you've ever seen paper tape, but it's about 1 inch wide, and it has 8 holes in it, the presence or absence of holes representing a byte, well, representing a bit, 8 representing a byte, of course. Pretty amazing stuff, pretty clunky back in the day. So kind of fascinating that somebody can use a computer that is so limited and fall in love with it. But that's what happened to a lot of us. He wrapped the C library with Tcl back in version 7.5 and said, this is great stuff. He's been a Tcl fan ever since, so that would be like 20 years. And he's here to talk today. You guys have heard of Rust language, modern and very highly regarded language that has some really, object-oriented systems programming language that has some really neat features. And he's here today to talk about Tcl, Rust, and the death of Rube Goldberg. Will, come on up.
So I'm here today to talk about my work in progress because I couldn't wait until this afternoon. I should add it was my dad who built the PDP-11 from a kit. I just made a great use of it. And I will also add the lovely thing about paper tape is you end up not just reading it, but punching lots of paper tape, which makes lots of little teeny black dots, which are really fun to take to high school football games and drizzle in people's hair. Just so you know, I know you'll find that a very useful piece of information at some point. Tcl, as we know, is implemented in C. Some while back, I started implementing my own Tcl interpreter in Rust about a year ago. I'm going to talk about that. But one of the things that I have become convinced of over the last year is that Tcl's original uptake was largely because it was implemented in C. One of the reasons Tcl is no longer gathering users is because Tcl is implemented in C. Okay? I hope to open your eyes fairly wide and maybe make your jaws drop at certain points in this. Back when I was doing most of that work in the DSN in C, and I have code that's been running reliably for over 20 years. Every track of a spacecraft the DSN has done since like maybe 1999 has involved my code in some way. There are many other people who can say that. I'm not that special, but I have code that has acquired, was lovely to begin with and is now something they want to kill because it won't die. So I've done a lot of C. I've done some C++. I've written Tcl extensions in both of them. And Tcl is not a fun language. About the time I was doing the DSN work, I tried doing some open source programming in C at home on my own time, and soon realized that my personal time was too short to be diagnosing dangling pointers and null pointers and all of this without the expensive tools I had access to at work, which is why I got excited about Tcl. I suspect I'm not the only one in the room who can say that. You've got in C a very limited standard library by modern day standards. You've got dangling pointers, buffer overruns, memory leaks, core dumps, all manner of interesting things. It's easy to make mistakes and not discover you made them until very much later. It used to be a really good match to the hardware. I am assured that in these days of multiple cores and branch predictions and all sorts of things that I do not understand, that that's really no longer the case. But there are some standard ways of making C and Tcl work together that, as I say, back in the day, were really totally cool. They were very compelling. You could write a system, could be a library, could be an entire application and extend it in Tcl. You'd make a configuration file that was Tcl. You could provide some behavior you didn't want to have to compile by adding little scripts that would execute in Tcl. You could take a library and wrap it. That's how I got started. I'm sure a lot of us old folks got started kind of that way. And then have this library that you could magically script and blow everybody's minds. There's for the DSN work, there's a Tcl shell I wrote originally in 7.5, that's the one Carl mentioned, and then in Tcl 8, using the new syntax, the new C API, that is still in use, that probably I'm the only person who used, but I was kind of the wizard. I could diagnose connectivity problems amazingly easy because I could just sit down in an environment where we had no compiler and try things. Nobody else could do that. You can add speed and utility to Tcl. I've done this too. You're writing an application in Tcl and you've got some stuff that's expensive, and so or that you don't want to code yourself, and so you add a Tcl library to do that. We've all done that, most of us. Done that over the years. This is not as obvious a choice as it used to be. When you were primarily programming in C and you were starting to get into Tcl, that was a really easy sell to do that. These days, if you're doing mostly back-end programming, you control the environment, as the folks here at FlightAware do. Okay, makes a fair amount of sense to go that route. You control everything. If I were a young guy wanting to work on an open source program in C, and I'll let you all stop laughing, it would not occur to me at this point to want to add Tcl to that. Tcl doesn't seem like a small addition anymore. And if I'm writing something I want to push out cross-platform to lots of different people, the amount of work I need to go through in order to do that is considerable. And if I'm not primarily a C programmer especially, I don't want to go through all of that. I want to use a language that makes it easier. I've written a lot of mostly plain Tcl applications that needed to be distributed as a single file. So you need to make sure you've got a base kit of some kind, and there are how many different ways to produce those. And then you've got to wrap your base kit with your project tree, and there are how many tools we've come up with to do that. I used to use Tcl app from TDK, alas. And then if you include binary extensions in that, you first have to build them for every platform you might want to run on, and then you've got to put them in the right place in your star kit, your star pack. And then you've got the problem that when you run it on some platforms, the virus checker is going to get angry with you and say, are you a virus? I think you're a virus. Okay. It's doable if you know what you're doing, but it's not simple. It's not obvious. I began to feel like we were all the frogs in the pot of boiling water. You know, we wanted ways to distribute Tcl apps that included binary code, and we figured out ways to do it. And it seemed so simple, but you really, if you step back and try to explain it to somebody, they look at you funny. They do. I am assured this is a picture of Rube Goldberg implementing a cross-platform Tcl extension in C with all the pieces that he needs. And I have to ask myself, why use C at this time? Yeah, it's everywhere. It's not like C is going to go away now, but you're constantly having to worry about memory safety. If you don't get your memory safety right, and sometimes even if you do, you got cybersecurity issues to deal with. That if you're a poor working programmer like me, you have no idea what it is that you did that somehow made your code unsafe. Concurrency. Don't let friends use pthreads. Okay. If you're doing cross-platform, you know, then you suddenly need to deal with concurrency. I still have not grokked semaphores. When I think of semaphores, I get this vision of people eating spaghetti around the table, but I've never clued in on what it really is all about. You want to do cross-platform, okay, suddenly you need to learn AutoConf and maybe M4, configure, maybe libtools if you're a bit crazy. You've got to understand GCC versus LLVM. You got to figure out how to make it build on Windows. And let me tell you, I have built Tcl and such like things on Windows using MinGW and MSys, and it works. But I mean, my goodness, I mean, that's a mashup. What build tool are you going to use? Make, nmake, cmake. When you see that there are 50 million varieties of the tool, that means that there's none of them that's compelling, really. And I know make pretty well. I can do all sorts of things. And then if you're wanting your code to build on every platform, think about all of the pound defines or other tokens you need to have in front of every single function that people like Don understand. You do understand all of them.
No comment.
And I got to say, people like Don and Richard, who are maintaining these C code bases that will compile everywhere, really, I admire that, and I don't understand it. But I salute you. And all of this is part of the C ecosystem. The ecosystem has gotten to be incredibly complex. Changing my tune a bit. I'll let you read that. I'm paying off one of Sean's things here. Gosh, this doesn't look anything like the toy aisle. I'm sure most of you know where that line comes from. Every so often I like to learn a new language. And my standard thing when I learn a new language is I write a text adventure. Been doing that for decades. Because I don't need to think too much about the link to the operating system. I just need a little bit of text I/O. And I don't need any other libraries. All I really need is to focus on learning the control structures, the data structures, how you hold your mouth right in that language. Some of you who know me, I usually begin my talks with a line from my grandfather. You didn't hold your mouth right. It's all about learning to hold your mouth right. Why I didn't have that slide, I'll get to in a moment. So I wanted to learn a new language, and I came across Rust. It was the first thing I've seen in my life, really, that looks like it could potentially be a replacement for C. I thought C++ was. Tried C++ when it was brand new. Tried C++ when they first implemented templates. Used it a bit later. One of the first projects I talked about here, I had done a wrapper to a C++ API in Tcl. But you know, if it were going to take over from C the way we all figured it would have done it by now, and it hasn't. It has its place, but it's not going to win as the premier systems language. So what are your alternatives? There aren't really all that many. One of them that is fairly recent is Rust. That's the Rust mascot. His name is Ferris. He's a Rustacean. People who program in Rust call each other Rustaceans. And I have to say, the Rust community is very much like the Tcl community, by and large, in my experience. That may be a crab, but Rust programmers are not especially crabby. They're very, very helpful, very pleasant. Why use Rust? It's intended to compete with C on performance. It's not quite as fast, but it's, from what I've seen, it's close. And what I've seen, I don't mean my code. I mean people who have been trying to work at that level. I'm not really an optimizer. It's intended to be memory safe. It's intent that the language is designed so that you can't have null pointers. You can't have dangling pointers. I'll talk a bit about that in a bit. Arrays are bounds checked. Dangling pointers don't happen. No garbage collector. The goal is to provide high-level, zero-cost abstractions, they're called. You're right, I'll move over a bit. Zero-cost abstractions. The idea is you feel like you're writing in a very high-level language, but most of the work is done at compile time. And the code that's being generated is what you kind of get if you were programming at a low level, trying to do it as performant as possible. It is currently easily cross-platform. There is a single Rust compiler, uses LLVM as its backend. You can write Rust code that runs trivially on Mac, Linux, Windows, unless you're doing platform-specific things on those platforms. If you are sticking to Rust code, it will compile easily. You know, you don't have to do anything special. It just compiles and runs. They are doing a lot of work in the embedded world. There is a smaller, reduced footprint version of the standard library, and if you target that, you can run embedded and you can run on normal platforms as well, with a few limitations. They're supporting WebAssembly as well, which looks like a really interesting technology, though I'm told that these days it's mostly being used by people who are making things run in your browser that you probably didn't want to have there. But so interesting language. I thought it was worth looking at. Now there's a thing. I've gone through this process many times. How do I get to Tcl from this? I've got this little adventure game framework, and you can go download it if you like. It's not a full game. I was focusing on the internals. How do I get from there to Tcl? Because this is a Tcl conference. I ought to be talking about Tcl. There's a process I always end up going through, at least in theory. First, I write a text adventure app. Then I say, oh, you know, because I'm a software engineer, I need to split out the framework and have the app and then this framework I could use to write another text adventure. I've never done that. I've never written another text adventure using the framework, but I always think that way. And then I start thinking, well, you know what I really need is to be able to specify a text adventure definition and then have a text adventure compiler with an engine that will run it. And we're in full Don Quixote tilting at windmills territory here, because the world has absolutely no need of another version of that system. There's a perfectly good one. It's called Inform. And if you have an interest in writing text adventures, Sean, I suggest you go look at it.
Is that 5 or is that 7?
6 or 7, either one. 7 is pretty peculiar, but it's interesting. But I start thinking about that, and well, you know, if you give a mouse a cookie, he's going to want some milk to go with it. So, you know, you just sort of lead yourself down the primrose path. And once you get to this third column, then you say, well, in this text adventure definition, they're going to need some kind of Boolean expressions. And they're going to need some way to specify a set of actions to take. And another of my maxims, thou shalt not implement half-assed extension languages. Anybody else done that?
I don't even know what half-assed means.
Half-assed. You're a good man, Richard. You know, you just start with a simple command language. It's just little commands to execute. And then you say, oh, I could use variables. And then you say, oh, I need some logic. I'll add in an if. I could do that like this easily. And then you end up with a monstrosity that is horrible to maintain and doesn't really do what you want. And so I have learned not to do that. I'm not going to do that anymore. I've also seen lots of other people do it, and it's rarely pretty. So of course my mind goes to Tcl. And I wasn't going to try to link standard Tcl into Rust. You can link Rust to C code, it works okay, but it would give me all of the problems that I was talking about earlier, and I don't want to deal with all of that. I wanted to work on something fun. And so I started looking at Tcl 7.6. I started looking at the man pages, and based on my own knowledge of Tcl, I wrote the beginnings of a real Tcl interpreter. It's got the control structures, it's got procs, it's got expert, got a number of commands, has basically no dependencies for the core interpreter, just the one Rust crate, they're called. And my goals for it, I wanted an extension language. If I were going to write a big system in Tcl, I'd use standard Tcl at this point, despite all the things that I've said. But I wanted to be able to extend a Rust app or wrap a Rust library and have a Tcl interface. I wanted a small footprint because if anybody else is going to use it, it's got to be something they feel like they can throw in without having to add this massive dog wagging their tail. I wanted it modular. So if there are pieces of the system, sets of commands that they didn't want, they didn't have to have them. I wanted an excellent Rust API. One of the things that really attracted me to Tcl was how easy it was to extend it in C, given that I was already programming in C. I wanted that kind of ability and better, if possible. I wanted it to be performant. We're waiting on that. And I wanted what I'm calling a non-gratuitous consistency with standard Tcl. The unset command has a no complaint option as of yesterday. It does nothing. It's just there so that if you want to say unset minus no complaint, you don't get a surprise, because there's absolutely no reason to throw an error just because the variable didn't exist. If that's what you wanted to check, whether the variable existed or not, there are ways to do that. It does not have octal done. There's no reason to implement octal numbers in it. As far as I am defining standard Tcl commands, they ought to work the way they do in standard Tcl. So my for each command, for example, will let you iterate over each item in a list. It will let you iterate over the items in a list the way for each will do. It does not yet let you iterate over multiple lists, but there's no reason not to provide that eventually, and I expect to. But insofar as it's gotten, it's meant to be consistent.
Do you have a global array Tcl platform?
No.
Okay. If you grow one, you'll have to choose an engine value for your engine.
As I say, non-gratuitous consistency with standard Tcl. But yeah, if the language becomes popular, and bear in mind, this is a personal project of mine. I work at JPL. This is not a JPL project. This is something I've been working on myself for fun over the last year. If people start using it, and it is available at Crates.io, which is the Rust package repository, and I checked yesterday and 108 people have downloaded it. I'm probably one of them. So a bit better than Lemon. A bit better than Lemon, I guess. Whether any of them are actually doing anything with it, I have no idea, but I haven't gotten any bug reports. That could be good, could be bad. So let me give you a quick tour of some aspects of Rust, so you know why I like the language at the lines of code level. One of the things Rust does that attracted me to it, when I was programming in C heavily, which I have not done in 10 years or more, I always had this notion in my head of ownership. I have allocated this block of dynamic memory. Who owns it? When I'm passing it, I see Richard nodding. When I pass it to a function, does that function get to just look at it? Does it get to modify it? Does it take ownership of it and it's not mine anymore and now it's its responsibility to clean up? Had to keep all those things in mind always. One of the neat things about Rust is it does that for you. And as you'll see over these next slides, the reason why I don't have the slide, you have to hold your mouth right, because if you're using Rust, you will hold your mouth right. You will have no choice. So here's a simple piece of code. We have an append function. It's going to take a string, which is a mutable string, and an str, which is some piece of text, which could come from a number of places, including a string literal. And it's going to push the latter onto the former. So I'm just wrapping the standard way to append text to a string here. If we look in my main, I'm creating a string variable containing ... I am appending something to it immediately using push string, and then I'm calling append to append something more to it, and then I'm calling println bang to print it out. A number of things to comment here in general. You notice that the only place you see types are in the signature of the function. This is very common in Rust. It's a strongly typed language with an awful lot of effort put into type inference. So it knows, just because the append function is what you're using, that text needs to be a string, because that's what you're passing in. You can always add type declarations to your variables. When I say let text equal, I could put let text : string if I wanted to. That's sometimes really useful, because if I put the wrong thing, the compiler will immediately tell me what's the right thing. And sometimes I've confused myself. That's fairly common. Rust is a lot like Tcl in that it's easy to get started with a little, but unless you have developed a deep understanding of what's really going on, what those curly braces actually mean, you find yourself having some trouble. And this is a similar thing. You need to acquire a deep model of what the compiler is doing, which may not be everybody's piece of cake. But however, this code doesn't. Oh, before I get to that, println, that bang means it's a macro. It uses a format syntax that I guess derives from Python, so I'm told. I don't know how much it resembles Python's current format strings. Not so happy about that, but that's what it does. The double braces there means print this thing out using its standard display format. And there's a way to implement a standard display formatter for every type. But the thing about this is all of the work to process that format string, however complicated it is done at compile time. And so it will ultimately be producing the code you would write if you were not using a format string, but were using lower level routines to produce exactly the output you wanted in the minimal possible way. It makes it faster. It makes it type safe. It also means that you can't pass arbitrary format strings to println, which is sometimes annoying for people like me.
Are you able to compose your own println-like functions in Rust?
It has a very complex hygienic macro mechanism. So yes, and there is the infrastructure to println is there. So if you want to write macros, I've done this. If you want to write macros that use a format string and take multiple arguments to build up something for storage, let's say, you can do that. Yeah. And you get the same advantages. It becomes a zero cost abstraction that makes your code look nicer. It's also something that can be seriously abused. You know how programmers are. But that code doesn't actually work. The reason it doesn't work is, you see the bold face there. Variables, Rust has taken a lot of information from the functional programming languages. And so the Rust compiler can reason about things easier. Variables are immutable by default. If I just say let text equal something, string is immutable data type, but when I say let text equal string, the compiler is not going to let me change what text references, it's not going to let me change the thing that it's referencing. Okay? Can't do it. So when I try to call push string, nope, compiler's going to tell me you can't do that. We call this fighting the borrow checker. And everybody goes through it when they're starting with Rust. So what I need to do is declare that variable mutable. Once I've done that, I have a mutable variable. I can update it as much as I like, and everything goes fine. But then I got a problem. Append doesn't declare that string to be mute. So when I try to call append, the compiler is going to tell me, you can't do that. You're not allowed to change it. That second line, that push string, is going to get a compiler warning. So I got to declare it mute. Okay. Now I'm good. No, I'm not, because Rust has this concept of ownership. When I call append, just passing the bare variable name like that of a normal variable, even a mutable one, I am passing ownership of that variable to that function. Append now owns that. It can change its value, but then down here on the bottom line, main doesn't own that variable anymore. It's not allowed to look at it. So you got a couple of choices. I could have append return the value, return the variable, and thus pass ownership back into main, which works but is ugly, or use an ampersand, which looks deceptively familiar. That's not saying pass this by reference. That's saying pass a borrow. In this case, it's a mutable borrow. If I left the keyword mute off, it would be an immutable borrow. It's saying, append, you're allowed to take this string and look at it, and in this case, you're allowed to modify it, but it's not yours. You don't get to keep it. In particular, you can't pass it to anything else that expects to take ownership of it because it's not yours. You have to give it back. And once you do that, this code will all work. So it takes a while to begin to recognize this. But that ampersand, for C and Pascal, or C and C++ programmers, you're going to think, even me, when I haven't done much of that in years, I can't help thinking about it as taking the pointer to something. And you are not. It's like the difference between curly braces in C or C++ or Java and curly braces in Tcl'. Yeah, an if statement in C looks a lot like one in Tcl', but those curly braces are doing something entirely different.
If the function, if it had not been a borrow, would it have called the destructor on the object into the function automatically?
Yes. Yes. Because it knows mutable borrows, immutable borrows. If those sound kind of like mutexes, you can have one mutable borrow of a value at a time, which you can pass down through a number of functions and then get back. You can have any number of immutable borrows of a function or of a variable at a time. But if you try to take a mutable borrow of something that has immutable borrows, you're out of luck. And if that sounds like mutexes, there's a reason. It's because the compiler does a lot of work at compile time that in normal systems would be done at runtime.
It sounds like avoiding mutex.
But it is. It is. That's a good thing. There are ways to work around that and do mutability at runtime, make something mutable, change it, put it back. And I've tried that, and unless you are very, very careful about how you do it, you will regret it. That's the only time I have had my code core done. is when I have done that and screwed it up.
By the way, this is starting to look very much like the ampersand for certain smart programming types in C++ or A and beyond.
Could be, could be. Everybody talks to each other. So there's a whole lot more. A few of you I know have looked into Rust a little more deeply. There's a whole lot more I could talk about here. I could talk about lifetimes, for example. But because of all this, when a variable goes out of scope, whenever it goes out of scope, the compiler knows. And it will drop it. There's no garbage collector. It will drop it at that point, and you can define the drop trait for any type that you write and have a method on that value that will be called when it is dropped if you need to do cleanup. And it's not like finalizers in Java, which are a horrible disappointment. It actually works. I'm not going to talk about it much today. There is a smart pointer type in Rust for reference counting. You just declare it, I want a reference counted string. And you can clone it freely, and cloning is just incrementing the reference count and letting you take the reference, use it. And when there's nobody using it, it gets cleaned up. And you don't need to figure out whether you need to increment the reference counter here or decrement it there. Any of us who have worked with Tcl', had new types to Tcl', have run into that where you're not sure you did it right. And then it works, and you think, well, I guess I did it right. You don't need that here. But much, much more I could say. There is a document online called the Molt book, or the Rust book. If you are at all interested in Rust, that's where to start, is with the Rust book. And it goes into all of these things in much more detail. It's a good read as well. It's interesting. It's not painful. Other things in the language. Enums. Well, that looks like a fairly standard enum. You got a number of constants. You can assign them. You use the enum type to qualify it, or you could bring the enum type into scope and just use the symbols. Seems fine. That is the Rust equivalent of a tagged union. In Haskell, it would be an algebraic data type. When I create a this, I have to provide a 32-bit integer, signed integer that gets carried along with it. When I create a that, I need to provide a 32-bit signed integer and a string that gets carried along with it. I can have as many of those as I like. A given variant, they're called, could have a tuple of 0 or more values. And as I say, it's basically like a tagged union in C, only safer and with a lot more support in the language for doing cool things.
Do you get to tell it how many bits you want to allocate for the enumeration value itself, or does it already pick?
It does what it does.
Okay, it does what it does. You don't get to say, oh, I only want you to allocate 8 bits.
What I will, it does what it does. In this case, because there's a string there, it has to hold a reference to a string, because strings are always on the heap. If it were only using what are called copy types, like integers, things that can be copied quickly, a lot of the ownership stuff I was talking about earlier applied because we were dealing with strings, which are always allocated on the heap. If I had been dealing with integers, I wouldn't have had to go through all that because it just copies them. The ownership's not an issue. So this will be as small as possible if all it had in it were integers. As soon as you get a reference in there, then of course it gets bigger.
On the previous slide, though, go back one slide. Do we get to choose how many bits are assigned to color?
Maybe. That would only come up if you were dealing with like a C library or something else low level that needed to know the bits. And I've not actually tried interfacing with C because I already gave my screed about C, so I won't go into that again. There are ways to do it. Going to come back to enums in just a second. First, I need to talk about Molt's value type. We're going to start talking more about my interpreter. Value is Molt's two-legged stork. It's its Tcl'2019. And it is intended to be very similar in a rusty sort of way to Tcl'2019. You can have a string rep, you can have a binary data rep, either or both. Once you get a string rep, it sticks. Can't change it again because values are by definition immutable, even though that data rep may be changing from one, shimmering from one type to another as you go. Spent a lot of time on this. I'm not entirely happy with the internals. I think we can make it faster, but I like the interface. And so here's an example. I can create a value from any of many different types, including any type that implements the display trait and the from string trait. That is, that can convert itself to a string and then convert itself back. If I've implemented those traits in that way, I can put it into a value and get it out again. I don't need to write the sort of boilerplate I would have to write to extend add a type to a Tcl'2019 because it's just part of the language. So I create a value from an integer. Integers in Molt are 64 bits. Molt is more or less Tcl. Did everybody see that? That's the acronym. I like it better than SNP, frankly. I always felt kind of bad about SNPs not in Tcl in later years. So I can put in the integer, I can get it as a string, I can get it as an integer, I could get it as a list of one item, the normal Tcl way. Notice these question marks here at the end of the last two lines. There's serious magic going on there. We're going to come back to those. Now, Molt is not currently byte compiled. I started by looking at the Tcl'76 code and kind of seeing what it did because, you want to get the semantics right first. And that was easier to look at than trying to figure out byte compilers and all of that. But ultimately, for speed, instead of parsing and evaluating in one pass, I decided I want to go to byte compiling, and I need an internal form. I need to parse it to some kind of parse tree. And so this is not deleted except for comments. This is the data structure that I parse any Tcl script into. If I am sourcing a file, if I am parsing the body of a proc for evaluation, that the body of that proc is in a value, and I ask for it in the internal form, and it saves it as the data rep for that value. And that data rep is a script. A script is a list of commands, which I call the data type is wordvec because I'm using command for the thing you register with the interpreter that has a name that you call. Wordvec is a vec of words. Vec is a Rust type that matches really, really well to Tcl lists. I have not found any reason to implement a Molt-specific list type yet. I'm just using the standard Rust vector. It's a vector of words. A word is a thing that I can evaluate to get a token, a value that I will then pass to a command in a normal way. Okay? And it can be one of several things. It can be a value. If I parse a brace word, I just get a value. No big deal. If I parse $X, well, I get a variable reference, and the string is the name of the variable. Because when I evaluate it, I'm going to need to look that up, and it's entirely possible that will point to something entirely different by the time I actually execute this. So I can't do the lookup early. I got to use the name. It can be a script. That line had square brackets in it, and so I need to parse that out, and I'll have this exact same structure recursively. It could be a list of tokens. If I have a double quoted string with multiple things in it, I need to remember, well, I had an A followed by a space, and then a variable reference, and then a space, and then a script, command interpolation, and so on. And so I keep each of those as words. And then within one of those strings, I can have the bare terms like A space and space B that go into that tokens list as a string. That's the data structure.
A suggestion, before you go too far down that particular Do race start, race sooner than later.
That's one of the next things on my list, but I've got to apply this to my expert parser first.
Okay.
Otherwise, there's not much point. Because when I do any of these things in the middle of an expression, I'm still doing it the old way. So I've got work to do there. But yeah, it's on my list, you'll see. So when I want to evaluate a script for each word vec, I convert the words to an array of values. I look up the variable values. I call the commands that I'm interpolating in. Evaluate the interpolated scripts. First word's the command name. I look that up. I pass in the other arguments to the command in the usual way. I get the result code. Maybe I return early. And ultimately, if I haven't returned early, I return the script's result. I could show you that code, but it wouldn't fit on one slide. And frankly, some of the code I've seen this time around hurt my eyes from sitting in the back of the room. So I decided to spare you all that. But I can show it to you if you're interested. It's straightforward. Here's how I convert, here's part of it, how I convert a word to a value. I use Rust's pattern matching capability, what they call a destructuring bind in some languages. I get the word, I want to get a value for that word. And so it depends on what the word is. If it's already a value, I clone the value. Values are reference counted. So I just get one more copy of the value. So in good Tcl fashion, if I put a value in a variable and then append it to a list and then add that list to a dict, I've only got one copy of that value in the system. If it's a variable reference, I look up the variable reference and hey, there's that question mark again. Now you may note, I could look up that variable, but maybe there's no such variable. Hence the question mark. We're going to talk about how that works. I could execute the script, evaluate the script. Again, question mark, because the script execution might not do what you wanted. And there's some more. I'm not going to go into all of that. Okay, let's talk about how we define commands. If we want to extend Tcl in C, here's how we define a command. And I picked one that had some reasonably complicated behavior, but I could fit on one slide, which is the exit command. So you get a client data pointer for if you have any context for this command that it needs. You get the interpreter, so that, of course, you might want to change variables, define new commands, delete them, whatever you're going to do. You need the interp. Also, you need the interp to pass the result back, because you have the result field in the interpreter. And you get the arguments in the obj_v array with obj_c as the count of them. First thing you do is you say, do I have the right number of arguments? If not, you call Tcl wrong num args, which formats up your error message for you, and you return Tcl error, right? Everybody seen that? If obj_c is 1, your return value, your exit code is 0. Otherwise, you have to call Tcl get in from obj to try to get that parameter's value as an integer. And it might not work, so you got to check with Tcl OK. And if it doesn't work, you return an error. And Tcl int from obj has already set the interpreter's result data to that error data. And then you call Tcl exit, and you're done. You die. But if you didn't, in a normal one, you would set the interpreter's result to whatever the result of this command was, and you'd return Tcl OK. I tried doing this with append. I don't know if anybody's looked at the definition of append recently, but it's a lot more complicated than you think, and I ended up having to remove almost all of the interesting stuff to fit it on the slide. So oft-repeated pattern in this code. Do something, get the return code. If it's not Tcl OK, you return it. Or if you see that it's an error, you return Tcl error, and then you go and do the next thing. It seems like when you are reading the Tcl code, it is dominated by the need to return two things from a C function. And so you return one in the interp, and you return an integer return code. And every little thing you want to do seems to take 3 to 5 lines. I'm not knocking John here. It makes sense when you're programming in C, but it makes the code a lot longer. You can see a lot less concise. How do we return things In Tcl, how do we return things in Rust? In Rust, you have an enum result, which is a generic type. It has two types you can plug in. The return type you really want, T, and an error type. That would be the exception class in Java or something like C++, where you have exceptions. It has two variants, OK, which has the return value you want, and error, which has the error data that you wanted for this particular call. Here's how you might use that. This is my version of a square root function. The standard library has a square root function that has a much better error type than this, but it could look something like this. Square root takes a 32-bit floating point number. It returns a result where the type you want is a 32-bit floating point number and the error type is a string. In the real standard library, that error type would have error codes and such like that in it as well. If you've got a non-negative number, you compute your square root and you return it using OK. I put the result : in there because with enums you usually do qualify them. In fact, result is used so often in Rust that you don't. You just say OK or error, and everybody knows what it means. So you can take the result : out. If there was an error, you return error. Here I just used I turned a string literal into a string value. Notice there are no semicolons at the end of those two lines. A block in Rust returns the value of the last expression. So this is an expression. This ends with a semicolon. It's a statement. If I put semicolons here, I would have to get the result value back and return it down here in some way. But if can return a value just like it can in Tcl. I did the same thing in that pattern matching code I showed you a little bit ago. How you might call this? Well, there's a couple ways. I could use the match operator as before, the pattern matching. I'm going to pattern match on square root value and see did I get OK and a root or error and a message and handle those like you see there. Or I could use the try operator. That's that question mark. Wish I had this further up the screen so you could all see it. I say let root f32 equals square root of value question mark. That says I am calling something that returns a result. What I want is the good result. I want to assign that to my variable. That's why I declared root f32 there, is to be explicit. That's what I'm getting out of it in this code, is the good value, not the wrapping result. And if it doesn't work, return the result and bubble it back up to the top. This is basically exactly what Tcl code normally does. The difference is I don't need a field in the interpreter for the good result for that data. It just gets carried by the result type that I return. And so all of those things that we're taking multiple lines to handle the result codes, just put a question mark on it, return result, and it's good. Here's what my result type looks like. Those of you who have done a lot of work with the Tcl internals defining commands ought to recognize this pattern. A molt result, that's a type alias, is a result that can return a value, one of my normal values, or a result code. The result code is an enum. It can be an error with an error message, a return with a value, whatever the return value was, indicating you're returning early. It can be a break or a continue. Those don't have a return value to go with them. And so I can throw an error just by returning that error result code, and it will bubble as far up the chain as it wants, just using the question marks, or I can catch it if I need to using pattern matching. Some of you, either if you haven't started scratching your head, you will in just a moment if you think about this. Where do I keep the stack trace? Where do I keep the error code that goes with the error? Any ideas?
I'm assuming that maybe Rust is magically doing it through a mechanism internally to
No,
So,
I just haven't done it yet. That's also on my list. Clearly needed. And then that value in the error variant would get replaced with something more specific for error handling, in which I could accumulate the stack trace past the error code and all of that.
Back in the return case, it would have to be the option stationary and all that goes.
Exactly, exactly. Here is how exit is implemented in Rust. I pass in the interpreter as a mutable borrow. Notice that underscore at the beginning of the interp variable name. That means I'm not actually going to use this. It has to be there. The lint checker, don't complain about it, but it, and it's an interp, so we give it a name. I could just call it underscore because I don't need it here. I pass argv, which is a slice of a vector that has the arguments in it. There is really there are multiple ways to define commands using molt. Some of them include a way to pass something like the client data pointer in, but you don't often need it. And I'm still working out quite how I want to do that. But there is a way to do it. Here I don't. So this one doesn't use it. And it returns a molt result. First thing to do, it calls check args. This is a combination of Tcl' wrong number args with the logic that says, how many of them do you need? And it just says, well, how many arguments did we get? Great, let me format up the return code because you screwed it up. The error message, question mark says, oh, if it returns the error, it goes, otherwise it's going to return nothing for its good type, and so I don't need to look at it. So one line instead of at least three. Then I'm going to say, let return code if argv_len equal 1. If I have one argument, it's 0. They didn't give me a return code. Otherwise, I'm going to ask for argv1 as int question mark. And it will give me the integer if it's there, or it will bubble up. One line. And then, of course, we call standard process exit. And we cast that return code, which is a 64-bit integer, to a 32-bit. Program dies. So as you can see, much more concise. Much more concise. I like that. How do we build applications and extensions using Rust? And this is the part I didn't expect. I thought I could do the other stuff that I've talked about already. This is where it starts getting interesting. This is the killer feature. This is where we say goodbye to Rube Goldberg. The Rust ecosystem. First, you have Rust Up. That's the app you use to download the Rust tools, the compiler and the other related tools, and keep them up to date. And it will let you get the current stable version for your platform. It will let you get the nightly version. There are other possibilities as well. I usually have it install both of those, and I only use the nightly very, very rarely. I usually use the current stable. It has other features as well. Cargo is the Rust build tool. Think of Maven or Gradle or what have you. We'll talk about that in a minute. Crates. Rust packages are stored in crates. It's cargo. So you can have library crates, like Tcl packages. You could have binary crates, by which they mean an application you can run from the command line. Every package that's going to become a crate has a cargo.toml file. Everybody familiar with toml? Anybody not familiar with toml? That's Tom's own markup language. It's basically a glorified version of WinINI files, and why they picked it, I don't know. But it's functional enough. It extends Win-style INI files to be hierarchical if you want that. But that's the crate manifest file. That's where you define what your crate looks like. How many of you have used Maven at some point? This is nothing like Maven. You can all heave a sigh of relief. And then crates.io is the standard Rust package repository. If you're doing open source work in Rust, you can push your packages to crates.io and anyone can use them. And that includes both library and binary crates. And Molt is on crates, the initial version is on crates.io if anybody wants to try compiling with it. Here's how you create a new application. You say cargo new hello. It creates a hello directory and populates it with the minimum requirements for a hello world. And if you can immediately CD into it and say cargo run, it'll tell you what it's compiling. It's compiling it in debug unoptimized mode, and then it will run hello world. So you get a working app immediately. You can also create a library crate. A binary crate can have a library crate in it as well, because usually you write your app as a minimal starter that calls into your library crate. Cargo lends itself to test-driven development. There's a way to include tests in your Rust source files that is non-intrusive but useful, and so you can say cargo test and it will test all of your code. It's pretty sweet. Here's what the initial manifest looks like. My package has a name, it's got an initial version. Rust packages use semantic versioning. Your author, I don't know quite how it picked that up, but it put that in for me automatically. I must have configured it somewhere. Which edition of the language? There are currently 2 editions. The compiler supports both, 2015 and 2018. You want 2018. And then any dependencies. At present, there are no dependencies, but you would list additional crates that you wanted to compile in. And then the main routine is just fn main, println, hello world. It's in the source folder. Suppose I want to create a vanilla molt shell. I just want a shell app I can start up and type at, like I showed in the slide earlier. My cargo.toml looks like this. I added 2 dependencies, molt 010 and molt shell 010. And like all of these package management systems, that's really saying, I want 010 or 011 or 012 or what have you. It'll pick up the latest in that series. Molt is the core interpreter. Molt shell is an additional crate that has the logic for creating a shell interpreter. Here's what the main looks like. You'd have to go look online in the molt sample repo. I'll have a link to that at the end of the slides to get the use statements at the beginning of the file, like imports or includes. But this is the code. I get the command line arguments from the standard environment. I create an interpreter and put it in a mutable variable. I can add any commands that I want. And then if I have more than one argument, well, the first argument, of course, is the interpreter's, the executable name. So I can call molt shell : script, pass in the interp and the other arguments. It will go try to load the script file, pass any other arguments to it in the argv, arg0 in the normal way, and execute it, and then it'll terminate. Or I can, if there are no arguments, I will call the REPL and get an interactive shell with that prompt. And you can type things at it in the normal way. There are some niceties of standard Tcl that I haven't implemented. For example, I don't have run this script and then meet me in the REPL, which you can do. I don't have a Tcl shell RC file at this point. Haven't needed one yet, but you could add all of those things. May I say, this is a heck of a lot easier way to create a shell interpreter than it is using standard Tcl, where you need to go copy the shell interpreter routine from wherever it is in the code base and edit it to do what you want. It's much less code, and you can fork the sample and use it. Suppose you want to add commands to that. Well, there's a molt command function, command square, computes the square of a number. I didn't put the logic inside it. It looks exactly like the exit command that you saw earlier. And I just call it interp.add command. Here's the name function pointer. Now we've got a square command. And that's if I'm doing it, in this case, as part of the application. Now, suppose I want to write an extension, a molt extension that does binary code, binary commands, but may also want to have some Tcl commands in there. I want to load a Tcl library. Similarly, I got double. It's going to double a number. I use interp.add command to add that, just like I did. I have an install function. You can do it any number of ways. This is the pattern I picked. The extension defines the install function. You pass in the mutable interpreter. It adds its commands to it. And if they need, any of them need context, as I say, there is a way to do that. I'm not showing that here. But notice this line here. This is saying the include string macro is a standard Rust macro. It's part of the standard library. It says, find this file in the build tree relative to the command, the source file I'm compiling, and include its text into the compilation unit as a literal string. And then, of course, I'm passing it to interp eval, and I'm returning whatever the result I get from that to the caller. I could equally just call panic if it failed, because, you know, really, my library that's compiled into my app shouldn't be throwing errors. And loop.tcl can contain any molt code that you like and define any commands that you like. It will just get executed when you install this stuff. Okay. Bottom line, I can build binary Tcl extensions, library crates that extend the molt interpreter. I can push them to crates.io, and anybody who wants to use molt on any platform can add them as a dependency and put them into their app with basically one dependency line in the manifest and one line of code in their Rust code, without worrying about configure, autoconf, make, and all of this crap. I can build library crates that include Tcl code, basically star kits. And it's a third-party macro, and I've not actually tried using it, but it's clearly doable in principle, called include-dir, that you give it the root of a directory tree in your source tree, and it pulls all of that in and presumably gives you some kind of virtual file system access, not as files maybe, but to access the data. So that there is a way, if you have a whole bunch of code to pull in, you could pull it in. So you got star kits. You can build all of that into an application that have most, the extensions and the Tcl code. You've got star packs. You can distribute all of them through crates.io, and it's all piggybacked on Rust's normal package management system, and you don't need to add any other tools to your tool chain. And it takes a couple of minutes. I mean, it is trivially easy to do. And they will run at least on Windows, Linux, and Mac OS. Speaking as, in this area, kind of a hobbyist programmer, I think that's really pretty damn cool.
Will it run on my 2004 Mac OS 10.2?
I haven't the slightest idea, but gosh, I doubt
It's
it.
important because that's the last big engine processor that I have access to.
I have no idea. I honestly have no idea. I won't say that it won't, but I'm kind of thinking probably it doesn't.
You should get together and try.
Yeah,
Okay. So LLVM is the only compiler.
yeah.
Okay.
It just works. If LLVM can target it, it'll probably go.
Okay.
The more, I'm not an expert in that area. I have to take that on faith. Current status of molt. I can do script execution in an interactive shell. I'm not going to try to do a demo here, although I could. But if any of you want to see that, just come talk to me and I can show you. I mean, it's a shell. You type Tcl commands at it and it executes them, you know. It uses the real Tcl syntax. I have been testing it against Tcl'8.6. To some extent, I've been, you know, whenever there's a question, I go see what standard Tcl does. And I see David Simmons looking at me, or I can imagine that he must be wherever he is. I don't have the splat operator yet. As I said to Kevin, yeah, I'm planning on adding that soon for some value, some number of O's in soon. It has lists and expressions. The list syntax matches Tcl's That was trickier than I expected. Has procs, it has all the normal control structures except try. Has catch though, it has the catch command. Has a test harness and test suite that are not exactly Tcl test compliant, but are very similar in flavor. And a fairly minimal command set at this point. There's a lot more that you'd want to have. Expression parsing in particular, I basically took the Tcl'2019 expression parser, and that's the one piece of code from one of the other interpreters that I just took and duplicated as close as I could, because otherwise my mind started to boggle. I have added the EQ, IN, and NI operators to it, and most of the functions are not implemented yet, and you can't define functions in the mathfunc namespace. There are no namespaces in Rust, or in Molt yet. May not be anytime soon, because I'm looking at this as an extension language, not an application development language. And while I'd like to have namespaces, because they make some things easier, cleaning up from tests and things, they're not a priority. I don't have arrays, gotta have arrays. You got a scripting language with associative arrays, you can basically do any damn thing you please. Don't have dictionaries yet, don't have namespaces, don't have traces. Traces would be easy enough to add, I think, but I don't have a need for them myself. I would like to have ultimately all of the normal return options, have stack traces and error codes and all of that. Lots of commands to be added, maybe some kind of packages. I don't have an autoloader. I do not intend to implement the autoloader at any time, but I don't have any kind of Tcl packages either. I'd probably be inclined to do something much simpler, more like Jeff Hobbs' Tcl modules, Jeff St. Andreas' Tcl modules, rather than the whole package requires syntax. Because the way you manage packages with this system is you just get your dependencies from Rust. And you only really need some other notion of Tcl package if you want to load them at runtime. So it's not as important for this. Some kind of objects, at least something cognate to namespace ensemble. Some easy way to create ensemble commands would be essential for this. So what's next? Parsing expressions to internal form using a kind of parse tree like I showed for scripts, so that everybody, all the parsing code in the app can be in the same page. Splat operator. There's more things I want to do with the value type. You can write what's called unsafe code in Tcl, just like, I won't go there. You can declare a function or a block code unsafe, and that lets you do pointery things. And it's up to you to make sure you got it right. I have a little bit of that in the value type, and I'm thinking there are some higher level abstractions you use to avoid needing that, something called a ref cell. And it's slow, and I think I can probably get much better performance if I just embrace the unsafe inside value and make it work. I may also want to go not to a two-legged stork, but a many-legged stork where whatever whatever data rep I get, I just keep it. Memory leaks galore. Regex, additional commands. Regex is an optional feature. There's an easy way when you're building a Rust crate, and when you add a dependency to a Rust app, it downloads Cargo downloads that crate and builds it. Everything. Static linking is an idea whose time has come. Honestly, we avoid DLL hell. So it's really easy to specify in your dependencies, I want this crate and I want these optional features. And so I could say I want regex, and everywhere in the code where you could use regex, it gets added in. I don't really like that way of doing it. I'd rather just make it a separate set of commands, but regex, as we all know, is so embedded in so many things that that's hard to do. File handling is an optional feature. Got to have at least source, but you don't need to have the file command and the channel commands and all of that for a lot of things that I would want to use this for as an extension language. Don't make them buy that. They can add that probably as an external crate that they could add in when they need it. Namespaces, I don't know. I like being able to put things in their own namespace.
Well, I was just gonna say, this is, when we get the finish.
I'm almost done.
Oh,
So
lots
just
of questions.
hold it for one more slide. If anybody finds this interesting and would like to help, there is lots of low-hanging fruit. And I have to say, despite all the cool things, I'm not saying, gosh, everybody in the Tickle community should drop what they're doing, adopt Rust, and start working with my code. It's not ready. It may never be ready. It's just my own personal project. But if anybody in the community is interested and wants to see it succeed and they would like to work on it, come talk to me.
Where is it and how is it licensed?
It is at GitHub, github.com, wduquette/molt. This slide deck is will be on your memory sticks, or you can just ask me. So it's there, and of course it's a BSD license. What else would I do?
Public domain?
No, I'm not as good a manager.
You have sense. Are you ready for questions?
I am actually, but I want to make one more point that I would have shown if I'd done a demo of the interpreter. There is a lovely Rust package called RustyLine that gives readline support that is not, GNU licensed. And so one of the reasons the Molt shell code is in a separate crate rather than in the core is because it has RustyLine as a dependency. So every Molt shell gets the readline behavior that really should have been in Tickle shell 20 years ago if it weren't for Richard Stallman.
All right, so have you read my page on, because I get a lot of pressure to translate SQLite into Rust.
Okay.
And so I have a web page, and I list 6 reasons why I'm not doing that.
There are probably really good reasons not to.
And I just wonder if you'd be interested in hearing these and addressing them and saying that that's nonsense, Richard, or
Let
maybe
me-
a good reason. Or maybe we should take that offline. Maybe
Let's see if there are other questions first.
Okay.
But yeah, I'd be happy to talk about it. And I have to say, I am still at best an intermediate Rust programmer. I've done a significant piece of work in it. I am by no means an expert.
It's sort of related. I'm not sure how directly related it is. Does this open the possibility of writing extensions in Rust that run in the C Tickle interpreter, Tickle core interpreter, using a lot of this machinery, the way that you're implementing Tickle quantum Rust?
It is certainly possible to write apps that include both Rust and C. Firefox is increasingly being written in Rust. They're kind of migrating it one area at a time. And so I think in principle, it could be possible to do that. I have absolutely no interest. So.
And the waistline of the data structures are more to make it simple, to make this like a Rust in Tickle, as opposed to actually supporting the various and sundry ways the Tickle extensions can do evil things. So that would be a separate project, and be a completely different data structure.
It's much easier. It's much easier, I think, to call Rust from C than it is to call C from Rust.
And if you wanted to call Rust from conventional Tickle, it might actually be interesting to call it from quadcode, because quadcode's object code is a lot more like Rust's than C's.
At some point we've got objects and namespaces and dictionaries and things on the to-do list. Any thought of perhaps avoiding namespaces completely and just going with objects and then implementing dictionaries as a special type of object?
May I just say that to-do list should be regarded as potentially fictional? Because it's a wish list. It's a list of things I intend to think about eventually if I can keep my enthusiasm going. on a succession of Saturday mornings. And eventually there are things I would need to think about how to do. I am certainly not sold on doing it exactly the way it is in Tcl. I have heard Donald talk about how variable resolution works.
You haven't, it looks to me like Rust has some object orientation, but you didn't mention anything about the class object model.
It is
You're
not
able to say that.
object
It's not,
oriented
okay.
at all. It has structures which can have methods. It's a lot like SNIT in some ways. And types that are structures, all types, can implement what are called traits, which are misleadingly like interfaces in a language like Java. And again, it's one of those resemblances that leads you astray a bit. You can, when you're doing, you're saying a generic function, this function takes a type T, there is a fairly complex syntax you can use to say, T has to be a type that implements these kinds of traits, but maybe not those kinds of traits. One of the guys I work with, who's a functional and logic language geek, says it's kind of cognate to Prolog. Actually, it's a way of logically specifying what can go here that the compiler understands. They actually have a Prolog-like model language they use to model it for compiler improvements. But basically, I'll get to you. Basically, you can define methods and you can define traits on them, and then you can pass things to things that require things that have those traits. So it's object-based in a sense. We can talk more later. Peter?
A good deal, probably most of the Tcl extensions that I have worked with and written are basically glue to libraries that already exist and are already in C. Is any of this applicable to that stuff?
Well, certainly you can do wrappers for libraries that are already in Rust. I think that ought to be clear enough.
Yes.
Because you're doing that with the standard library. Rust can link in C code, and so you could conceivably find a C library and work out how to link it in with your Rust app and have commands written in Molt that address it in some way. I know that that's doable. Again, I've not explored that because, I've given that screen. I won't do that again. But yeah, in theory, you could do that. I don't think I would, but it would be a really boring world if everybody were me.
So I'm curious about Rust's types and type inference. So I work in OCaml, which is one of the major inspirations for Rust.
Yeah.
But my understanding is Rust's type inference is weaker than OCaml's. And
I can't speak to that, but it wouldn't surprise me.
yeah. Well, yeah, we can talk about it. But so in OCaml, in the MLs, and Haskell as well, because they use the same type inference, there's this tendency, because the type inference is so strong, to push as much logic into your types as possible. And you start sort of relying upon the compiler to help figure out the logic of your code and all that. And I was curious if you have any experience with that in Rust. Rust encourages you to push more and more into the type system.
I would say it probably does. You can write very C-like code in Rust, modulo the borrow checker, and having to satisfy it. You can also write very Haskell-like code in Rust. And one of the things you often see is, I call, using a fluent style, this dot that dot that dot that, doing a pipeline of things, streams and such like on iterators, where they become very long because if you define intermediate values and then call those, you're getting the borrow checker involved. Whereas if it's just passing the value from one function to the next, the compiler knows that, that's never going to be abused because it's never seen publicly. So yeah, there are a lot of places where you could write a standard loop, or you could just do a fold, if that's what floats your boat. I am insufficiently camelish to be entirely comfortable with that yet, but some places I do that. Okay, and we have 1 minute. So Richard, I think, is gone. I will have to talk to Richard about his issues after. So, anything else?
I was just, this looks like a great sandbox to actually try some ideas that people have always had about, hey, let's rename the list command, or let's, and actually be able to see how it works without having to, it looks like a user-friendly way that we could actually play with what is Tcl in the sense of,
Let me say this about that to you. Fork is your friend, and I know you. So feel free to submit any pull requests you like, but expect pushback. And third, if you change the list commands, I will cut you. List space whatever is too damn long. I don't want to go there. I keep hearing it suggested. No. I would be more inclined to go to S equals S match, S compare than I would be to go the other way with this. 10:30. I'm impressed. I did it right on the money. So I'm here till tomorrow about noon. Anybody wants to talk about this? I am always happy to talk about what I'm doing.
Thanks, Will.
I'd also like to say, having come to the conference for so many years, I never expected to be giving a keynote. Thank you for the opportunity. It's the first time I ever got to say everything I wanted to say.
All right, it's 10:31, so I'm going to abbreviate the break by 1 minute to 14 minutes, and we'll resume at 10:45 a.m. Thanks. Break begins now.
Hold on. I brought my coffee over here so I could drink my coffee when I got thirsty. You wind me up and I just keep going. If you're Rust, I had enough of the spirit of at the moment, event you said.
I sent it last night. Yeah, but. Oh, no, I don't do. Yeah. So,
Let me just read.
I actually found it, but I saw the algorithm for
You have a great opportunity because of all of the, I got everything in the rough. Yeah, I gotta say, I'm doing this on my own time, and the older I get, the less time, creative time I have outside of normal working hours. I don't know that I can easily shepherd this into something more. I mean, if I were writing an app that I wanted this, I would add it to the make sure that that is how sweet it's working. Yeah, if I were going to rely on it in production, if I want to get all of the nifty details in, especially if you want it to be performance. I mean, at its current speed, it would, even if it had all the features that flight awareness.
It's difficult because I have to remote desktop.
It's not anywhere near fast enough for that. They need help. They need help to get there, and I'm more of the cabinet maker who works in the shop on his own with maybe an apprentice than I am the big team. So for this to get to the point where it's not working production.
No, that's part of the shell. That's not in the core at all. That's an application defined. Common question. Lots of people like this. Yeah, well, that'd be a good open source project to do that. That'd be really cool. That'd be really cool.
But it wasn't working.
Again, I don't have a budget.
More that are, more that you actually
There's lots of other things.
can't do it. But I think
I know.
I cannot decide, see, Rust, this is the thing, Rust is all about doing as much as possible. And then you don't do that kind of stuff.
You could translate it to Scala. Scala would be perfectly happy to completely optimize it. And if you want to do Scala data, it would be
No,
I did that with our.
not gonna do that.
So Tcl'2019 compiles not to a bytecode, but it compiles to JavaScript functions that just actually perform the work that needs to be done in an array, and it just runs through the array and calls function. And I get to a side factor 3 from the C Tcl information as well. Have you looked at Tcl'2019?
I have not.
I love this. It's basically, you made exactly the same choice I did pretty much every.
I saw you grinning the whole way through my talk.
This could have been, I could have used these slides just about in some syntax trees. If you use the same command, it's governed the same way.
Funny.
It looks almost exactly the same to define the typical command.
The issue I've got is figuring out how to handle that client data pointer, defining an object command that needs its state or an extension that needs its state. I've got a couple of ways to do it. I'm not entirely happy with either of them. Well, one way to do it, and there's an extended version of a command actually is not a function. It's what's called a trait object. In Rust. So you can define a trait object that has the method that's executed, and it can have any additional amount of data. If you want that data to be mutable, you need to use what Rust calls a ref set. Or at runtime, you can say, I want to borrow this mutably, make this change, and then let go of it. That's slow. It works, but it's slow. So when I call that import that command, it's taking that function and wrapping it in a trait object that just knows how to call command functions. And that's probably adding some slowness as well. I have another way to do it. You can define a context in the interpreter where it can be of any type, where your code can then say to be mutable interpret and that context object, and then you can work with it and just put that. But it doesn't get cleaned up properly.
This stuff is actually surprisingly robust.
So what I want to do is add a context argument to basically all of the commands, and have a way, whether I am defining a single command with object context or an entire extension with context that shares,
That's just
that it will get cleaned up.
You have something about
I'm not quite there yet.
That's the small.
It's a sandbox escape contest. I mean, I can give them prize, I guess, but I mean, not anymore.
I mean, you have hard, medium.
Oh, you
And Cold Stone is very Rust
Yeah.
like somewhere.
They did one of the things that was
That's a good point. Yeah, that's a good point. Now that they so
There are ways
the
to
French
do
machine
it. They're blind.
one of my
It's not try tree. There are things you can do to do additional stuff.
Take that out, we pull
I know
off.
it exists.
So that's not, it's kind of crap, like, yeah, it's not, I mean, it's fine. We'll give it something.
It's a fine class, yes, you put no cat.
Order of magnitude. I know that all of that was
That could be an issue in Rust. I have actually been kind of impressed with how far I have been able to get without having to do arcane things like unsafe code. The only place I currently have unsafe code in the system right now is in the code that wrote in my value type, where I convert an arbitrary data type that has the right traits that I pass in, and I try to get it out again. I have to see whether I got one, and there's a little bit of unsafe code there. But most of the things I've been trying to do have fit pretty well into Rust's borrowing. I think that's probably a tribute to John and how we designed Tcl to begin with, so that you could reason, the internals you could reason about them, not go nuts. Swift, I know that it exists. My goal is that I've not ever done any professional work targeting acronyms. And I don't think I trust Apple. Well, there you go. But if you're relying on, that's the thing, anything I'm doing outside of my professional life, I want something that I think is probably going to be still running if I come back in a couple of years not looking at it. And I don't trust Apple for that.
Yeah, kind of a silly thing.
I ought to put my fourth interpreter.
Oh, yeah, that sounds really good.
I wrote a fourth interpreter as an extension before I'd ever heard of Tcl.
Yeah, that's what I was using for extension.
Yeah, and it was for C code, and I had a way of scanning comments in C code so that the fourth interpreter would build knowing where the functions were, so that you could actually call most of any functions you wanted to in your C code from your interpreter. It was as unsafe as I'll get at.
6 points of dark.
It was.
6 points of
That
dark.
wasn't the original idea.
Okay.
Did
you see them?
No, I haven't.
Are you on a station, Ron?
I have not a station. Yeah.
That had at a low level.
Actually, wasn't trying to decide if I'm do
Exactly.
work in progress or not.
Console command. Executive, they call
I
it.
have to see if I still remember
Do things with the right
last
action.
type progress.
I was writing a program.
Unfortunately, it's a good thing I put in
That's
Windows services for Linux last night.
So I was actually.
The guy that shipped me my work in progress handed me a fireball.
It was a process that controlled multiple smaller C programs and we were sending courses back and forth.
Start packing, start
More and more, and now it will be great. Okay.
I might take a look at it, that is, like,
I don't
you know,
expect
just
you to do it.
the interesting thing about the API is I'm not an optimization guy, and architecture and interface. I like to build tools that are easy to use. Richard, have you rewritten your laptop? Turn it up on the web browser.
Yeah.
And if you're going to order get the H1.
Oh, he's right there. That's good.
Yeah. We're going to restart?
Just the round. Shoot.
That's everybody.
Crap.
I don't know what the okay, no, then we're not gonna go off.
Everybody, please start heading back to your seats. We're going to start in 2 minutes. 2 minutes.
I gotta get back on IHG. For some reason, it keeps wanting to have the Xfinity Wi-Fi. So, it's too bad.
SQL.org.
Yeah, let me look at this and we can talk about it. I listed 6 injections to Rust. I'd love to hear what you have to say about this. Well, in terms of ecosystem, I invited the Rust stations to say, hey, maybe wrong, nobody's, and this hits Hacker News once a year or so. Creates a story. But no Rust stations.
So you have a PhD.
PhD is, yes, I have a master's degree in
All right.
PhD and
Really? All right.
never done the first.
Never did any of that.
Are you doing that?
Let's get going. And I'll put a number of decisions that they made. And I just said, it may be a very cool place.
Okay, everybody. We're going to continue. So our next speaker really needs no introduction. Richard Hipp is the inventor of SQLite or SQLite, one of the most popular pieces of software in the entire world. He's also developed many Tcl tools, including Table Widget, HTML Display Widget, MK Tcl app, and do you call that Toby? The Tcl in one build environment. He has a master's in electrical engineering from Georgia Tech and a PhD in computational linguistics from Duke. He was a founding member of the Tcl core team and is now one of the emeritus members. He's presenting on Wapp, a simple yet powerful, secure, and robust framework for writing web applications in Tcl. Round of applause, please, for Richard Hipp.
A memo, from now on, I'm going to get Carl to come with me when I give talks, and he's going to do the introduction. I've never had such a kind introduction before. All right. Oh, there we go. Great. All right. So, I'm not a web developer. Can you hear me okay if I walk away from the microphone?
Yes.
All right. So I'm not a web developer. I do other things, but everybody these days, you got to write web pages and dynamic web pages, and I'm thinking, and that can be hard to do because you typically have to get a big framework, and you got to learn the framework, and you got to learn all the ins and outs about it. And I was finding that uncomfortable because there's a lot to remember that I didn't want to remember. And I thought, well, think about what Tcl really does well. I mean, if you look at the build process for SQLite, for example, I've got a bunch of Tcl scripts that do code transformations. I could have done those things as C code or Rust code or something else, but it would have been much more complicated. It's very easy to write utility programs in Tcl. So why can't I do web applications written in Tcl to make them very easy? And so I put together this thing called Wapp, or short for web application, which is ability to do Tcl applications that are very easy to build, very easy to maintain for a long time, powerful and secure. There's a web page there. I'm not going to go over the details of how you use this. I'll briefly review it. Most of my talk is to motivate you for why you might want to take a look at this. So why you might benefit from using Wapp if your primary job is doing something other than developing websites. Bear in mind, Wapp is not intended to build sites like flytaware.com or rubylane.com or something like that. It's for little small things that you just need to get done. Just as you wouldn't normally you wouldn't write a compiler tool chain in Tcl. Tcl is a great language, but it's not really appropriate for that purpose. In the same way, you wouldn't write a major website in Wapp. You want something that's simple to program, because when I'm putting something together, I don't want to have to learn a big API just for that. I want it to be very simple, something I already know. I already know Tcl. Maybe you need small accessory apps for a much larger website. I'll give you some examples of how this works later. Or you want to embed a web-based command in a larger Tcl application. Suppose you've got a big Tcl' app that's running. Maybe you're controlling a nuclear physics experiment or something. I don't know. And you want it'd be convenient. And Tcl's controlling this. You've got a big blob of Tcl that's doing it, and it would be convenient to monitor what it's doing by pointing your web browser at it. You can drop this library in here, and that's really helpful. And then also the web has become, people are trying to break into your website all the time. There's all kinds of attacks. There's cross-site scripting attacks. There's, I don't remember all the names. There's a bunch of them. And you want your website to be secure, and Wapp helps you to do that. It's designed to be very easy to learn. This is its focus. Very small API. The idea is that the entire thing fits on one piece of paper, an 8.5 by 11 piece of paper. You can read the instructions. And once you understand it, that's all the mnemonic you need to actually be productive in it. Hello World is 6 lines of Tcl, 2 of which are the shebang and the package require. Generic Tcl shell works fine. You can be up and running in less than 5 minutes. And one of the cool features of this is that the application you build with Wapp is cross-platform. You don't have to be tied to a particular web server or any web server at all. So for example, you have the same bit of code, and you can just type Tcl shell myapp.tcl. And with no other options, it automatically pops up a web browser and makes that web browser point at your application. It has a little built-in web server itself that it runs. Or you can specify a TCP port, 8080. It wouldn't be nice if you could just specify 80 and we didn't have the Unix restriction of, is that really giving us any security that you can't specify low number ports?
No.
Isn't that kind of obsolete? But anyway, give it a port number and it'll put up a website there. If you want to run it under like Nginx, which doesn't really support CGI, last time I checked, has that changed? Can you do CGI on Nginx? Does anybody know? Is there a plugin for it now? Last time I checked, there was not, but that has been several years. It also supports SCGI, which you can do with Nginx, or you can just make your script an executable, put it in your CGI bin, and run it as CGI. So you have lots of different options on how to run it, or you can actually take the file, put it into a larger Tcl program, and run it as part of your larger Tcl program. So how is this useful? Here's some examples of where I'm actually using it. If you go to the SQLite website and click on the search menu and enter a search term, and you get the page of search results, that is powered by Wapp. This was originally done, it's always been done in Tcl. It was originally 353 lines of Tcl, where I had imported bits of the Tcl live to process the CGI, and it had bugs, and I kept getting people saying, oh, there's a vulnerability in your search menu and so forth. So I rewrote the whole thing in fewer lines of code, and it's now secure and doesn't give any trouble. An example of the use case here is that, I want to put that search menu there and just forget about it and leave it for 10 years. I don't want to have to constantly maintain that thing, which is kind of the purpose of Wapp. Tools that you don't want to have to maintain. Another thing on the SQLite website, if you go to the checklists, we have a release checklist that we do for each development cycle. And I've got this thing where you can go and click on the different checklist items and mark them off, or say, oh, that item failed, and so forth. The development releases, or the testing for development release is about 3 days of work for the team. And so people are testing different things and they're marking them off as we go. This checklist application was originally 1,700 lines of C code that were hard to debug and didn't do a whole lot. I rewrote the whole thing in 553 lines of Wapp. I added new capabilities using the XML HTTP request stuff. And now it's also cross-platform. It used to be only CGI, and so it was hard to develop because I had to upload it to a server to test it out. Now I can just test it out on my desktop while I'm developing it. Ginger and I have our own private little website here, and so when Ginger sends me to the grocery store to buy stuff, she puts things in this little application, and I could be in the grocery store buying things, and I mark them off, And then Ginger's at home on her iPhone, and she says, "Oh yeah, pick up something else," and it just appears on my list. And this is an incredibly useful thing. It's just a few less than 200 lines of Tcl code. It's nice to be able to throw together little applications like this. I'm sure there is some commercial app for iPhone that lets you do your grocery lists so that you and your spouse can do this.
Alexa, add coffee to the grocery list.
Or something like that. Yeah, but then do we really want Jeff Bezos knowing what I'm buying at the grocery store? I mean,
He knows everything else.
I just don't know. So I kind of like to grow my own and have my own little infrastructure here. Sometimes you just need a little script that does something. Over on the Fossil website, I've got some examples of showing Fossil with lots of different skins. This is kind of like a file list on the website, but I wanted to put some additional text onto it and stuff. And sometimes you just need a little script to do this. So this is 28 lines of code, about half of which are just the text for the header up there. And then it loops through and looks at all the files in the directory and gives you a link to them. And sometimes you just need a little script like that that's going to be secure and it's easy to maintain.
Richard?
Yeah.
So you're using HTTPS. What do you do about certificates?
Well, now see, this one is running. That's running on a larger web server. This is running a CGI.
Okay.
So if you want to run it standalone, I tried to figure out Tcl'2019 and I can't get it to compile reliably or to use. So, yeah, if you want, so this is running CGI on a bigger web server, and the bigger web server takes care of the translation for me. Yeah. Yeah, it'd be great if we could get Tcl'2019 kind of really going. It'd be great if TLS was part of the core, don't you think?
Yes.
That would be really cool. So if you're working on SQLite and you want to run our Tcl test, you can do just from a SQLite checkout, you can do Tcl shell test, Wapp test, and up on your web browser pops this little screen, and then you click start test. Actually, it's running here, or you can press stop test to stop it. And this is how we do a lot of our testing now. Dan did this. It's written in Wapp. So we've always done our tests have always been Tcl driven. We always have a big Tcl script that run the test. But it's really simple to just drop Wapp in the middle of that, and we have a web browser console that shows us the progress of the testing, since that takes 8 hours or so to run. So what does a Wapp program look like? Well, here's hello world. If you create a file hw.tcl and put those 6 lines of code in there, you've got an application. Now, I said source wapp.tcl because otherwise you'd have to figure out how to get package required to do its magic, and that's always bewildering to me. But it's really 4 lines of code. It's giving you a procedure to run when a web page request comes in, and then you start it up, and then you just type Tcl shell hw.tcl, and this will pop up on your browser screen. Or you could say Tcl shell hw.tcl and use one of those other options to run it in a different way. Or you could throw it up on your website and it would run on your website. Here's a slightly more complicated version of the same thing, hello world, but I've added another page down here. I've got Wapp page env. And what this does is that if, after the name of the script itself, if you put another term on the URL that says env, it'll run that procedure rather than the default. And that procedure goes through and prints out all of your environment variables, which is a kind of a useful thing to do when you're debugging your web application. It's so useful, in fact, that, well, what are the inputs to a web application? Let's talk about a web application a little bit. You've got kind of four ways that you get stuff to your web application. There's CGI parameters, or the CGI variables. This is what the web server is telling you was in the header of the HTTP request. There's query parameters, which is the stuff that comes after the question mark in the URL. There's post parameters, which are the decoded stuff that's in the payload on a post request. And then there's cookies, which are extracted from the header. These are kind of your 4 inputs. And Wapp tries to keep things simple by putting all of this stuff in a single namespace. You don't need to know where any of this stuff is coming from. And there's a Wapp param, give it a name and the default value, and it returns the value of that thing. You can get a list of parameters, tell if the parameter exists. You can set a parameter. I'll talk about the fifth thing down there in a moment. So CGI variables, if you've done programming on the web, you know about these, base URL, document root, and there's a few others that Wapp actually adds to its own. They all have to be uppercase. Query parameters have to be lowercase. And the reason for that is we don't want somebody to put a query parameter on a URL string that impersonates a CGI variable, because that could be a security problem. So Wapp has no way of accepting query parameters that are in uppercase. It also rejects all the query parameters unless your request is coming from the same origin. If it's the same origin request, or you can say Wapp allow cross-origin parameters. And this is a security feature. It's a little bit annoying, but we have to do that for security. All the parameters are automatically decoded. The encoding is escaped, and so you get exactly the text that was intended. Post parameters are the same way. They're automatically decoded. It understands XWWW form URL encoded or form data, both forms. They both come through. And again, lowercase only. And your cookies come out. They have to be lowercase cookies, just to avoid security problems with people trying to impersonate CGI variables. It's all in the same namespace. This is the total API right here. These Tcl' commands are the complete and totality of the interface. So if you print this out, you kind of know what you need to do. I took the liberty of using a minus sign rather than an underscore in the names of the Tcl' procs, which seems a little odd, but I can hit a minus sign without having to hit the shift key, and that allows me to type it a lot faster. So this runs as both CGI or as its own server, or if it's running a CGI, every request is going to fork a new process, a new instance of Wapp, and so there's no persistent state. There's a separate process for each request. That gives you high concurrency. You can actually put this on a website as CGI and really hammer on this thing. It'll serve a lot of data really fast. But it has a higher startup cost because you have to spin up the Tcl' interpreter every time, but it gives more security. Every address instance has its own address space. Or the other modes where it's running as SCGI or the other, it's a persistent connection, and that means that you can carry information in Tcl' variables from one request to the next. On the other hand, it's single-threaded. You can only serve one request at a time, and but you have lower startup costs. So there's a trade-off there. There's a little bit of semantic difference between running CGI and server that you need to be aware of, but it's not that big a deal. The apps are mostly portable. Now, I've got this thing called Wapp Tcl' Shell, which is kind of Tcl' Shell, which I normally use. You can use just plain Tcl' Shell. The advantages of using Wapp Tcl' Shell is that it understands package required Wapp. It has SQLite 3 built in because it turns out that SQLite is a really cool thing to have in these little miniature applications. And it's all statically linked. And so I normally set up my websites inside a changer jail. And since it's statically linked, I don't have to worry about picking up all the right shared libraries. Unfortunately, the script-based commands are omitted from that, so I can't do the fancy clock stuff. Boy, wouldn't that be neat if that was built into the Tcl' library? Wapp really wants Tcl' 8.7 because it really, really wants to use the minus command option of regex. It will work with Tcl' 8.6. I have another formulation there that isn't it, but there's reasons why that doesn't work well. So if you want to do this, I'd recommend Tcl' 8.7. I've got a bunch of examples online. I put a bunch of examples on the website, and I was going to give you this list, and I thought, why do I have a list here? Why can't I just do a little Wapp app that lists them for you, of course? And if you go to that website, a lot of these applications they're all very small. Most of them have a little button on the side that says, show me the source code. And so the application itself will print out its own source code. It's kind of a cool thing. Helps you to debug. As Will was giving his most excellent talk on Rust, thank you, Will, I got this bug report. I got an email message. Somebody's telling me they're getting a 404 error on the Wapp website. What happened here was that I changed the primary URL from index.html to home, but I neglected to update some documentation someplace, and somebody was getting it was a busted link. So how do you fix this? I mean, I could go into the web server and reconfigure it so that it does a redirect for me. There's, most web servers allow you to do this stuff. But I thought, no, let's just throw a WAP app there in that spot that causes a redirect. So I just pushed that up there and made it executable, and that solved the problem. We did this moments ago. This is it. This is the perfect example of what you would want to use WAP for versus, say, a major website. So it's in wide use. It gives me the ability to write quick little web applications that are secure. I don't have to remember a huge API. I get the full power of Tcl', so I can write short little things that don't take up a lot of space. Permissively licensed, it's a BSD license. You're welcome to visit wapp.tcl.tk if you want to contribute. I will be happy to give you a developer login on that site, and patches and suggestions are welcomed. Any questions? Yes, Andreas.
Is it true that you get the full power of SQLite as well?
Sure. If you use like Wapp Tcl shell, absolutely, because it's built in. Or you can package require it using plain old Tcl shell. Either way.
Good.
Absolutely. So for example, in the shopping list app, of course, the items on the shopping list are stored in an SQLite database. How else would I do that? and for the checklist app that's on the website, I mean, we've got checklists going back, I think, 10 years. And of course, WAP has only been around for 2 years. So, but all these checklists, we've always stored them in SQLite databases. So when I redid WAP, the checklist in WAP, I just had to use the existing databases. There's no problem. Questions? Thank you for your attention, folks.
Looks like a lot of fun.
It is. Who's next up?
Kevin Canny.
Oh boy.
All right, our next speaker, Kevin Canny, is an old hand with Tcl. Did you go to the first event, Kevin, back at Berkeley?
Yes.
Yeah, he was there. That was crazy. He has a bachelor's degree, a BS degree in mathematics, a master's degree in electrical engineering, and a doctorate of philosophy in the realm of computer science. He's been writing software for 40 years. Is that professionally or is that total?
That's professional.
Professionally writing software for 40 years, so he's probably forgotten more than most of us know. 28 years at GE Research, and just a couple things that he's shared over the years or presented papers that I thought were really interesting. GE owns NBC, the television network, owned the television networks, and they made, Kevin and his people made, using Tcl and TK, a drag and drop interface where they would drag and drop all of the television shows and programs and commercials and stuff onto a timeline, and then the stuff would play out. They had to do a lot of heroic stuff because the Exynos application had to run like basically forever and not run out of resources that Exynos does run out of. So they had to do a lot of crazy tricks.
It was worse. It was Windows.
Oh, enough said. It was Windows. Yeah, Windows. Okay. So they did all sorts of heroic stuff to make the program never crash. Also, they did a project where they're scanning microscope slides looking for profiles of proteins in cells, and that is now actually a clinical test. So that's kind of amazing. And he's currently working on an in-process inspection system for 3D parts printing for aircraft engines. And a lot of us here from aviation and stuff, so they actually are 3D printing metal engine parts, and some of them are in the hot stage of the engine and stuff, and actually GE is shipping 3D printed engine parts in current generation engines, which I think is just amazing. Kevin's here to talk about something that's near to a lot of our hearts, which is mapping in general. And since Google got real expensive for the maps, there's been a huge interest in OpenStreetMap. And Kevin's presenting today, mapping the Tcl' world using Tcl' to curate OpenStreetMap. Round of applause for Kevin Kennedy.
Thank you, Carl. And what happened to the HDMI?
This one?
There it is. That's not got erasure. Maybe I'll sit down. There it goes. Okay. So, I don't need the mic, right? People can still hear me?
Yes.
Okay, well, I'm Kevin, and I'm not talking about anything that I'm doing for work. I'm a hobbyist. I'm a geek. Even in present company, I'm pretty geeky. I can't help it. I'm wired that way. Most of you know me, at least by reputation. I'm math geek, engineering geek, computer geek, Tcl' geek. Love Tcl' because it fits the way my geeky mind works. Now, a note here. When I submitted this paper, it was basically, going to be a talk about an interesting hobby project. And then I saw that there were an awful lot of attendees listed from ESRI. And I started feeling like the apocryphal story of the guy that perished in the Johnstown flood. And when he got to the pearly gates, St. Peter told him, look, you have to give a colloquium to get into heaven. And he said, well, okay, I've got very recent experience, and I think I can give a pretty good colloquium on flood control. And so St. Peter said, oh yeah, I'm sure Noah is going to be excited to hear about the latest developments in the field. So with a room with a lot of ESRI people, that's how I feel about talking about mapping. And so yeah, I'm a map geek. I love geography. I love mapping. I love to read maps, imagine the places on them, going to places and seeing them for myself, finding some little places that aren't on the map. I can actually have fun going out on a weekend and looking at a rock outcrop that I saw on Google Earth and struggling through the brush to see what the view is like. I have a seriously weird idea of fun. Friends have taken pictures of me on these trips, and astonishing number of them. I'm either consulting a GPS, reading a compass, or making field notes. Because mapping where I've been, I don't want to lose those places. I don't want to lose myself. I've been a map geek even longer than I've been a programmer. I've been infatuated with maps for not quite 60 years probably, but like as long as I could read. My life as a programmer goes back only 40 some odd years. And Tcl' and maps and computer imaging are all things that keep drawing me back. As a preteen, I was a proto geek. I can remember the New York World's Fair of 1964. And one of the things that I really remember clearly was that the New York State Pavilion had this terrazzo floor with a huge map of New York State, like nearly football field scale. And I was amazed that I could look on that map and see the golf course that was a block away from my house. and couldn't see my street, but I could see the street my school was on. I was amazed that there was anything at a scale that I was familiar with that showed up on anybody's map. And well, then once I joined the Boy Scouts, I learned about topographic maps that were at large scale and existed for a big swath of the country, and they did show my house, and learned about map and compass navigation, and even learned a little bit about making maps. And some people are still teaching it the old-fashioned way. I found a very recent picture of a group of kids being shown how to map an archaeological site with alidade and plane table and measuring tape, and mapping it basically the way I learned to map things. GPS really revolutionized that, because now you don't need a 4-person crew minimum to do that, because you don't need 2 people to handle the tape and 1 person to sight and 1 person to handle the sighting rod. I also remember when it became possible to download the CIA World Data Bank on FTP, and suddenly had vectors for like all the country boundaries, and had vectors for major rivers and lakes, and could produce maps of the world. Well, sort of. I mean, there were PostScript printers, and so I could do nasty code, probably C code, that would write a PostScript file that would eventually print a map. And but that gave me tools to do a bunch of fun projects. I hacked up a way to receive weather satellite photographs and overlay some map information to make sense of them. I was in various technology clubs when I was in grad school, and we did some various ambitious projects, visual tracking of spacecraft, and we even had a team that in, I believe it was 1988, launched a balloon payload to the edge of space. Now that's something that's really routine. You put a cell modem on the balloon, you launch it, but in the time, it was not something that amateurs did. You know, it required months of negotiation with the FAA to get the waiver to have uncontrolled balloon, and but actually managed to find a little play. No, I'm not gonna bother. Oh, there it is. Just came up on the wrong screen. There's a piece of ancient video with the balloon launching. It cocked Debbie on the head on the way up, and then so flying away there, and a bunch of geeks looking at their little screen trying to pick up the signal, and oh, there it is, starting to come in, and oh wow, pictures of the farm fields. It's up there, and that one made it about 100 miles. Busted the terminal control area on the way down. I mean, we had an FAA waiver, so we got air traffic control on a landline telephone and told them where the payload was. And well, my job on that project was tracking software. I would have loved to have had Tcl'. I invented all sorts of bad languages to do these projects. I had driven Ousterhout to despair with the amount of time that he spent implementing bad shells. Yeah, somehow I got my slides out of order here, but well, that's okay. Here's the next. So, yeah, prior to having the PostScript printer, I did some amount of mapping with line printer stuff, because a colleague of mine as an undergrad had a job with where his advisor had got this brand new program from Harvard called SIMAP that could produce thematic maps on a line printer. And this guy's job as an undergrad was that he would take maps from the map library at Dartmouth, take them to a drafting table, carefully measure the township boundaries, transcribe them to coordinates so that his advisor could do maps like this of Vermont and New Hampshire for whatever it was he was studying.
Notice the paper tape.
Notice the paper tape, yes.
Confetti resulted.
Yes. And well, there were at that time also devices that could draw things. They were things like mechanical pen plotters. A complicated thing like again, video's not playing. I'm not going to worry about it. But a complicated plot like a map, particularly if you were doing like thematic shading, would take hours on a pen plotter. 1980s, yeah, that's where we got the CIA data bank, Yale Bright Star catalog, so that the spacecraft tracking could be done with reference to bright stars in photographs. And then in the 1990s, I started with actually being back out of grad school and doing things professionally. And had Tcl' had escaped the laboratory, and I was using Tcl' early, like since 1991, because it filled a need. It was embeddable, extendable, uniform command language. Did everything from designing snap-fit plastic parts to hollow airfoils to microwave tubes. The common thread here is that none of the application was really in Tcl', and most of it wasn't even embedded. All of these things just worked with exec. That's the classical way to use Tcl', and that's really the roots of the language. And doing things that way, and then adding things like HTTP, or even earlier, just sockets, did huge integrations like MVC, where, yeah, this is the upper left is the nice, pretty picture of the control room, about as it was when we commissioned it. And lower right, well, you're seeing the equipment racks. It's too small to read, but the first rack on the left there says rack number 376. So yeah, Tcl' was controlling that whole plant with sockets. And so there was still, and around about that time, there were starting to be like a lot of hobby projects with mapping turning up on the wiki. It started out with a very silly one from Richard Zuckenberg, Mapping Colorado, where he drew a rectangle that were the right dimensions, and he defined the coordinate transformation, mapped a couple of cities, drew a line connecting them. And that turned into a thing called Tcl' World, where I told Richard about the CIA vectors, and he upgraded this to be a whole vector map. And then people started contributing things like a shapefile reader and the Slippy map thing in TK-Lib. And I wound up doing the Tcl' Lib map proj library because people were implementing all sorts of projections incorrectly. And so on. Eventually, Andrei Shidura for Google Summer of Code project implemented an OpenStreetMap editor in Tcl'. That wasn't all that effective, actually, because it wasn't in the OpenStreetMap ecosystem. An OpenStreetMap editor is really a very complicated beast, and typically you need a whole lot of plugins for the specific task you're doing. And it's no longer maintained. The other thing was it ran afoul of some TK limitations that are still there. A TK canvas can't do a polygon with holes. And there are area features on maps that have holes. So now we're up to the current decade. My daughter had become old enough to go hiking with me on more challenging routes. We started planning some real adventures, and I discovered the trail mapping around me is non-existent. The US government pretty much went out of that business in the first Bush administration, and the current generation of maps are missing a lot we needed. The previous generation were decades out of date, so that's what got me into OpenStreetMap. And OpenStreetMap in the US faces the problem of too much land and too few mappers. The example that's near and dear to my heart is the Adirondack Park in New York, which is got an area about 80% the area of Belgium, with a population of a little over 100,000, maybe about 120,000, less than 130,000. So really to map OpenStreetMap effectively, we need to work with external data sources. There's government data sources of various quality that we simply have to import. That's a very controversial topic in OpenStreetMap because they really want hand-curated data, but we have to deal with what we've got. And so the kind of question I'm trying to answer is kind of shown on this map. I wanted to do, let's say, an expedition to Round Top Mountain, and I wanted to say, can I get there conveniently without trespassing? OpenStreetMap sort of had incorrectly this one large area of state land that it's on, but these little things marked Round Top Mountain Unit, Twilight Park Unit, South Round Top Unit, those were there. Those are New York City owned pieces of land that New York City has purchased to protect its watershed. They're public access, but they were not mapped. And so here's one example of data import into OpenStreetMap that actually got interesting, that Tcl' helped with. The only data that was publicly available for these was, there was this PDF document that listed all the areas and embedded links to PDF maps. So that was going to be a really interesting exercise, but let's see what we could do with it. Well, I don't know of a good PDF reader for Tcl'. If anybody does, I'd like to know about it. So I started with exec PDF HTML. For that table, it generated HTML that was totally unreadable in the browser. But I didn't care, because what I cared about was that I've got this, for each item, I've got this block of HTML that's very stylized, that gave me all the table cells. It also gave me things like footnote symbols, so there was some further parsing to be done, but TDOM could parse it. And a few hours later, I had a script that had enumerated the areas, extracted the metadata that I wanted, and even automated it in downloading all of the maps. But what can I do with a PDF map? Well, the SRE people will appreciate this. It was a GeoPDF map. I wound up using one of the geospatial command line tools that called OGR Info to see if I could, is this actually geotagged data? And sure enough, it listed me a bunch of layers. There was a couple of layers with things like other and other two that I couldn't make any sense of at all. 100-foot elevation contours. Well, okay, I know what that is. Roads, streams, ponds, lakes, and reservoirs, 400-foot elevation contours, building footprints, and then this thing called layers PAA that turned out to be public access areas. And so there was a tagged geospatial layer in there called public access areas. And next thing, just pour that into, with exec again, pour that into a Postgres database. Sorry, Richard, spatial light just isn't quite ready. I'm doing some pretty nasty geometric calculations, and spatial light is missing some critical tools. And besides, the whole OpenStreetMap ecosystem is Postgres. So wound up just dumping each of the maps. The minus append of an OGR to OGR is saying append to an existing table. So I was able to do this for each map in turn, so that I had all the boundaries in one place. And that was enough that, if I launched Quantum GIS and opened the database, I could certainly see the boundaries on the map. They looked more or less correct. Whoops, topology. All that I actually had from extracting that was outlines expressed as line strings. And even those were broken into short segments, so that there were no more than whatever it was, 100 vertices per line string. And some of those lines looked like they were simply that some ranger had walked the boundary carrying GPS and were noisy as all get out. And so that resulted in overlap of adjacent parcels and that sort of thing. So there was a lot of topology fixes. Tcl doesn't have computational geometry facilities. Nobody's done that extension. It doesn't need it. PostGIS has it. So did a whole bunch of TDBC stuff that was throwing in PostGIS commands to clean up the data. Took a few days to design it. It was actually a couple of pages of Tcl and then some pretty horrible SQL queries. And it was usable data. Now the hard part is review and conflation, integrating this stuff into OpenStreetMap. And that really takes an editor for OpenStreetMap data. And Andre Shidura's editor is no longer maintained and really isn't that capable. But most OpenStreetMap editors now support a standard HTTP-based API. They open a HTTP server that controls the editor client and listens on port 1111. And so you connect to this HTTP server and you can give it commands like download this area from OpenStreetMap, or take this local shapefile and load it into an OpenStreetMap layer.
So you're saying that they're using the web browser as their GUI?
They're actually what this was intended for was that there are OpenStreetMap editors that use the web browser as the GUI.
Yeah.
And a lot of people don't like them. They have all the issues of using the web browser as your GUI. There are a bunch of standalone OpenStreetMap editors that then you want to integrate with the OpenStreetMap browser. And so there was like an edit button in the up-level OpenStreetMap browser that you can set your combo box so that when you click that edit button, it sends an HTTP transaction to your local host.
Okay.
And if somebody is listening on port 1111, it will drive that stuff into the editor. And it's enough to apply keywords and values to a given object, or download a given object from OpenStreetMap, download a given area from OpenStreetMap, open a local file. There's a handful of things that it does that are enough to integrate it to the browser editor.
Remote procedure call.
Yeah, it's essentially HTTP remote procedure calls. Yeah. And so with HTTP, I was able to do that. For the New York data, I didn't worry about doing finer management, but I also wound up doing a later project with New York State data where I had thousands of parcels to work with and needed to keep track of my work list and needed some help with managing things like whose sets of keys and values were right. And so I wound up hacking up this little TK-Powell that also integrated to that local HTTP listener in the editor that would let me choose a thing to work on, select what keys and values are applied, and in the case of conflicts, those values would change into combo boxes where I could choose the value I wanted to push through. Visit the URL describing the site, apply the selected tags, copy the tags to the clipboard so that I could edit them further in an OpenStreetMap editor, finish the object so that would mark in the database, okay, I'm done with this one, it's off the work list. And so over the few weeks that I was manually reviewing the data, I was able to keep track of my work list in an SQLite database and have this sort of control over the editing. So I'm almost out of time, but I'll just quickly go into another little project that I've been working on. This one actually, rather than being something that assists me in doing things, is something that I would like to see more broadly used in OpenStreetMap, which is rendering North American numbered highways. The people who aren't from North America don't understand the mess that our highway system is. A typical area here, the numbered highways will have 4 different numbering systems overlaid, because you'll have interstate, US, state, and county, township, parish, etc. highways, all of which may have the same number. You do need to know which system you're looking at. And there's also very frequent route concurrences, as opposed to the European scheme where a route generally connects 2 nodes, and you never see 2 numbered routes sharing the same pavement. In North America, there's actually one pathological strip of interstate that has 9 highway numbers. I mean, here's one example where where showing the visual shape of the sign really helps the driver a lot. So I mean, here, this is New York Highway 146. That's Interstate 90 concurrent with the New York Thruway. It shows both signs. County Road 77, and so on. And handling the concurrencies is important. This is how the display I'm using it shows it. This is how the OpenStreetMap default view shows it. It tries to say like CR65 or NY146. Here on the concurrency, the renderer seems to have given up entirely. I'm not quite sure what's going on there. I'd have to delve into the code more than I want to. So the way this actually works is it's a Tcl' script that monitors changes to the database. There's a side script that happens when changes arrive that generates SVG files for the symbols if it doesn't have them. And then I'm using the conventional OpenStreetMap renderer with a horrible SQL query to resolve concurrencies and join route segments so that the symbols appear at approximately equal intervals to reassemble it. And this is something that I really would like to see get back to at least OpenStreetMap.us. And it's facing some political issues, but I do have the code for that up on GitHub. So what does this mean for Tcl, TK? Tcl really has played a tiny role in all of this, but an indispensable one. It glued all this stuff together. And there's no more than a couple of thousand lines of code in any of these import projects, but it's all glue, doesn't do much, but so is that the way Tcl's going to rule the world? I don't know. This is what Tcl is for. It's very sticky glue. So it's still very useful for the same thing that I was using it for in 1991, which is gluing things together, where very little is brought into the language. So have I left myself any time for questions at all?
Yeah, you have time.
Okay. Questions? Comments? Rotten tomatoes? No? Okay. Who's on next?
All right. Thank you, Kevin. Our next speaker is a fallen restaurant kitchen worker, he told me. Philip Clifton. He's been programming web stuff for 12 years. He went to college for engineering. He started programming in BASIC at the age of 7 or 8 years old. He has been a professional programmer for 12 years, and he's the lead software developer at FlightAware. focusing in particular on the web, the area of the World Wide Web. He's presenting today on smart tile grids, optimizing the display of non-uniform geographic data. So a round of applause, please, for Philip Clifton.
Okay, let me get set up here real quick. And cool. Okay, so we can get started here. So yeah, this is actually, it's a kind of fun little project I did at work. It's actually been about 2 years ago I did this, but it was fun, challenging in all the good ways. It didn't make you hate yourself. And you know, the kind of dumb name I came up with it for it was smart tile grids, which is slightly ironic now that I say it out loud. And you know, as implied by the very long subtitle, the kind of smartness here was that we have some non-uniform data. We want to figure out how to display it on the map in a more efficient manner. And so what does that mean? Well, that's what I'm here to talk about. So sort of the brief intro which leads into the presentation. Like Carlson, I've been doing this professionally 11, 12 years. I've been at FlightAware about half that time. And while I was at FlightAware, basically I kind of fell into map development, kind of in the same way usually development happens, where somebody one day said, hey, can you look at this thing that a contractor used to have? And I said, sure. And the trap was sprung, and that was kind of the end of it. But, you know, it's provided some opportunities for some fun things I've done, you know, some major rewrites of libraries. It's very visible stuff on the website that makes us look good. And so it's been enjoyable, and it, you know, brought me into this particular project. So the use case we're going to talk about today, you know, if you look at the FlightAware site, there's maps everywhere to watch one flight fly or stuff going into the airport. We're going to talk about this particular map, which we call the live map, for lack of a better term. And so what this basically is in a way, it's kind of the dumbest map possible. It's every aircraft ever on the map that makes you go, hey, that's a lot of airplanes. And, you know, there's kind of an asterisk by that. It's not really all the flights ever, because, you know, we have data access agreements. Some flights aren't publicly visible, but it's the vast majority of them. It's still a lot of flights. You know, this can be very easily upwards of, say, 10,000 flights on here at a time. And kind of the interesting thing about this map we can talk about that's relevant to the presentation is there's kind of two types of data rendering we're seeing on this map. The first one, which is kind of the background imagery, the blue continents, water, and everything. So this is being sent down to the browser as raster images. This is, you know, it's just a regular old PNG, nothing special going on there. And then we have the actual aircraft. And what happens with these is we send down to the browser basically JSON data. It's essentially just, it's a position list with some extra metadata. And the browser can say, okay, you know, right here is a point in that city. Oh, what kind of thing is this? I can't mouse over. This is a A380. It's a United flight. It's going from Houston to God knows where. And then it does it a whole bunch of times when we get all these things pointing in their headed direction. And it looks cool. And so, like I said, I bring that up because that'll be relevant kind of as we dig into the use case here. And so we'll take a little quick detour here to talk about web map, because this is also relevant to how this works. So if you were to look at like a Google map or a map on FlightAware, and you watch it load, and especially if you had a slow connection, you notice that, you know, the background image, it doesn't all load at once. You'd see kind of a piece here, and it kind of loads sequentially. And so we basically, it's because we break this imagery up into tiles. You know, we don't just load one big image. If we loaded the big image for the entire world, if you're looking at Houston, you know, 99% of that data is irrelevant to you. Why would we do the work to send it down to you? So we break it into tiles, so we're only sending down the data that you actually care about. And so the way the tiling scheme works is, you know, usually some form of a 3-coordinate system. And there was a bunch of names for these and a bunch of kind of versions of them, you know, XYZ, slipping map, TMS, but they all share the kind of same basic thing. There's 3 coordinates. You know, there's a Z, which is the map zoom level. You know, you zoom in, you see, you know, smaller things, larger. And then there's X and Y, are pretty much what you'd expect, you know, lat, longitude, rectangular coordinates, nothing too exciting there. And so I'm gonna pause here for a second just to get into this a little bit with a quick kind of demo here. So just to show you what this looks like on the map, this is just where I'm drawing kind of a, that's not where you're supposed to go. Basically drawing kind of the tile borders on here and the actual coordinate systems. And so, you know, I call it X, Y, Z. The order here is actually Z, Y, X. So we see, you know, all of these have Z of 2, so that's a zoom level, and then we have, you know, 0 to 1, and -1 to -4, because why use normal numbering systems? Let's not get into that part of it. But so we can And what we can see, so if we come here and zoom into one of these tiles, at some point I'm going to go far enough that I get to the next zoom level. Now we're at zoom level 3. You'll notice that one tile just became 4. And if we keep zooming in, we'll keep seeing that. Somewhere at level 4, and hey, there's 4 times as many tiles again. And so the reason we do this is good for raster images. The general idea is that when I go into zoom level, the geographical area is now twice as large as the screen. And so by quadrupling the tiles, basically a tile ends up being roughly the same pixel size on screen at all times. So all of my tiles can just be like 512 pixels square or pink or something like that. And by having different imagery at different zooms, I can kind of control the detail level of the map. You know, if I zoom way out here, like if I wanted to look at, say, roads in the US, I don't want to show every road ever at the zoom level because it's going to look like crap. We might want to show just interstates. If I zoom in, you know, way into Houston somewhere, we probably want to see more. If I zoom way in here, we probably want to see more streets. You're not really seeing this in this example. You can kind of see it with the kind of waterway here, that as we zoom out, the detail level kind of decreases and changes. That's basically what you get out of kind of this XYZ thing. You can kind of control the detail level, and the one downside or consequence of this is every time we zoom in, number of tiles quadruples. You do the math, you can see there ends up being a lot of total number of tiles. You have 20 zoom levels. It's very literally in the millions. So back to this. That's not supposed to go there yet. Okay, so that's our basic idea of web maps there. So is this a good tiling choice for our live map example here? Well, whether it is or not, when I started the flight over and started playing with this, that's what we used. And so first thing we talked about, XYZ lets us change detail levels. Well, we don't do any kind of detail level filtering for this. The query for the data is pretty dumb. Here's a lat long box. Put all the points in there, send it to the browser, let the browser deal with it. So having that zoom parameter in there is redundancy in the most literal sense possible. You know, we started with that one tile, we loaded all the aircraft in there, and then I zoom into the next zoom level, and we take that and throw it away, and now we load 4 tiles of the same data. We already had all the data in the browser. Why do we get rid of it? And then there's performance issues too. You know, we want this to be kind of a flagship, nice looking product. So we'd like to be performant, and we'd like to do caching to make that work well. And that means, you know, we need multiple users that need to kind of be requesting the same tiles all the time. And if you have millions of tiles, the chances of there being cache overlap, you know, just kind of goes to the toilet. So that's not very useful. And then the fun part here, so when I started doing this, we were using Bird's Eye before we moved over to Popeye last year, I think it was. And particularly with Bird's Eye, not so much with Popeye, but fetching these large data sets can be kind of slow. Not horribly slow, but, you know, slow enough that the user can notice it. And particularly with Bird's Eye, for this particular use case, again, just a lat long box, I found through my experimentation that basically the time it took to query a data set is roughly proportional to the number of aircraft in the data set. So 10 times as many aircraft, 10 times as long for the tile to load. So, you know, for just sheer performance, the fewer aircraft we can have in a tile, the faster it's going to load, the better it's going to look for the user. You know, with certain limitations, we don't want to have 1 aircraft per tile and load 10,000 of them. And then kind of the visual consequence of that is, if we have 2 tiles and they have a very big difference in the number of aircraft, you know, maybe this one loads in 2 seconds, this one loads in 20. And now the user's looking at the map that just has this big hole in the middle. And this is not hypothetical, this is what these things look like. And so, you know, next slide kind of combining these 2 things, you know, we can see the very obvious example of this. You know, there's craft load aircraft here, there's 2/3 of a craft load there, there's like 1 here. So if you're a user, you probably see this load pretty quickly, and this thing might take, you know, 15, 20 seconds, and you think it's broken or it just takes a while. You know, it's going to look bad no matter what. So there must be a better way, of course. So this kind of lets us get into basically the goals of what I was trying to do. You know, we want to try to limit our number of tiles so we can get better cacheability. And we want to try to get basically a uniform aircraft count for each tile so we kind of get roughly uniform load times and don't get those big holes in the map. And so the solution I basically settled on for this was, let's look at the flight position data, let's analyze it, and let's generate a tile grid off that, and we'll do it offline, because we do have that whole loading issue. If we're loading all the aircraft, it's going to take a while, but if it's offline, we don't really care how long it is. So we take all that data and basically recursively, keep dividing it up until you generate tiles that are manageable and kind of uniform. And, of course, distribution of aircraft is going to change throughout the day. It's going to be busy in the US now, it's going to be busy in Europe later on. So we need to kind of periodically regenerate this, like, a 8 a.m. central tile grid is going to be crappy at midnight central, say. So the kind of first sort of naive approach I took to this was, I took this split concept very literally. Okay, here's 10,000 aircraft. Let's split it down the middle. Now I've got 5,000, and keep splitting it basically until we get to a manageable thing. And this, ends up being a pretty simple operation because it's rectangular coordinates. And if I, draw a line at say y equals 0, then all I have to do is look at my y coordinates. If it's greater than 0, it's up here. If it's less than 0, it's down here. It's pretty easy to evaluate. So, the thing I did ended up being, this is pretty iterative. We try the geographical midpoint, check our counts, move the split towards a higher population and kind of refine that until we get a roughly equal split. We can't be literal about equal because, dumbest example, it might be an odd number, right? So we're a little fuzzy with that because you don't want to hit that, and we don't want to, it doesn't need to be perfect, right? We're not looking for, if they're off by 5, who cares? Let's just move on to, it's good enough. And so we can kind of look at sort of the visual version of what this looks like. Draw a line there. Okay, it looks like there's more to the south there. We move the line down here. Okay, now there's too many up here. And we do this until we get to a satisfactory solution. And so that works pretty well. And it's, it's not really slow at all. It works pretty easily. It's just simple math. The problem with that, oh yeah, I should have told this to stay awake. Technical difficulties. Okay. Anyway, so here's the problem with this approach. If we take splitting literally, the number of tiles we can have, the count can only ever be basically a power of 2, 2, 4, 8, 16, or whatever, which is very limiting in the tile grids we can create. Like if we take an example, let's say we had 4,000 points and we want to get, say, 400 points per tile. Well, okay, we divide it up into 8 tiles. We've got 500 per tile. We want to do more than that. We divide it again. Now we've got 250, and we kind of overshot it. And so it'd be better if we could make this a little more nuanced and kind of be a little more flexible the way we did the split. So when I kind of rethought this, I said, if we restate this original idea of splitting, instead of saying half and half, we can say, we're splitting to a ratio. The dumb one is we're 1-to-1 ratio. The same number of aircraft are here and in the other half. And if we rethink that and say, well, if we do arbitrary ratios, then we get a lot more flexibility out of this. So we can do arbitrary ratios. We can do an arbitrary number of tiles. So if we wanted to make 3 tiles, we split 1 to 1-to-2 ratio. Then we take that second batch and split it 1-to-1. Now we've got 3 tiles, and we can basically recurse that as far as we need to. And this leads to also you have to kind of reframe your thinking about how you're going to do the splitting too. Because originally I said, okay, I've got 4,000, I'm going to cut it in half till I have a number I like. And this one, you can't do that during splitting because you don't really know what the target's going to look like. So you had to kind of reverse the thinking and say, well, let's just say, how many tiles do we want? And that's what drives the logic. So if we have 4,000, we want 400 tiles, or if we have 4,000 points, we want 400 per tile, we're going to need 10 tiles. And I think at this point, to kind of get into logic, let's just, we'll get some actual code. So this is basically part of the kind of, main prop that runs this entire little tickle script that does this thing. And we pass into this, we say, here's our desired density, like 400 aircraft per tile. We pass in some bounds there, which are going to be the entire world to start with. And why we do that becomes important in a second. And then at this point we've done, we've queried bird's eye or Popeye and basically said, give me all the flights in the entire world, and that's a list of points. And then it's pretty easy, okay, how long is that list? That's our number of flights. Divide that by density, take the ceiling of that so it's a whole number. We've got our desired tile count. And then we call this split rectangle to count proc, which is kind of the meat of the actual logic here. So we look at this thing, And I've kind of annotated this a little bit, so there's a little bit of an example here to make it hopefully a little easier to follow. So we're passing into this, here's our list of points, here's our bounds of the rectangle we're going to split, and here's how many rectangles we want to split that rectangle into. In this case, let's say we told we want to split it into 5 rectangles. So the way we do that is basically we're going to determine, so we kind of start with our naive thing. Let's cut target count in half. Can we use that? Well, it's probably not going to be a whole number. So if we take the floor and ceiling of that, we end up with the ratio that we want to split to. So in this case, with 5, we want to split it to a 2-to-3 ratio. And then that becomes the ratio we pass to this actual split rectangle proc, which is what actually does the splitting. And I pass that kind of the same thing. Here's a list of points. Here's the containing rectangle. Here's the ratio I want to split it to, 1 to 1, 2 to 3, whatever. And then that's going to return back 2 rectangle dictionaries. And each one of those is going to be a set of points and the set of boundaries for the rectangle that just created. And then from that point, we just get into the fun recursion part. And the nice thing about this, so this 2 to 3 we get here for our ratio, it's not just our split ratio, it's also for each of these sub-rectangles, it's how many rectangles I need to chop that one up into to make the recursion work. So, floor is going to have 2/3 of our, or 2/5 of our points, ceiling's going to have 3/5. So I want to split this into 2 more rectangles, I want to split this one into 3. And so we can just examine those in our next part here, and we say, okay, if split floor, which was 2 in this particular case, so that's greater than 1. We need to split the rectangle again. And then it's just recursively call myself, split to count, pass my points, pass my bounds of my smaller rectangle, pass the number of tiles I want to cut it into, in this case 2, and then whatever comes back from that, stick it in my result set. Then we just do the exact same thing for that kind of ceiling count, the other half that we split up. And so visually, it ends up looking like this. Our first thing we split it into 2/5 and 3/5. We split that into 2/5 becomes 1/5, and we're done with that. 3/5 becomes a 1/5, 2/5, and then 1/5, 1/5 all around. Now we're done. And that gives us, and now we have 5 tiles, and if we want to make it 7, 9, whatever number we need, it works for that. So we get to see, what does this look like? Or what does it end up looking like? And we'll go to more examples here, not this one. So this is basically a production grid that I created, or I generated the store while I was doing this. And this is basically the number I arrived at that I target aircraft per tile is 400, which is just, so experimented, and that's in like kind of the sweet spot between tiles load fast and I don't have 5 million of them. And so you can look at this and you kind of get, it's pretty good visual representation. Where is the aircraft density at? Nobody's full because who wants to go there? US is kind of busy, Europe's kind of busy. Asia's a little bit asleep. And we can see, so for a more exaggerated version of this, I generated a grid with 100 aircraft per tile. And it just kind of highlights, same kind of thing. We can see more, a little more granularity where the dense areas are. Usually Europe, US, these are kind of our hot spots there. And then the cool thing I thought I could do with this, I said, what if I generated a day's worth of tile grids, like every hour, and then threw them on a map and animated it. So if we do this, we should be able to look at those kind of roundabout density plots. And we should expect to see kind of the, the busy aircraft areas sort of follow the sun to the west, right? And so if we start that, and the timer is pretty rudimentary, so it kind of started at a random spot there. But yeah, you kind of see what you expect. Here, Asia's kind of slowly going to sleep. I got that backwards. Asia's kind of firing up now, and it's starting to get busy, and then in a little bit starts to migrate over to Europe, and that starts to get busy. Then eventually it gets busier, and then the US starts to wake up. And eventually Asia starts to go to sleep again, and then eventually we're back where we started again. So that is, okay, I think we did 24 hours here. So that's a day's worth of tiles. And so that's the thing we do. So we've been using this in production for probably about 2 years now. And your map loads it relatively consistently. looks pretty cool, catching works well, and I don't think we've had anything break because of this in a while, which is not true from when I first started working with it, but that's a good story. And so with that, questions, yes?
Do you guys always do the Cartesian projection of the globe, or do you have customers like, say, in the Northern Hemisphere who really want to see,
We only use one projection for the maps right now. Everything is, Cartesian, I forget the actual projection.
Sorry.
Yeah, I would like to do something like that because, the problem with this grid, obviously you try to map a sphere into a rectangle, you have discontinuities at the poles. I think the worst this grid ended up being at about 80 or 86 or 87 degrees. So anything that goes over the North Pole just rapidly looks like complete crap. It just looks like it flew off into space and then rematerializes. So I've thought about wanting to have some way to kind of do a different projection. It's kind of a hard problem to figure out because, like, at what point do you make a change? I think a better solution to that would be using something like a cesium or a 3D library that you just have a natural 3D thing and I can pan it around and get a more natural one. That's a big unknown that I've kind of wanted to do for years, but just haven't quite had the time to play with. So it's on the permanent to-do list. Yes.
I gather part of this is because the plane icons are in the PNG that you send out. They're not drawn on later.
They are drawn on later by the browser.
They are drawn on later by the browser.
Yeah, they're actually SVGs. The browser just gets the list of points, and the browser draws those. It's a HTML5 canvas that it draws them on there.
So when you're doing the query for the tile, why is it so strongly dependent on the number of airplanes? Because it seems like you could just say, well, okay, here's the region, here's the PNG that goes with it. Why does the number of planes matter?
Well, that's a limitation of the actual query for the service that provides the positions, and that's where the fact that the time it takes to make the query ends up being proportional to the number of aircraft. So if I put a lot of aircraft in one tile, it could possibly take longer than I want the user to take. Okay. So by limiting the number, I kind of
It's not producing the map tiles that's the problem. It's all of the data that goes along with a tile of this size at this part of the globe.
Yeah, it's just basically the work of, here's all my positions, give me a little things. Anything else? Yes.
So, got one or two questions, I'm not sure. So one is, I think this is really neat, and it comes off just some work that I've done. One, I'm wondering how easy it would be to essentially sort of do the same procedure within a given tile, so that you can sort of analyze subsets within a given tile. Does that make sense?
So like take one of the tiles I've generated here and
then rerun the entire algorithms within it.
Yeah, I mean it should work. I mean it's recursion, which means once it works, it's very elegant, but you pull all your hair out in there.
Yeah. But I work on it. So it's recursion. It's fine. And then I'm curious about, so it's similar to a tree map, except that you're generating, the algorithm is generating the ratio. I'm trying to see the linkages and the differences between sort of tree map algorithm and what you're doing. Yours is a lot simpler in a lot of ways. I think I understand it, whereas when I've read the tree map stuff, I don't get it. So I guess I don't have a question. Maybe I want to talk to you more. Look at the code, but yeah, there's an interesting approach here, but you're sort of doing it more inductively.
Have you looked at using a quad tree? What you do is you take each of these boxes, and you don't get a constant number of boxes in the end. Take each of these boxes, you divide them in 4, and you keep that division until you keep recursing that until the resulting boxes have less than or equal to the number of planes you want in a tile.
Yeah, I think that's basically what my first attempt was.
Well, that would it was a half. It was a half division, and you were moving the division.
Yeah, it was. Geographically, it wasn't.
Right. In this case, what you do is you take a box and divide it into 4.
Okay.
You say, does this quadrant have less than the number of planes I want on a tile? If so, you're done. If not, you take it and divide it again, and that's a typical quad tree. That's often used in mapping, that's why I kind of came up with that.
Yeah, I did not look at that.
Okay. Now, what the disadvantage of that is you don't have a fixed number of tiles when you're done, of course.
Is there a easy explanation of why the query time depends on how many claims are in there?
For that one, I'll go look at
If
Peter.
you pull the data out of this, it's doing a search on a SQL database over latitude between here and here, and longitude between here and here, because typically what we get is they're looking for all the planes near a given airport. So they're looking at a particular section around the airport. What that gets mapped in, that gets filtered through this tile thing to reduce the number of individual queries that are made against the database. But basically, it's doing a lookup in a SQLite database, and how long that takes is pretty proportional to the number of hits.
So if you wanted, you're asking how many planes are there in a tile?
Yeah, because typically your
Yeah, I almost wonder whether you can reach behind the curtain and inquire of Star Trek directly.
Yeah, that's kind of what I was wondering. Are you using R-tree index for this?
It's not the box, it's not the bounding box. It's just that getting one row is a reasonable amount of time before you use the X percentage of our resources.
It's just actually
So
reading
this
the row.
amount of time is incredibly short, is the first problem. How long do we want it to be? Shorter than that. And so the linear, a lot of it's just like you get a rendering. It's got to go on the network wire. So it's getting turned into JSON. It does have some post-processing standardization on that, which is probably a long time. So it's simply like, why does it take you longer to print n rows than one row? This is n. But the box scan, it is, the question is like, should it be at R-tree or the index that we have? Like, indexing two doubles is kind of unclear what it is. And our experience is like the outside of that. But like, having a client ask, so Philip's kind of watering this down. A lot of clients are asking for the bounding box 90, 90, 180, 180. Oh yeah, that's the whole Earth. That's every plane in the database. And so that takes a while.
Any other questions? Okay, thank you.
Thank you, Philip. Okay, well, the good news is we're about 7 minutes ahead of schedule. The bad news is it's raining. So it's lunchtime, and the idea of strolling over to the nearby restaurants is looking a little bit questionable. So the afternoon schedule runs until 4:45, and then the banquet is at 6. And so I propose that we extend lunchtime a little bit and that we run over past the 4:45. Does that work for people? Just to give you a little extra time. So my proposal then is that instead of 1 hour for lunch, that you'll have 1 hour and 22 minutes. And that will allow us to return then at 1:30 instead of 1:15. Does that work for everybody? Okay, great. So lunch begins now, and we'll resume with the afternoon session at 1:30 p.m. Thank you. Okay, we're gonna wait like 5 more minutes and see who else comes. All right. Yeah. Sessions, everybody please come on in. Our first speaker this afternoon is Michael Yantosca, Michael's worked as a software developer for 13 years, and he's worked in oil and gas, artificial intelligence, and video games after a 4-year stint as an anime dub screenwriter. I just got the backstory on that. It's really, really interesting. If you want to annoy him, just ask him. I'm sure he won't be annoyed to talk about it. He got a double major in computer science and linguistics from Rice University in 2001. And he moved into the field of aviation when he joined FlightAware earlier this year, actually, right? So he's really, you didn't know Tcl' before this year. It's pretty amazing what he's done. He's working on his master's thesis at the University of Houston and expecting to complete that by the end of the year. His research interests include programming languages, real-time systems, digital signal processing, and machine learning. He's presenting today, Release the Turtles, Pure Tcl' Interface to Dynamic Proc Tracing. So round of applause, please, for Michael Yantosca.
Thank you. Okay, so this work was kind of born out of what was supposed to be a very small JIRA ticket. So I'm going to go through just kind of a little bit of the motivation, the design and implementation, some small experiments that we did, and some takeaways from So Turtles is the Tcl' Universal Recursive Trace Log Execution Scrutinizer. I'll say that 3 times fast. It's recursive because we actually use the proc definition and a trace handler to bootstrap, adding trace handlers to the other procs as they come in. And it captures dynamic call record information limited to the immediate caller-callee relationship. We don't get the whole entire stack. And then it records the inclusive time in proc. So, the time from on enter and on leave, it captures that so that you can get some timing statistics so you know what its hot spots are in your program. It's fork safe to a point. We'll go into that a little bit later. And it's probably not thread safe, at least for now. And like I said, the motivation is we have a program at FlightAware called Multi-Machine Hyperfeed. And we wanted to do some extensive refactoring of the code base in progress for performance, modularity, legibility, maintainability. And so the ticket that kind of spawned all this wanted to look at how we could group procs together by relation, by call relation. For me personally, it's kind of an etude in Tcl' introspection. I am a neophyte in the language as it is. And I think really the first time I started programming it was June of this year. My experience with it beforehand was using things like GitK and the kernel config GUI before my wife advised me strongly to pick a distro that just worked. And I wanted immersive projects to dive headfirst into the language. Talked to some of the folks at FlightAware about what kind of tools we had available with Tcl' to do these kinds of things. Shannon Noe suggested command trace and Tcl' disassemble, and I kind of looked briefly at those. The command trace had a very comprehensive logging of the commands that were executed, but for something that, like multi-machine hyperfeed, that was producing thousands, if not millions of calls every whatever time frame, the output was going to be too verbose to really sift through in a timely fashion. And the Tcl' disassemble stuff looked like it would be useful for static analysis, but I also wanted to include the execution timings in that, so wanted to work on something bespoke. Okay, so for the design and implementation, I'm going to go over briefly over the package organization, the initialization of using the library, how it collects the data, how it finalizes the data to a SQLite database, and then how we do the analysis post-mortem. So we have kind of the root package, Turtles, it's all the things. This is the one that you will package require if you want to use this, and most users will probably only need to use this. The persistence mechanism is broken up into a few packages and sub-packages. We have Turtles persistence, which is kind of a pseudo namespace, and it has the mechanisms for saving the trace artifacts, and it's brought in as an alias using string substitution for the two scheduling ones, multi-threaded and event loop. And there's a common package that the two use called Turtles Persistent Space, and that provides the actual SQLite queries. We'll get into the scheduling in just a minute. One of the things that when I was going through and doing the analysis, I wanted to do the clustering based on the Gallagher-Humblett-Spira minimum tree spanning tree algorithm. And I started on that and tried to kind of model it as a K-machine model simulation using Tcl' threads. That kind of dragged on, and so we'll go a little bit into that later. But I've left the packages there for anybody who's interested to look at kind of where that was going, where it came from. And instead went with a BFS floating approach with the cluster Tcl standalone script that's in the root of the package. And then just some helper functions we had for hashing. We used deterministic proc ID hashing as based on the fully qualified namespace origin to proc name. And then also the options processing, which determines what mode the system is running in. And then we have some packages that we use for doing the Tcl test to make sure that the package is performing as we expect. We have pretty decent documentation of the conference paper, which is available on our GitHub repo. We have the README, and throughout the code base, I tried to be very comprehensive with Doxygen style comments, so you can take docs if you pull the repo down. You don't need Doxygen to build and install the library, but it's just there if you want it. And then installation just to, using GNU Make or similar utility, make install, and then you can look at the README and Make file for more details on that. So this is as far as starting the thing up. Package require turtles, : turtles, : release the turtles on argv. That's it. It'll start the mechanism and do everything that you need to do for most use cases. You can choose some non-default parameters we'll get to in the next slide. And you can even supply a variable name other than argv if you want to do an isolated run of it. Recommendations, places before any imports on the packages you want to measure. Because it uses proc to bootstrap, it waits for it, depends on those proc definitions to come in and do the handler to add the handlers. And so as early as possible. All right, so parameters, now by default, it's not enabled. You have to pass in the enable flag in your command line parameters to your program. And just quickly, you put these arguments between the plus turtles and minus turtles brackets. So this will be on your command line, and that helps keep your command line arguments for your program safe from this processing, because it's destructively consumed to avoid interfering. Because if you throw these in and you don't have branches for those strings, then you might actually crash the program. So this reads those in and then removes them so that your program can just use the arg strings that you care about. So like I said, it's only enabled if you explicitly enable it. That way, if you want to run it, leave the package require and the initialization call, you can do that in production code, and it doesn't actually do anything. It won't load, it won't create the SQLite database, it won't do any of that. But if you do enable it, it will be there. And the reason for that is it has a pretty high overhead right now. Then we have commit mode, we have a staged and direct mode. What that does is, in stage mode, it puts things into a staging in-memory SQLite database, and then we attach a on-disk database that periodically gets flushed to. And in direct mode, then you just write directly to disk. For schedule mode, you have the option of multi-threaded or event loop. The multi-threaded actually spins up two Tcl threads. One is a scheduler that does the periodic flushing and notifies the recorder thread, and the recorder thread does all the actual marshalling of the calls to the persistence to SQLite. With the event loop, we use the after mechanism essentially in place of threads. So if you can't have threads, you could potentially use that. That one's not as tested as the multi-thread. That focused most of my attention on the multi-thread case, but in theory, it should still work the same, albeit slower. And then we have you can specify in milliseconds the interval at which the flushes happen to disk. So those three parameters kind of go hand in hand together. And then because we had to account for 4 children, and we wanted to make sure that databases wouldn't step on each other, we actually follow a naming convention. And so that's specified by the DB path, where you tell where your on-disk database is, and the DB prefix, which gives you kind of a unique naming. So if you're running multiple things with turtles, that you don't stomp on each other. We also have a debug parameter that gives just some extra logging, I think, to standard error, in case you want to actually see as it goes what the timing executions are for each individual call. And so here's the persistence tables. Like I said, it's a SQLite database. We have 2 tables. Proc IDs, which handles the proc definitions. There's the ID, which is the hash of the proc name, the fully qualified original proc name of the proc point of definition, and the time that this proc was defined. So as the proc call happens, we mark that time and that has to do with the flushing of disk to make sure that we don't send too many things and kill the performance. The call points is the actual individual calls. We take the hash of the caller ID and the callee ID, and then we create a trace ID, which is a unique identifier that distinguishes specific calls that are, because you might have multiple calls from one caller to a callee, and you want to distinguish those. And so that's how we do that. Then you have the time of entry and the time of leaving on the proc. The proc ID is just
question.
Yeah.
Just for clarity, you're trying to do this not because you're trying to do profile guided optimization kind of stuff. You're really trying to get telemetry on what's happening in the execution.
A little bit of both.
And in the second part, because a lot of times the technique for that, right, is to do time-based sampling of the stack.
Mm-hmm.
And that's the most common technique because that also gives you all the arguments and parameters. So I noticed that you don't make note of, for example, what arguments and parameters were provided. Is that important to the problem? Or
not initially, but we're right now, like I said, the initial ticket that kind of precipitated this, we wanted to know what procs actually talk to each other, what the call relationship is. Now, as far as the arguments, that's probably future work.
Okay. I have other comments, but the one I want to talk to.
It's very hard to get the tickle stack from C code. It's very hard to get the tickle stack, period.
You can't trace it.
So doing sampling is extremely hard unless you actually instrument and extract the stack.
For high performance jigging, this problem is an essential part because the actual jigger is tracking the statistics in real time to know what to jig. And so I'm very familiar with this problem space.
Okay.
I'm happy to help you talk to you at least offline.
Sure.
Some approaches to it.
Okay, so the proc ID is just a rapid car Berlin hash. Have the Mersenne 8 prime as the modulus, and the multiplier is the Mersenne 7 prime. And you basically just feed that string, and it kind of recurs on itself to create the integer hash for the proc ID. And the trace ID, we take the following integers: the thread ID, the stack level, caller ID, source line number, and callee ID to create something unique for that caller-callee relationship. Now, of course, no hash function is perfect. There is the potential for collisions, but they're fairly unlikely. So here's a kind of just a visual demonstration of what happens when we bootstrap proc and have the tracing. So we have the little handler hanging off proc. So we call in, and then the interpreter reads it, creates the procs, and then adds the 2 handlers on enter and on leave. And that's just pretty much in a nutshell how it happens. And then in terms of collection, we go in, call our function that we've instrumented. It's called, it goes, enters, and it goes to the recorder thread, which then sends it to the stage 0, which can either be the actual direct to disk or the in-memory ephemeral database. And then when the proc's finished, it goes in, sends the thread message to the recorder to do its stuff, and it does it. And then to stop the collection, you just call turtles, capture the turtles, and that's it on that. And so this is how the finalization happens. We've got this kind of cheesy PowerPoint animation going on here, but you can see that scheduler sends to the recorder, which then periodically sends to stage 1, and of course the scheduler goes into sleep also, and then persists it to disk. And then we have some built-in post-mortem views that show the calls by callee, which is just the actual callee and just the overall broad statistics. Then we have a slightly finer resolution where we show the caller to callee relationships, and we give the number of calls, the total execution time in microseconds, and the average execution time in microseconds. Then we also have unused calls, because one of the things you may want to find out is what calls am I importing that I'm not actually using, which is just wasted space, and maybe would require some kind of restructuring of the packages if you have control over those things. And like I said before, for the analysis and trying to build a graph of the relationships between the calls, initially tested with the Gallagher Humboldt Spira minimum span tree as a K-machine model, implemented Tcl' threads, kind of overkill. And the development was progressing glacially in terms of weeks, partially because of my newness to the language, and just trying to follow a TDD approach. It just kind of got bogged down. And the folks who needed the statistics and stuff to do the refactor on hyperfeed were anxiously awaiting that. So I switched to a simple breadth first search flooding approach, implemented that in a day or two, and it's actually turned out to be sufficiently fast for the data sets, but it's just kind of reinforcing that the GHS attempt was kind of overkill. So just kind of to walk through the DFS flooding real quick, you basically have, here's the traces that the executions that happen. You have A0 that calls A1 and A2 calls C, and B0 and B1 and B2 that. Now this is there's two options in the cluster Tcl script. You can either do directed or undirected. With directed, you only count the edges going from the caller to the callee, and you might want to do that, as we'll see when we look at the undirected, because you might unnecessarily group things in groups based on common procs, like say clock, and it'll actually eat up all of your stuff into a giant big cluster and won't tell you a whole lot of information. So it makes the call, and we send out the flooding. Each of the nodes, for simplicity, I'm not showing the loser sending out their flood messages, and so the clusters kind of build in this way. So A0 kind of captures, and it's the root, and C is by itself, and then because it has actually a higher degree, and then C actually first come, first serve. So in this case, you'd end up with two clusters like that. Now for the undirected, everybody sends out their stuff, and then you see that the nodes that are most populous will kind of dominate, and eventually the C proc, which is common to all of them based on the undirected graph, will create a cluster that encompasses the entire program. Now, for to make sure that we are progressing and doing things correctly, we do have a test suite that's in the package. It covers basic cases like your standalone proc, nested procs, and because we were especially interested in the fork boundary cases, we have some unit or integration tests on that. And then tested against a couple of applications. One was what we call Slowbird. It's a flight-aware onboarding exercise. Basically, it's a console application that continuously reads TSV data and provides some message statistics. And then, of course, there's multi-machine hyperfeed. It's a service that manages multiple fork children, and the children are the ones reading this TSV data and the stuff coming over RNQ. just for some of the kind of experimental results, you can see that the undirected experiments yielded fewer clusters as was expected, and it's pretty consistent across these several runs, whereas the directed had more things. And then we have execution timings. The proc enter and proc leave handlers, not terrible, I guess, on 160 microseconds, but there's a lot of it, so that's really high overhead. I have some thoughts about how we can improve that. But as you can see, like the biggest consumer of time is the slow bird handle message, which is probably pretty good since we want it to be doing work. If we have, here we have the kind of the cluster, there's too many functions to really show to get all together, but on the cluster size distribution, we have a few big clusters and then a bunch of little clusters. And in most cases, the directed shows higher than the undirected case. We looked at the unused procs. Sample Silbird had 779 unused procs. Multi-machine Hyper-V has 6,324 unused procs in one sample run and 5,581. So that really kind of speaks to, there are some packages that have a lot of baggage that maybe we can trim that down. So that's a takeaway that we can take from that. And then again, in the execution timings, again, the handlers take up a fair amount of time, not because they're necessarily slow, but because there's so many of them, because we're hitting every single function that's defined at this point. And this is for the parent. Also, one of the things that we did kind of a difficulty, I had to change my assumptions about what constituted a valid proc name. Again, just my inexperience with the language. But you look down here, Tcl' clock format proc %A, %B, %D, blah, 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 blah. That was kind of a shock to me, actually. But I think Oliver Jowett had some pretty good solutions for that I was able to implement and make sure that we captured things like that. And then the child execution time, you can see that most of the time spent in consuming the RMQ and processing the lines. So that's pretty good. So some of our takeaways: simplest is often best. Premature optimization can significantly lower overall development velocity. I spent a lot of time on that GHS implementation that probably could have been better spent on doing more features or other things. And just being able, having iterative improvements and being able to measure performance as I went would have been better for not getting trapped in these kind of things. And then also, frameworks don't always translate well across platforms. The original implementation of GHS that I had was from a grad school project. It was OpenMPI, and OpenMPI processes don't necessarily translate well to Tcl threads, at least not in this application. And so to play to the strengths of the tools at hand, ran into a lot of barriers with the everything is a string kind of model. But I was able to actually leverage that in some cases to do some basic currying that came in handy during the namespace aliasing. The OS support was kind of mixed. The Mac OS 10 support was really kind of a barrier, particularly on the forking, because I was developing on my Mac initially and then moving to the server. And so I wasn't able to test the forking very reliably on Mac OS. And then also signal trapping when using multiple threads, I ran into some issues that I think there are some outstanding bugs on that, particularly on the Mac OS platform. And then also the string escaping can get kind of tedious and hard to track if you're having to translate across multiple things like thread messages, where you have to kind of literalize everything before you ship it over because you don't have that context between threads. And then I would have liked to see more complex example code for some of the non-trivial cases just in the Tcl library documentation for my own benefit. With the introspection, that was really great. The trace handlers themselves actually survived the fork boundaries, which was saved me a lot of time. And there is quite a bit of information available through introspection. And the interpreter isolation, in some cases where it worked against me, it did also make it easier to reason about the behavior versus the shared state kind of model, and avoid kind of race conditions. Although the cross-site communication via snippets can be kind of expensive, and there's a lot of actually boilerplate copy pasta for multi-threaded scenarios where I actually have to package require all the things that I did in the main program inside the thread create message. And maybe there's a better or more succinct way to go about doing that. I do have some caveats about the library. Not tested collection on multiple threaded programs. It'll probably induce contention towards the persistence. And there is a window of potential collection loss over the fork boundaries, because basically what we do to kind of save ourselves on the fork is that we stop the persistence mechanism create a special handler for Tcl' fork, stop the persistence mechanism, and then bring it back up on the exit fork and do some logic to test whether we're a parent or child. And then if we're a child, we copy over the parent's database so we have all that persistence information in every child to kind of preserve those fork semantics. And the parent just reopens his database. The Turtles library does induce quite a bit of overhead. I think Slowbird ran twice as slow when it was enabled, so there's some work to be done there. So just some kind of things for future work that I've considered. Performance improvements, replacing thread messages with shared channels between threads may help, just so that we actually have true data pipeline instead of sending snippets for execution. I think it will cut down on the amount of communication there. And I may need to drop down to C for some of the hash functions, just for speed. Personally, I'd like to be able to add some IDs based on the descent path to encapsulate that full call stack so that every root level call has some kind of a unique ID assigned that all the subcalls inherit, so we can kind of do that full trace. And other extensions, maybe persistence to Postgres, variable usage tracking would be helpful. Retroactive proc variable inclusion, because you're only going to get included in your metrics what got defined after you call the initialization function. So being able to reach back and do like info commands and kind of walk through that would probably be useful in some use cases. Yeah.
How long does a typical trace run last?
Kind of depends on whatever your program is.
But I mean, for your purposes, does it have to run for days, hours, or minutes?
Minutes.
So one simple cheat you could do is every time a frame is created, a context, give it a unique ID and just spin a counter. A 32 bit should be more than sufficient for the entire life of the program. Then you don't really need to hash it all. Because every frame that gets created will have a unique ID, that's all you have to record.
Now,
the entire stack.
Would that require modifying the interpreter in any way, or is this available through like as a pure Tcl?
Oh no, that's probably would require adding something to the interpreter on stack, but the performance of that would require that.
Sure.
So
there's the Turtles repos that's available. You can download it, and then I just put in a link to the original implementation of GHS and OpenMPI that I worked on that kind of inspired some of the aborted work on Turtles Veil and KMM that may pick up later, may not. See if it has any value. Any questions? Yeah.
What about object methods?
Probably does not capture those, because if those are through namespace, it definitely doesn't capture. In fact, I actually thought to try and do a meta demo where I actually traced the cluster Tcl script, and it actually didn't show up anything. And so I think there's a lot of stuff that was used object methods, and it didn't pick that up. So yeah, it's like I said, it's only bootstrapping on the Proc right now.
Thank you, Michael. Okay, we're going to bring Shannon Noe back up, who's going to talk about tracing Tcl at multiple levels. So, round of applause, please, for Shannon Noe.
USB-C
I lose all
flavor in this.
Carl has one.
Oh, you need a dongle? Yeah, you get. There's a dongle for that.
Let's see if my screen comes out there without freaking out. All right. It's gonna maybe work here. I'm gonna leave my URL up because there's some rather substantial trace files that it's gonna be hard to read on the screen. So if you want to read those, you might want to go to the URL. And there's a second motive. I mean, this presentation is on GitHub, but I'm actually presenting off of GitHub, and you're going to learn one thing in the next 5 minutes is how to do that, because it's super simple. So you notice the URL has a username first, and then instead of github.com, it says .io, and then after that's my repo name. So if we shuffle that around, that's my repo, okay? And then in order to get it to serve as a web page on github.io, you create a branch called GitHub Pages, and it will serve this branch for my repo. And down in there is an index.html, and all that's in here is reveal.js. It's going to load my talk. And so here's my talk. Thank you. Got any questions? There you go. There you go. If you want to give a talk off of GitHub and you want to, edit in Markdown, you don't want to do PowerPoint or whatever that thing's called. Keynote, right. You can just do Markdown and then use Reveal to serve that file directly. So, okay. So here we go, tracing Tcl at multiple levels. So how did this get started? I wrote a tip where I was like, hey, I want to embed an interpreter. I want there to be a static function to embed an interpreter that's immune to the define of use Tcl stubs. Because what happened is everyone's using CPP Tcl, and that defines use Tcl stubs because that's the right way to use it. And then they call Tcl create interp. Their program segds. They look at their source code, which is one line of code, and they're very confused because they don't know that Tcl create interp has become a macro. So I said, hey, we should have a version of Tcl create interp that is static. That yes, you will have to link Tcl, that's a given, but you won't have this problem with what defines you have set up. So the proper way is you have to make a unit that does not have use Tcl stubs defined, and then you create your interpreter in that unit, call that from your program. To write a file, you have to change your make config and everything. It's kind of tedious. So the response was, well, you don't know what happens when a Tcl interpreter starts up. And I said, I absolutely don't know that. So I'm going to find that out. So a lot of ways to trace Tcl. Right? Command trace in Tcl or command trace in Tcl, either place you find it. Whenever someone's debugging Tcl, I go, you know what, did you look at this? Save yourself a lot of time. Get a trace of your Tcl. I wrote Tcl'2019, which is sort of like command trace combined with strace or truss. So it actually doesn't do the I/O, so you can make it's tracing even a live program, and you can connect it with strace and see your Tcl, and then disconnect. You can also set breakpoints in the debugger. Of course, you can compile with Tcl compile debug and set the Tcl variable to turn on, which will flash up there. You can do turtles to get tracing information. You can redefine your procs. And of course, if you're really hardcore, you can go in the debugger and try to decode a Tcl call frame. That's not fun. It's very unfun. And sometimes you trace with call rank because you want performance. So there's tons of ways to trace. There's one more, which is GCC instrument functions. Right?
So what can we do with GCC instrument functions? Well, on every function that you compile, it's got to inject function enter at the beginning, function exit at the end. It's going to give you the addresses of the calling site and the caller. Compiled in, right? So this isn't a sampling trace. This is actually a good old C-scope style, a if-def debug style trace, print my line trace, and the compiler is going to inject these. That's pretty easy, right? And we get a full profile. All right, then we do it. And we go, hey, not only that, this is in Tcl. I can do all the Tcl stuff too. Like I can print the bytecode and the C functions, and I can print the Tcl line. I can print anything, I do anything, I'm in the program. I'm hacking away now, hacking in the C, everything's open, right? So I end up with this nasty snippet that I snipped out on purpose. So this is what happens when you get to the end of your script. Tcl plumps on exit 0 if your exit code's 0. And then it starts doing the exit 0, which gets to Tcl exit object command, which is the actual implementation of exit, which through no coordination, Will showed you earlier today. So I'll say one thing, after this talk, you're going to really appreciate his talk a lot more because we're going to go look at a lot of Tcl code. So let's talk about this. The trace is pretty busy, but what we have is the address of the callee, the caller, and we're getting the file and line number, right? So that's a little bit better than the address, huh? The API from the compiler was 2 pointers. This is actually the line of code. And then interspersed with this, oh, messed it up. So I did the swipey thing. Don't know how to turn that off. Is where I'm like, you know what, I want to see the Tcl bytecode just for fun. It really doesn't do a lot for you to see the bytecode over and say, oh wow, man, this is the bytecode. This is how the bytecode works. This is what the bytecode does. I will say, frankly, the loop where Tcl is calling commands from bytecode in Tcl execute up at the top of the code, you'll see it, is quite tight. If you're going to do this calling function pointers dynamically, this is done quite well. So that's one of the things. It's hard to make that reproducible. It's hard to make it do funny things in C in the debugger, and the Python scripting thing I hate. So now I'm going to hit this down arrow. If this slide is hard on your eyes, close your eyes, because we're going to look at some code to give you a little flavor here, right? So Tcl nr run callbacks, right? If you've been in the Tcl code, you've been watching it run, you've seen that, right? And this is the interpreter. This is the non-recursive interpreter, right? And here we have an extremely important piece of code, right? Because we've got a pointer to a procedure, some arguments for that procedure, which are pointers, and then the pointer to the next thing on our callback chain, right? And whenever we have to do things in the interpreter later, and we're not being recursive, we're flipping them onto this linked list. So the NR, that's it. That's the heart of the NR. Then this would be very typical of the Tcl code base is we want to do this fast, we want to do this, we do this a lot. So we want to do it in macro, right? So that we know it's inlined by the compiler. So you have to write a good macro like this one to actually do that, right? And that's your hardcore C. So I'm definitely like, there's a lot of code in Tcl, and I respect it. Anybody got any questions about that? It's kind of weird, but I wanted to show you just that you kind of know where we're at. We're going down this linked list, and we're going to do stuff, and it actually goes and does all the things as a result of that, right? So how do we do this? Let's talk about the implementation. So you grab Tcl, you throw in the magic flag into C flags, and I need a timer. I don't know when I started. What time did I start?
Start at 5 after 11 minutes.
All right. So we grab the source code, we flip in our C flags and turn it on. Then we have to add these two callback functions with the pointers. And these could just print the addresses and we could stop. Then we've actually got our trace. It's pretty nasty looking, right? But we have it, right? So we want to have a better implementation. So implementation 2 is we want to convert the addresses to source code line numbers. That'd be really nice, just like the debugger. Luckily, hey, there's a repo on GitHub where this is all written. And it's, unfortunately, it's got the wrong license, so we can't add it to Tcl forever because it's GPL. That's that. It uses this library called the Binary File Descriptor Library, BFD. Would someone raise their hand if you know that that's not its real name? Do you know that? Does anyone know that? The author that created this library didn't call it that. He's in a thread arguing with someone we won't mention, and he said, that's no big blanking deal. And libbfd was born, which later got renamed into this very politically correctly. But this is a library that call trace is simply calling the calls in BFD to translate the addresses, right?
It's just reading the link map, right? And translating the link map.
Pretty much, yes. Right.
You could easily build a replacement map to GPL.
It's currently no BFD.
Correct.
That would be a great name.
Yeah. And LLVM is a different one, right? So, but also, you know, we can do more with this. Like implementation number 3 is like, well, wait, we can print the Tcl command, we can print the bytecode, we can print certain IO actions that we think are significant. It's doing we could we can do whatever we want to do because we're hacking in the binary. So particularly, like sometimes I want to say, I'm like, okay, I'm really just concerned about what files are being opened. And in particular, like the only file I'm expecting you to open is the init.tcl, right? So when you do command trace, when you compile with the Tcl debug, you turn on the levels with this global, the Tcl trace exec global, right? And so that, because of how this is built, it's all in line, it'll all spill out at the same time. So you get all of that, plus the stuff I've added, and this is one that it does work pretty well. If you're really wondering what's going on with the Tcl, like this is an absolute answer when you do this technique by compiling the debug Tcl. This is the doc man page for it. And I got there by looking at the C code, not by Googling. I'm reading the code and oh yeah, here you go, here's this variable. Oh, that's what it's doing. That's what I want. Oh, that's the printf I want, right? And then went backwards and Googled to the documentation. So if you're not stuck in an environment where they won't let you compile with Tcl, and you really want to know what's going on with the Tcl, this is one way to find out in detail what's going on with it, right? So now, now I have to show you. So let's look at this file. I'll try to make it really big. Now, you remember on the other slide, it had all this detail about like what was going on, right? So let's cook that down and let's just ask, what does Tcl do when you start it up? And let's print each function once, not redundantly. And look at what's happening when we run it, right? So, okay, main, Tcl create interp. This was the piece I knew. Now the question is, what has to happen of all the stuff that's going to happen after that, right? So it starts off and setting up threads, setting up memory, setting up the Tcl math library, right? Then more stuff with threads, starting to set up the hash tables for the globals and proc names and all these things. Doing a bunch more stuff, getting to where we're going to be able to start making bytecode and start parsing. And of course now, the first thing that's going to happen is Tcl init Tcl is going to get read and processed, right? And so we're going to see a bunch of things about parsing, and commands are going to get created, setups for commands get called, keeps going on and on and on. And on and on. And so now we reach the point where we're like, wow. We're just getting to go in here. Tcl's got a lot of code. Profiling, I only care about the hotspots, right? If I'm in Richard Hipp battery mode, I care about every line of code, right? I'm very mixed about this. So today I'm going to show you some other things. They're not meant to be critical of Tcl at all. They're just sort of, they are what they are, right? But for me, these are things that I found through this tool that I'd like to show you a couple little things where I was like, wow, I'm surprised. I didn't expect that, right? And that comes from sort of running this on programs and watching what's going on. I'm not really getting any useful information about optimizing code or doing anything reasonable with it, right? So this file, this ex1log.gz, is one of these gigantic ones that's a real trace of a program. Here's the program. Not much Tcl. Makes a massive trace, right? So the traces of anything that's really production or useful are just far beyond, having a lot of utility. But what they do when you trace kind of real stuff is, you start to get into the code and you see things. And so one of the things that happens at startup, right, is we're going to find the name of the Tcl executable. In particular, we're going to end up calling this exact function, right? And part of the thing about my tip was, well, if you just call create interp, how's this going to happen? How's it possibly going to come out right? But the very last sentence of the man page says, but if we can't do it, we give you a null. So it doesn't matter if it comes out right. So I traced it, I found all this stuff, and I'm like, you know what, that doesn't matter. It doesn't matter at all. Because basically the protocol, the API that we put out to the public is like, well, if this doesn't work, you get a null. And you don't know the name of the Tcl executable, and it is mostly used, it's used all over the place in testing, and I appreciate that, but not useful for us. Exactly the same statement occurs here, right? And then, I think it's here. Oh yeah, here you go. So we're going to go get the name of the executable, and essentially, if it hasn't been set up, you just get a null. So I think now after that, having a trace, I could claim and say like, well, that's a good point because that won't work, but it doesn't have to work. You're still a Tcl without the name of your executable. And we're getting it from the source code. We're not getting it from my memory or my opinion, right?
let's look at this one. Tickle-free object is an interesting one because
Hey, Shannon, can you make that bigger?
I'll try. Yeah, let me try. Try to make it a lot bigger. There you go. I'll scroll. Is that better? Can you see it at all? You don't have to see a ton of it. So your expectation for tickle-free object is that it's going to do a ton of complicated stuff, right? This does do a ton of complicated stuff because it has to be complicated. Right? Some of the complication has to do with threads. That's just the curse of being a thread programmer. But the other one is this interesting line of code here at the 1320 where it gets this hash entry. Does anyone remember what this is?
Yes. Yes.
Yes. Any tickle? What is it? Screen up.
Memory preserves its preserve.
What is it?
It's checking for whether the object is preserved.
The object is currently in use, so you can't touch it.
No, it's a pin.
No, it's been marked.
It's performing a pin check. See this pin inside.
Right. You can't just delete it. Right?
No. That's to do with the tracking of line.
Yeah, I think that's what it is.
That's the tip 280 stuff?
Yeah.
Oh, okay.
Well, how about this line?
That's tip 280 stuff.
Credit back to you. You got talked out of it. Yeah.
No, that one's definitely tip 280.
This is tip 280. So, like I say, this is my comment about this. This isn't to pick on anything. This is to point out that, like, there's a lot of tickle code. So it says we cannot use the tickle get continuation table here because we don't know what state we're in, and that thread function might not work. It'll crash things, right? But what it is when we're in the parser and we're going through and it's 8 white space and we want to know there was a new line, it gets marked in this hash. So the parser connects the tickle obj. Because tickle obj is the thing that the parser makes a tickle list, right? So every time you're destructing a tickle object, you're making a hash lookup on this map that must be dug out of your thread storage. It's work, and this gets to like the battery thing. So what this tracer taught me the most was how there's a lot of things and there's a lot of code and there's a lot of code that's interconnected and it goes here to there, and I would say tons of it have to do with thread support, which is hard to get right. But this one really surprised me when I was like, why every time I delete a tickle object am I doing a hash lookup? I was like, what? Find the code and I see the code and I'm like, oh wow, that's a lot more complicated than I thought it would be, right?
Can you scroll back up a little bit? So, aside from doing the hash lookups pre and post, it's doing a lot.
Now this is
Blocks going on.
the deferred delete. So like they said, if you can't do the delete, it goes into the deferred delete queue, and when you come back in this code, it will clean it all out. So you're going to do all the deletes for everyone who deferred ahead of you.
That's what deleting very large graphs of objects. Yeah. So if you built a very big graph and then destroy the root of it, then you can't just recurse to everything.
It's the same problem we have to do in regardless of what we change.
Yeah.
But it's never done like this. It's why I'm just looking at it. That's very expensive.
So let's look at this one. This one, in one of my traces, this proc gets called a lot. And we recognize it from C. It sort of looks like is space, but it's not, right? And when I looked at it, I said, wow, I call that a lot. And that's kind of very hot C looking code there, right? But I'm like, well, what's it doing? Well, what's that?
Well, hair type is a macro. It does an offsetted lookup in a table. So then we got to go find the table. Do it.
Is this localization of data?
No. See if I can find it. Oh, here it is. So it takes a signed integer in a specific range. All the negative ones are normal. Then we get to the regular ASCII range, and here we take care of spaces and braces in the new line. And then we go to the high range, which is all normal. Now, I heard him say it, Unicode. No, nothing to do with Unicode. Nothing. So I'm kind of like, do I worry about that macro that does the table lookup to do is space? No. You know, is it maybe what we want? Maybe not. I don't know, right? But this is the scope of, like, this is a lot of C, and the C has a lot of people that wrote it, right? A lot of contributors.
Did it show up? What showed up in your hotspots? Because that's kind of interesting. What actually showed up as the hotspots?
So I only looked at is space because that showed up as a hotspot in one of my runs, right? Well, yeah, so this is sort of the question.
Doesn't matter.
Right, is like, does it matter? Does it
You're
not matter?
profiling fairly recent Tcl' sources.
This is 869.
Because it wasn't very long ago that instead of calling Tcl is space proc, you would have been calling C routine is space.
Yeah.
And I think that was changed just to not have multiple things that do the same function.
Yeah,
I
I
think it
don't
was
know.
an economy of coding argument, not a performance centered argument.
Yeah, this is definitely one of those, like, I look at the code and I'm like a dog, I'm tipping my head because I'm not getting it, right? But it doesn't mean that there's anything about it, or like it's not a good piece of code, right? I mean, I don't know how an Intel processor thinks about this.
In terms of doing this bit of the parsing through a table lookup, that's ancient.
Yeah.
It goes back to Tcl 6 probably, if not earlier.
Yeah, it definitely, the only thing about it that is kind of bothering me is that there are some places in the code where we're doing, like, in Tcl UTF, there's some guard checks, and then we call it. And I'm like, well, this guard check could have been a lot stronger, so we call it less frequently. And then just the whole thing, there's other places in the code where there aren't any guard checks on this array at all. And the array is it's quite small. It's an int, and it's a very small amount of an int, right? So you can easily go read off in memory.
It used to be a signed char.
Yeah.
So one thing, just to be sure that it's not sort of a false positive kind of thing, the way that expression is coded, depending on how you actually linked it, and whether you have link time optimization being used, that should have all been inline. And it's going to be much more expensive if it actually didn't inline it and create real call frames, etc. And I'm wondering if that's just an artifact of your instrumentation.
Oh, no. It's definitely, this instrumentation cannot tell you a single thing about code that's been through LTO. And you definitely should be building your Tcls with LTO.
So that's weird that wasn't, I mean, I think it's a little red flag in the idea that.
But one thing about it that you got to admit about this code is the way it's doing the code and the way it's written, right? Because rather than a regular range compare of immediate values, right? We're asking the compiler to go look up the table value and then test it. So, you know, the question is how much of the instruction cache, you know, is disturbed because we have to do all that instead of an immediate test.
I know the answer is probably that question.
I
think that should have been in line. It's a little odd to me that it wasn't.
Yeah, so if you're building Tcl, you should definitely turn LTO on. Even my bad benchmark, say like maybe 5% on our stuff, just out of the box. Like, there's zero reason not to use it on a modern compiler.
You know, I don't need LTO and SQLite because I make the
Trying to make
amalgamation.
it
We have a Tcl amalgamation, so that we just, Tcl.c and you can drop it in some other application compile it.
That
That would take care of your problem.
right. I thought about
It's
that.
really easy to include Tcl and other things.
So I was working on that, and then I said, I could do all the work of making an amalgam or say C flags LTO. So I was just like, for me, it was an easy choice just to let the compiler do it. Right? And the other thing that's good is LTO is getting better because soon we're going to be getting not only LTO, we're going to be getting, if you have profiling information, it'll shuffle around the code in the right spots.
Yep.
And that is coming.
See, I'm skeptical that LTO will ever be as good as putting it all in one translation unit.
It's never going to be as good as a human, right? It's never as good as a human who's putting it in one spot in the right order.
Best you can do.
Right?
So just go ahead and put it in one translation unit and be done with it.
Are you doing this with Clang? Are you doing this with ECC? What are you using for the compiler?
It's GCC.
Yeah, Clang doesn't.
Try doing this with Clang.
Yeah.
Try using its later for some of this. You might get better results.
Well, in
There's
any
different
case,
results for sure.
this code is I would just say that, like, you shouldn't guess what Tcl is doing. You shouldn't sit there and say, well, Tcl must be doing this. And I'm like, no, go look at what it's doing, right? Because it often does things, and there are things in it that, so it's been hard to really come up with, it's hard to come up with really, really good optimizations for Tcl, right? It's difficult, right? And as, and keep it being Tcl, right? Because the key is that thing is, remember we had this linked list of function pointers that we're calling? That's like the spirit of Tcl, right? Like that's data. That's not in an instruction page. Like the CPU is not going through saying like, yeah, Joe's going to call that function pointer over there, over on page 10. Doesn't have any support for that. So it's doing, so like the thing is like there's plenty of optimizations that we can throw off, but then in the end it won't be Tcl. It'll be some other thing, right?
It's cheap but not good quality.
Yeah.
That's the building language engines, that's the cool.
Yeah, so as a Tickler's got this weird thing of like, proc, and you can redefine proc, and proc, and you define it back, and you can use undefined to get some effect, and like, well, is that Tcl? Or is that the part of Tcl where we go, well, don't do that? Maybe.
It's Tcl.
Well, there you go, right? Okay. So hopefully it's not just super confusing because it's pretty technical. So any other questions about it? All right. Thanks for your time.
Very
Thank you, Shannon. All right, our next speaker is Vishan Persaud. He started coding a few years ago. He was doing advertising optimization and started writing a few scripts in Python to do ad reporting at a prior job. Came to FlightAware to do the same thing, started doing that, basically automated his job and took on more and more and more, and now he owns billing, which is kind of amazing because it's a fairly large sum of money. It's the collection of which is resting on this guy's shoulders right here. So Vish is going to talk about a first step toward end-to-end testing of subscription billing. Take it away, Vish.
Thank you. Let's see. I've eaten far too much Samsung down for this. All right, for those of you that haven't had the trouble of working with me, I'm Vishan. I've been at FlightAware for just over 7 years. In that time, I've helped mature the billing infrastructure, including the addition of new products, as well as expanding the overall functionality of the system. As a recent effort, myself and alongside our QA team have taken up the task of providing end-to-end tests for our subscription billing engine. This platform, known internally, is Omnibus. It is a Tcl' daemon that tracks over 6,000 billable accounts. It is roughly 5 years old, has 691 commits, and has been edited by 25% of the FlightAware technical body. For a system tasked with generating millions of dollars of charges and developed on by so many, it may be surprising to know that it has never had an semblance of end-to-end tests until this year. There were a number of hurdles that were overcome in order to write the first test. The paper accompanying this is a high-level system summary of what it took to make it happen, but the bulk of our time today will be spent by walking through the internals of Omnibus and familiarizing ourselves with billing of some of our products. Starting with the file structure, Omnibus the file is under 600 lines of code. And each product has a supplementary file that's paired with it. In the code, product and class are functionally synonymous. During the presentation, if I say class or product, it's just any one of these after the OB underscore. So like OB periodic is a product we have. FATE is a product we have. Again, if I say product and or class, they're the same thing. An invocation of Omnibus is simply the Omnibus billing file with the class appended as a flag. Omnibus without the class is simply a shell program that creates a charge. Before looking at how Omnibus integrates with the file, let's look at how it kind of tackles handling the charge to begin with. This can be split up into two phases. One phase is account aggregation. The second phase is charge execution. There are also a litany of hooks in these files that are what connect them together, and we'll see that in just a little bit. Looking at how information is collected and processed, the first phase, account aggregation, sets up the main payload, a list of arrays. Each array is a list corresponding to a billable account. In the charge phase, Omnibus loops through this list of arrays, and each array essentially is one billing unit. It's one customer for one product. There's a design assumption here that any product can be distilled into an equivalent set of parameters that this one system can handle. So regardless if it's a product that's sold by usage, by subscription, if it's a one-time buy, the system assumes that all of those can be translated into 5 or 6 parameters that it can use to initiate a charge. And this is possible because the code architecture of Omnibus it's very simple. It's not the smartest program, but by being so simple, you can get away with boiling things down. So the account aggregation code physically lives in this omnibus.tcl file, while the charge execution code lives in the accompanying product files. If we go through the omnibus.tcl file, I like to this is what's behind me. This is largely omnibus.tcl. I've pulled out a lot of comments, a lot of boilerplate code, but what we see is all of these omnibus underscore procs, which are essentially the hooks into the other file, bookending this for each loop. This for each loop is what runs through this array of accounts and creates a charge. Now, all of these hooks into omnibus.tcl exist for account management purposes. So we see a hook at the beginning, we see a hook for account aggregation, which is the account for billing procedure, and then before and after the charge, FAGL charge user, we see more hooks. And we'll see examples of how they're used later on in the presentation. It's important to note that the charge processor itself, the thing extracting money from a credit card or creating an invoice, FAGL charge user, handles a lot of the high-level billing or the technical billing aspects. Like, is this an invoice? Is this a credit card? Does this need taxes? Is this billed in a different currency? That being abstracted out of Omnibus makes the testing environment a lot easier to work with. Circling back to account management and effectively class files, several hooks may be defined. Behind us is the accounts for billing hook. Common to all class files is this accounts for billing hook. This proc does the construction of the array list, and for some products, it can be as simple as a select query that gets stuffed into a Tcl array. Better by example, this is our periodic file. Without much history, the periodic class is a catch-all product that any team member can go and create a flat fee recurring bill for a user. It's something as easy as saying as, this user ID owes us $10 every month. And that is the easiest definition of subscription billing. The biggest limitation here is the inflexible price. The price is stored in the database. So for usage-based products or things that have a pricing engine behind them, the periodic doesn't cover. But again, as you literally can see, it's a select query that gets stuffed into an array and then is put in a list for billing. This is as simple as a billing system can get. Now we'll look at the output of this charge. The record, along with the extraction of money from a user and the creation of the charge in the accounting system, are the effective outputs of Omnibus. Thinking about the inputs and outputs of Omnibus, you can see in the last slide that the majority of the inputs of Omnibus are all coming from the database. Similar to the array being created by the class file, the output record in the database also has the class-related ID and billing parameters. Currency and method are both important in the charge procedures as well as the finance system. Date seen in this entry and the billing date and billing method seen in the class file both maintain the frequency at which a product is billed and provides cash flow insight downstream in the accounting systems. It is important to note that all dates seen here are stored in the database themselves and are represented as variables in the code, meaning they can be set at will. This is a core feature of Omnibus that lends itself to repeatable tests. Introducing a usage-based product like XML, our web API, you can see how account management happens through charge execution through one of these hooks. So after the charge runs, this bit of code goes in and flags all of this user's queries that he's made against our API as paid versus unpaid. That way we can keep account of what he owes and what he's already settled up for. From a higher level, in order to coordinate pre and post maintenance changes, as well as fielding any schedule account upgrades or downgrades, these hooks are available to you. Seldomly, they're used all at once, but depending on the timing of the operation you need to do, a developer can insert the code necessary to keep the accounting gears greased. Before we take a step out of the system, Omnibus also has the functionality to pull in a user ID or a specific date. Testing starts to fall apart. The importance of being able to parameterize the date lets us do a lot of test reinforcement down the line, and it helps us preserve test cases. So why are we doing this? Outside of the business criticality of the billing software, why do we want to make it testable? It runs daily. It alarms if it doesn't. A lot of people get mad when we stop bringing in money. Errors are eventually noticed by administrators and account users. The product offering doesn't change frequently. It is a rotisserie oven. You set it, you forget it, you live in ignorance is bliss. But it's super punishing. It should not be nerve-wracking nor punishing to develop against Omnibus. When you merge new code in, a suite of tests should be there reassuring you that all is still well. But even earlier on during development, there should be immediately accessible feedback for your code changes. This only works if the feedback loop for tests is short. If we had to wait for a full database refresh before we can run the same tests again, testing during development would be inaccessible. Until recently, this has been the case. The account management that happens during billing for our largest projects touches a schema that is both sensitive and mutable. And in some cases, the changes happen through an opaque layer of triggers and may not even exist if there's a materialized view that needs to be refreshed. The only way to retry a test that had previously made changes without explicitly tracking each and every table and record in the database is to reset the entire database to what it was before. Additionally, without the testing environment, developers now have to use their own code against production. This means real credit cards, real invoices, real account entries that all need to be rewound when the test is over. Since I'm not an Opster systems expert or really an expert at all, I'm going to admit a lot of the environment setup that is detailed in the paper. Largely, the gaps here were to overcome the surrounding security and sensitivity of the information. That being said, the testing environment required 3 large systems to come together. First, obviously, the omnibus system. If the date in omnibus were operating as not a definable parameter, we would never count. The feature of omnibus is that it takes the database connection as a parameter. This means that omnibus can safely be pointed to a non-production database. Again, since all inputs of omnibus are in the database, this means that there does not have to be any test code or test switches in the production omnibus code. You just need to point omnibus to something that's not production. The second system, obviously, is the database. We've already talked about how crucial it is to be able to run a test quickly. In just a little bit, we'll look at how this is currently accomplished. The third system is what I'm going to call third-party APIs. With some good fortune, the credit card processor FlightAware provides a free sandbox. Other APIs we use, like our tax processor or how we determine addresses, does not. And rather than stall on these systems, we've just not yet incorporated them into the testing environment. By far, the most interesting part of this project is how refreshing the database was solved. To put up some background, FlightAware is a Postgres shop. Recently, we ramped up our ability to provision more servers, specifically those centered around development, allowing us to keep non-production code off of production databases. As part of this, the company is able to provide dedicated testing servers. Regardless of the server type, in order to provision any server, the ops team uses pgLogical to do full clones of the production database. This means that the testing servers are very close to reality once they're refreshed. I'd like to insert a quick note about securing these test servers. By design, developers have basically pseudo access to the dev database. And this gets rid of a lot of the red tape that we have in our production servers so that we don't expose anything. But still, it's hard to overlook the availability of all the identifiable information surrounding billing. Here you can see is a similar design pattern of allowing hooks for developer code injection. By extending the replication software to allow for the execution of SQL files, removing all emails, and removing all credit card tokens and replace them with test tokens is as simple as one SQL file. One thing we do is we remove all the emails from the users, even though developers have access to it, in the test database, because as a byproduct of billing, we send the user their receipt. It'd be a shame if we send someone repetitive fake credit card receipts for a product that they thought they've, paid for. Now, cloning is done by pgLogical. We carry this out overnight and as a best practice for the billing database. This introduces recent schema changes that aren't necessarily tested inside the context of billing. We found that we need to be running in production as much as possible, because commonly a view definition will be expanded, but the system users that billing runs on will not be set up again correctly, and it's usually just the website permissions, developer permissions that go back, onto the view definition. The nightly refresh is enough to catch all those. In order to bridge the gap between these refreshes, during the day, another Postgres library is used, pgdump. This is a nice little package that will extract tables and records into an SQL file that can be kept on hand. Tables and records can be dropped and updated, seemingly keeping the whole process in a transaction that is easily rolled back. Being able to use this relational aspect of Progress is, being able to store all of this information in a SQL file and repopulate it lets us really take advantage of the relational aspect of Postgres. The work currently being done now is to investigate how we can inspect the database and collect all records regarding a user account. Since all of our tables, usually contain a user ID or a class ID, we can theoretically extract all of the basically extract the user account in time and keep it and repopulate it whenever in order to test regression bugs and kind of immortalize the scenario we want to test. And between capturing the user in a point in time and being able to repopulate it and running Omnibus at any date in time, you know, we can immortalize these test cases versus if we didn't do this, every new billing period a user occurs, their account's constantly going to change, the products they have behind them are going to change. And that's just no bueno when it comes to testing and regression testing. A few things were evaluated to see if we can get around something using pglogical or pgdump. Initially, we're just going to use pglogical for the whole thing, but we were across dev versions on our production databases and our development databases that were just too hard to bridge. We did some work on recreating the system in SQLite, but all of the charging happens in a trigger, in a few triggers, and there are a lot of views that just didn't make it feasible to recreate. But as it stands, you know, we can refresh the database and execute these tests pretty swiftly. Finally, by sheer stroke of luck, the credit card processor we use offers a pretty comprehensive testing suite, pretty robust documentation, development accounts, and endpoints. As long as we point the Omnibus system physically somewhere else, you know, we're in no harm of polluting production or initiating, you know, fake charges. Like most of the web APIs at FlightAware, we had to bring out a deprecation. This piece here will differ company by company, but it was the thing we needed to be easy, and it was easy enough. I do want to take just a bit more time and go back to the system diagram. It's pretty low level, but all these systems here are written in Tcl'. Even the Postgres, the work done by Postgres, really what's happening is Postgres is executing a system file in Tcl', and that's how we interface with the charge processor. The way a charge flows through the system, I'm just gonna represent that. So we start, you know, billing kicks off, we specify the class. So say you bought an API subscription in Omnibus. Omnibus will ask Postgres for all the records to evaluate. Omnibus will then go through each record and see if it needs to be billed or not billed. There's some code sharing happening here with the main FlightAware repository. We keep a lot of the pricing engine logic on the website end, just because a lot of the front end needs to see this code, and we don't want to duplicate how we come up, like the code that it takes to come up with a charge. After we've gotten all the information we need from the shared space, Omnibus is ready to make the credit card charge, and it sends it back to Postgres onto a physically different server. Postgres executes the charge and then kicks it back to Omnibus, you know, for logging in, publishing to downstream services. That's really it. I just wanted to walk you guys through that system. I think that this work is really, you know, future-proofing the products we're adding to FlightAware, and it's really helping spin up or demystify some of the work I do, as well as bring newer members and like our QA team up on the work with billing. So I'm glad they've been able to entertain me. If it's you know, by right, a lot more people should have been able to co-author this, or a lot more teams should have been on this paper to co-author it. In the paper itself, I think I'd like to thank one of our system members for writing a bit on SaltStack. That's how a lot of this gets deployed. But, you know, again, a big thank you to those that did help out. I know for this to be a good presentation, I need to say SQLite fossil and name parameters, but that's it.
Great.
Yeah.
Thank you, Vish. Okay, we're going to take a break. We actually have some soft drinks and snacks coming, and they're not here yet. I know that the catering people are whipping that out, and it should be here in a minute or two. But we're a little bit behind. So let's just take like 8 minutes right now until 3:10. We'll resume in 8 minutes, and if the breaks don't come, if the snacks don't come for 8 minutes, then you guys can sneak to the back when the presentations are going again. All right, so the break begins now. We'll resume in 8 minutes. Thanks.
Yeah, Claude, hi. I scanned some of your biography to introduce you. You're very technical. Yeah, exactly. I don't want to make that like an insult or anything.
Well, it is, but it's okay. No, it's true. I'm actually surprised you. You social scientists do any programming. I honestly at this point don't understand how.
Yeah.
It's like just like cleaning data. Like,
Oh, yeah.
How the heck do you? I mean, and people are like Excel.
Yeah.
I mean, like, and I do a lot of science. Right now, I'm doing an analysis of 9 columns and like a couple dozen variables.
That's great.
Even that is like. So I don't know.
I just read an article that Goldman Sachs was saying that traders should all know how to program. And I actually made some good point at the university that what's happening is helping sociologists get their data into SPSS and stuff. Because they would, they didn't anticipate that you could have more than 5 kids in your family or whatever, and they took half of the format of representing the data. And so it was pretty cool. The Institute for Social Research.
This one actually is kind of interesting because, so there's.
But anyway, yeah.
But yeah, no,
hacking social scientists is good stuff.
Yeah,
right. And right. And so people do large data analysis projects, not where they're hold them to someone.
Yeah. No, and I talk about that a little bit in this. Great. Yeah, you do have this split. Doing it. Researcher and then you got a program.
Right.
Programming with putting a stream going on.
This programmer doesn't understand the domain.
So, like, I mean, it can work, but
Yeah.
it's very good to know yourself.
For sure. Because you've got the domain, the programmer doesn't. So they don't know if it makes sense or not. Well, I'll let you get your head here.
All right, yeah.
All right, cool.
Yeah.
Feel free to send forward questions.
Not so much maybe 12 years.
Well, yeah, and then that was probably not the right way to do it.
One thing I was going to comment on about. I kind of like it because it's all writing. You call it value.
Hard at work.
Yeah, the results out.
Okay, this one might be broken. Oh, in that case, he has two broken. We will have to have more for burning because that's exactly how. No, because
I don't slavishly stuff, but I do like.
over there, no,
So I submitted creative reading.
take the entire thing and I will check this again because I am not sure if it was fully broken or not.
Yeah, well, a couple of these I had to reformat.
Also, I have.
Oh, you reformatted them.
So what I is but I had laid it on the reformat my extract.
Oh, I see. Okay, I never thought about reformatting. So that might be explained by fixed upload or scheduling our for their thing. In this case, actually, the things I put in, they were actually already containing data from last year. I actually didn't bother wiping it, I simply had from last year.
Traits are kind of like
Bonus. Right now, this is me checking. This one was about, yeah, didn't really work. But yeah. Oh, no. This one has actually only the data from last year. That is what I which was not recognized and not written actually. This one possibly was written actually, and also used. So we might, yeah, we will see if it comes up. Let's burn these rules, evolve us, and every have simply normal rule or something.
My results.
I see. Yeah, these are the last one blanks. I removed them so that you the people checking out my instructions. So you can basically take them from here. As soon as you this is also revised out. Previous projection. The line is sometimes takes a while to project. I have to do three times okay, yeah. Yeah.
We're gonna start in 2 minutes, please. Everybody come on in and take your seats. 2 minutes.
Yeah, I do the same except I don't do things. Because I don't make,
be aware that I'm
thinking to get them for my burn. Yes. Maybe later.
yeah, I'm willing to look, but how much I will.
Oh, I see. Okay, this one is broke.
So you might undergrad is Emory. And then master's.
Yeah, we'll see it.
Berkeley and then that's Houston. What is very
Yeah.
Oh, actually, those are just
It's actually the weather. The party. Yeah, then we open up.
All right, please take your seats.
Everyone's
Oh, here come the snacks. Okay, the snacks have arrived, so we'll give you 2 extra minutes.
No, I very much like
Yeah, me too. Yeah, I used Snowball. That was a script in the late 70s, and then yeah, my whole my career has data kind of moving from FlightAware is all organized around like decades of experience. And what we were also thinking is like, they're like, well, we need a priority and look at data environments is really a big binary data structure. And why do you have that? Again, I started in 79. One of the first 2 years of university, and we looked at some of the profiles were like the filter file, and it file everything. All right, everybody, please take your seats. We'll have more time to talk after these sessions.
All right, let's get to it, huh?
All right, let's get to it.
Let's get to it.
All right, Andrea said, sit down. My authority is low. His is high. Come on, everybody. All right, I'd like to introduce Claude Rubinson. Claude is an associate professor of sociology at the University of Houston downtown, where he teaches courses on research methods, social inequality, and culture. His research work covers it's very broad research work. I'm just going to touch on a couple things. His research work covers developing formal methods of qualitative research and health services research on the conditions that facilitate or hinder the success of interventions designed to improve patient outcomes. His talk today, Rediscovering Ousterhout's Dichotomy in the 21st Century while developing and deploying software for Set-Theoretical Empirical Research, R to Python to OCaml and Tcl'2019. A round of applause, please, for Claude Rubinson.
Thank you. So I have way too much text on my slides, so I brought printouts.
Wow.
And hey, paper is a superior technology. You can, whoop, except for that.
You can drop it on the floor.
Yeah.
And is that paper statically linked?
It's got a chart.
Sure. So thank you for the introduction. As you heard, I'm an assistant professor of sociology. I do not have a background in comp sci or anything like that, but I work in this methodology called qualitative comparative analysis. And I'm not going to talk too much about the methodology today, mostly due to time limitations, but if you have questions, of course, I'm happy to answer questions. But so I have software that implements this methodology, and it has evolved over time. Originally implemented in R, then I moved it to Python and Qt, and now rewriting it again in OCaml and Tcl'2019. Uh-oh. Let's see if we can get that back. And the move to using OCaml and Tcl' has really helped me sort of think about how I use programming to essentially conduct research and conduct methodological research. And so I wanted to talk about that a little bit today. So what we're doing is we just had a bunch of talks that were like really, really deep and technical, and now we're going to have a little whiplash. I'm going very, very sort of high level and abstract about sort of knowledge production via programming. I assume most of the people in this room know Ousterhout, who, if you don't, invented Tcl' back in the 80s. And fundamental to, does anyone else need copies of the slides? Did everyone get some? So fundamental to the design of Tcl'2019 is this idea that he has promoted in various venues of using two languages for any sufficiently complex system. Right? And this is the idea that you use a system programming language for the low-level stuff where performance matters, for complex algorithms, and then you use a high-level scripting language for gluing stuff together. And we've seen lots of examples of gluing stuff together today, and people talking about sort of the advantages of Tcl' for this. Okay. I want to highlight, in one of his comments, he says, I think these two programming environments are so different that it'll be hard for a single language to work well in both. People aren't paying attention to this. I wasn't really thinking about this. I've read his scripting piece, over the years, but I didn't really think about it a ton until I started rewriting my software and sort of rediscovered this. And I have a slightly different take on it. I'm new to Tcl', so I've only been working in it for about a year now. I came to this conference for the first time last year, took Cliff's tutorials, and we've been working.
Okay, I was wondering if that was the same plant.
That's the same plant. That's our friend Cliff. And in the preface to his text on Tcl'2019, he talks about researchers. Right? I'm a researcher. And he says, there are these sort of two approaches to doing research. One is what he calls the prickly theoreticians, who are really looking at abstract theory. And then he talks about the GUI empiricists, who are really starting from the data and building up. And he says that what researchers have found, and he's exactly right about this, is that what we really need to do to develop knowledge is move back and forth between these. We move back and forth between our theory and our data, and our data and our theory. And going back and forth is how we figure things out. And then he says, I think the same thing has emerged in computer programming, right? And this is Ousterhout's dichotomy, that we have some people doing sort of this heavy theory-oriented programming. This is the systems programming problem. And then we have other people who are doing sort of the sort of real-world, day-to-day scripting language type of thing. And he calls them the planners and the doers. Okay? And he very much says, I'm a doer, right? This is why I like Tcl', I'm a doer. Okay. So, Cliff is exactly right about this difference. Okay, so in the research community, we talk about inductive versus deductive research, right? And inductive research is where you start with your data, you look for patterns, you just look to see what's out there, and you build up your ideas. In deductive reasoning, you start with the ideas. Okay? And deductive reasoning, this is the classic scientific method that we all know, right? You have your theory, you come up with a hypothesis, a prediction of what you expect to find, you collect some data, right? Then you test your theory, see if you're correct, right? And so this is the basic difference here. I'm going to pour myself some water. Sorry. Okay. So I'm going to give you sort of the highlights of this talk. which is that I think that programming languages and how and what we're trying to understand work together. But there are different ways of looking at this. And so there are different development strategies that have been developed over time. And part of what's going on here is trying to understand what is the domain that you're interested in. And the term domain is an overloaded term in computer programming. We use it to refer to a bunch of different things. And what I want to distinguish between is what I'm calling the application domain. And this is sort of the world of business rules and processes and how you actually accomplish something, versus the analytic domain, which is, okay, what is this thing really about? What's sort of my underlying model? How do things fit together? The other thing to sort of pay attention to is how much is known about this domain. Do we already know a lot about this domain or not? And the argument that I want to make is that when you cross these, we come up with sort of different design techniques and different languages being appropriate for these different cells, essentially. So when you're working sort of within an application domain, okay, and you're trying to figure out sort of how to accomplish a task, okay? If sort of it's already known how to accomplish the task, the programmer still has to learn it. So the programmer has to learn either how to do the task themselves, or they have to rely upon domain experts to tell them how to do the task, right? So if you're creating, a banking system or whatever, you have to talk to the bankers or whatever it is. Okay? And this is where domain-driven design comes from. And if you read about domain-driven design, this is all about the idea of you have to have domain experts. And the whole idea here is that there's already this knowledge about the domain out there. On the other hand, if you're not really sure what the task is yet, right? This is the case a lot with programming. You're like, well, we want to get over here, but we're not really sure how to do it. So if you don't really know how to do it, it's unknown. This is where like Agile comes in, right? And it's this idea of just massive iteration, back and forth to figure out what works. Oh, this isn't working, let's redirect, let's go somewhere else. Okay? Scripting languages are great for these. Okay? Why? Because you need this rapid iteration. Okay, and am I on the right track? Yes, no, yes, okay, keep going. No, let me sort of reconsider what I'm doing, and I haven't lost too much. On the other hand, I don't think that scripting languages tend to be as good for these analytic domains. Okay? The analytic domain, I'm going to give you more examples from my own work here, but in analytic domains, you're really trying to understand what is this thing I'm interested in. If the domain is known, so for me, it's like a research method. It could be building a compiler. Okay? If the domain is known, the ideal thing really is a DSL, a domain-specific language. They've already implemented it. This is something that lets you work within the domain. You don't have to think about it too much. That's great. Or a systems programming language can work really well here. The example development strategy here is test-driven development, right? In order to write the test, you already have to know something about it. You have to know what to expect. So if you don't know what to expect, you can't write your tests. And in fact, that's where a lot of I exist, is I'm working in this methodology and I'm not really sure what I'm aiming at yet. Okay? I tend to exist here a lot of the time, in this unknown area. And what I found is when I'm trying to understand sort of the algebra underlying this methodology that I work in, and this is novel, okay, systems programming languages have really helped me get there. I don't know a really good example of this. Connell Elliott has his denotational design, and that's an example of what I'm talking about here, but he sort of presents that as purely functional. And so I don't know if there's a more general term that someone's using for this type of thing. So I'd be interested in feedback. Yeah.
What I tend to sit a lot in the analytic unknown space, and a lot of things end up being what we call emergent, and it's usually a mingling of actual scripting languages and system programming languages.
It can be.
There's a problem with decomposing.
Yeah.
And then either read that.
Yeah.
But it's not at all like admin.
Right. Yeah, I would agree. I'd like to talk to you more about that too.
And I do a lot of expert system programming, and what usually ends up happening is you start on a script level, and then as it gets sufficiently more detailed, we either end up having to optimize it in a systems language, or we find the only way we can enforce our rules in a consistent manner, given the things that we have. So it's
And I'm going to argue that that approach, which is sort of what is being recommended now, is do as much as you can in a scripting language and then drop down to a systems programming language only when it's been demonstrated necessary. I think that that's problematic. And certainly in my methodology, it has hindered the development for reasons that I'll talk about. Okay. So programming is knowledge creation. Essentially, I've said some of this already. Scripting, I think, really complements this inductive reasoning, because what you're trying to do is model this application domain to try to solve an existing problem, something that is already out there. And so you need this rapid acquisition of knowledge. You want this iteration. And so what you want more than anything is ease and speed of writing and deploying code, right? And what Tcl' really, is fantastic for this. Everyone here knows this. Systems programming, on the other hand, I think complements deductive reasoning, right? Because in deductive reasoning, what you're trying to do is develop this sort of model of this analytic domain. How do things really fit together? And what you're looking for is this deep understanding of these abstract entities, how they relate to one another, right? That's the algebra, how they relate to one another. Casing, really understanding what this thing is, what is it, and trying to figure that out. And so what you're really looking for here are these semantically meaningful abstractions. And you want to avoid logical errors, like trying to link or compose disparate types, disparate entities. And systems programming languages, because of their strong typing, can help you avoid a lot of syntactical errors. And that can be really, really useful. Critical. So what is qualitative comparative analysis? As I said, I'm going to sort of blow through this. This is a technical definition of configurational comparative methodology that uses set theory and Boolean algebra to investigate multiple conjunctural causation. I'm sure that doesn't mean much at all to you. Essentially, what QCA is we use set theory to analyze empirical data. So we're looking at superset subset relationships. So simple example is religious fundamentalists are almost always politically conservative, but just because you're politically conservative doesn't mean you're a religious fundamentalist, right? So you've got asymmetry between those sets. The key thing, and I can talk more about it, but the key thing to understand here is it is not a statistical method, okay? So all of your understanding of statistics, they go out the window, because we're now in the world of set theory and Boolean algebra. What I found in my software design that I've been working on since grad school is I'm really doing two things. I'm working in both these domains. One is to sort of understand and advance the QCA method, and then the other is working on how to conduct QCA well. And so I've been working on both of those, and I didn't really understand I was doing both of those until this latest iteration, where I started rewriting it in both a systems language, OCaml, and a scripting language, Tcl'2019. Okay. So some of the problems with sort of this new approach, or let's do as much as possible in the high-level systems programming language. I think this emerges partly out of Knuth's line about premature optimization being the root of all evil, right? It's like, okay, well, don't worry about if your scripting language is a little slow, right? Don't worry about that. Do as much as you can, because it'll be easier to modify later, that type of thing. But then you also get things, so this is Marlutz in I think it's learning Python text, this big or something. I mean, it's insane. And he really promotes this idea of just use Python for everything. And so he says, the only downside to Python I found is, as currently implemented, its execution speed may not always be as fast as that of compiled languages. as a general purpose programming language. Its roles are virtually unlimited. You can use it for everything from website development to gaming to robotics and spacecraft control. And there really is this idea of just use it for everything, even though it's C underneath a lot of the time. And a lot of the libraries are written in C. The Python programmers don't have to know about that. They don't have to be aware of that. They don't have to even think about that. Okay? And there is this idea of just like do everything you can. And Python's a really good example of this. If you think about sort of its standard library of like, we're just going to add in everything we can. Okay, so this is really departing from Ousterhout's dichotomy of use two languages. There's a reason for this. So I'm not going to go through this too much of how my software has evolved. I did originally write it in R.
In that previous slide, what was the point you were trying to make there between the two, juxtaposing the two quotes against each other?
That I think people have taken this idea of premature optimization being the root of all evil, and it's now scripture, and it's a good justification for writing everything, writing as much as you can in a scripting language. And what I want to argue is starting with the scripting language can be detrimental.
I would agree with that, and I would add that the missing piece of that is not that I want to optimize early, I want to know if I can optimize later. If I can't optimize later, I can often be completely screwed. And much of what I worry about building things is only whether it's optimizable later. Because if I can't, or I don't know that question, then making the assumption to go to the other could actually be very problematic, which I think is what you get.
A little bit, but I'm even going to go further and say it's not always about optimization.
Well,
It's not just
optimization might not be about performance, it could have other.
Right, but I'm going to say it's not even necessarily about optimization. I'll show you some examples of that in a second. Okay, so very quickly, because I know I'm going to run out of time. So I originally wrote my software in R because I was using R. I'm a social scientist. I hated it. It's really painful to use. I now own the domain name rsucks.org. There's nothing on there, but I do pay for it every year. And then I rewrote it in Python. I've been using Python for years and years and years, and so I rewrote it. And overall, it was a lot better than R. But I did over time. One, I had performance issues. The algorithms, so all the electrical engineering majors here, one of the main underlying QCA algorithms is the Klein-Mikulski minimization algorithm. And that's very computationally expensive. And so I still had performance problems, but the biggest issues that I had was bit rot. And every time I would come back, because I'm a part-time programmer, things just would break. And that was really, really painful. Deployment was really, really painful. Every time I had to be sort of hacking stuff away to make it run, especially on OS 10 for deployment. So then a couple of years ago, I got tenure. And then you're like, oh, well, what am I going to do? And I said, oh, maybe I'll rewrite my software in like a new language. And so I started looking around, and I've always been interested in functional programming, and I chose OCaml, which I've really fallen in love with. And then a little while after that, when I realized it wasn't going to meet all my needs, that's when I started looking at scripting languages again, and discovered Tcl and TK. And then so since then, I've been sort of working on this, and I've split it so that I've got OCaml that I'm using to analyze my analytic domain. That's where I'm modeling the data structures and algorithms. It provides basic command line interfaces, and it solves my distribution problem because I get native platform-specific executables. They just run. It's great. Right? So it's like someone earlier said, like, oh, static linking is an idea whose time has come. Like, yeah, that works really, really well. Okay, and then for my application domain, I'm using Tcl and TK, and so I'm using that obviously for things like the user interfaces. So I've got command line user interfaces and GUI interfaces. And then I'm using it for all these other things like the data management and transformation, for my session history and management. I've got a SQLite layer for persistence, and it also provides easy cross-platform distribution. So that's been fantastic as well.
So you got about 5 more minutes.
5 more minutes, great. Okay. So this is great. I don't have to talk too much about OCaml because Will's discussion on Rust already covered a lot of its advantages. And so, as you know, we can talk about this. The big thing that OCaml gives me here is these algebraic data types, which allow me to really easily express complex and recursive data structures. Okay? And so when I'm looking at modeling these Boolean expressions, it's actually very, very simple to do that. This is modeling a Boolean expression right here. I just have my atoms, not ands and ors. So simple to do. You can use pattern matching to pull stuff out and pull stuff out recursively. That makes things pretty straightforward. Okay. Type inference. So this is something during Will's talk that I asked about. The OCaml type inference is very, very strong, which means you really don't have to do any type annotations. Not any. Sometimes you do, but it's pretty rare. And it will type check the entire program for you. And so this is fantastic when I'm working through my logic of, oh, do these things work together? Does this operation actually work? Does this algorithm work? The type checker tells me when I've made a mistake. And sometimes it's a simple mistake, but sometimes it's like, what's going on here? And I've spent like half a day trying to figure out why is the type checker unhappy? And then finally I'm like, oh, right, Claude, you're an idiot. Got it, right? But it takes some time to sort of figure this out. Okay. And so type inference is super. Okay, so using these two languages has helped me solve a bunch of problems that have been long-standing in the QCA world. Some that I didn't even quite understand before. One is, thanks to OCaml, now I have symbolic Boolean computation in the software. No one has done this. There are a bunch of QCA software packages out there, but they're all just sort of parsing textual strings. And so now we can actually have arbitrarily complex Boolean expressions, which is super helpful. We can put QCA on a real foundation of set theory. We can also associate Boolean expressions with particular constraints, which no one's really been able to do before. So there's certain conjunctions that are impossible, such as being male and pregnant. We can now say that can't happen. We couldn't do that before. In my software, you could manually mark it off, but you couldn't sort of do it in a simple way. And we can also sort of put in sort of our background knowledge and apply it to these Boolean expressions as we're trying to model the data. Okay, this is just all code to look at different things. I'm going to skip it. A big thing that I've been interested in for a long time is modeling missing data, and I've written a couple of papers on this. QCA currently can't do it, and so all you can do in QCA is list-wise deletion. If you've got any missing data, you drop out the entire case. QCA is often used for small n stuff. I'm doing an analysis of 9 right now. You can't just drop that out. That's a real problem. And so I've been extending QCA's two-valued logic into, now lots of people here know SQL, and we know what problems SQL's three-valued logic and use of nulls can cause, right? But that's not good enough. So we have to use a four-valued logic because there are in fact two forms of missing data. That in SQL we just use nulls for both, but you can have unknown data where we just don't know what the person's birthday is. Or you can have inapplicable data, right? The person doesn't have a salary. And so Hipp, who developed the relational model in his version 2 of it, actually proposed a four-valued missing logic, two types of nulls. And this is essentially what I'm implementing. I'm implementing a slightly different version of this. So, you know, if you think, you know, three-value logic is complex, like QCA logic is just like, it's a real pain right now. Okay, this is sort of how a lot of it is implemented. I'm going to skip it. Okay, so that's sort of some of the things that using OCaml has helped me figure out. Using Tcl and TK, one is finding ways of doing QCA well. And QCA really does emphasize this retroductive process of going back and forth between your theory and your data that I talked about at the beginning of the talk. So what I'm developing then is an extended Tcl console, right? And so this is great because Tcl provides this basic foundation for all the data management, transformation, math, and statistics. I can easily call out, right, to external programs. And then I just add in my commands for conducting QCA, which are often just calling out to my OCaml code, right, to my command line scripts. This also is where I can put all sort of this stuff that I'm exploring. Of, oh, here's a function that I don't know if it really works, or one person wants this. I can provide it as for a text-based console interface. I'm also writing the GUI, right, which is sort of user-friendly, but highly, highly opinionated of how to do QCA well. And so the GUI sort of forces you, it's very limited, it forces you to conduct QCA in a way that will give you decent results, okay? To make it sort of hard to do it poorly. In the past, I've split those. They've been different applications, the command line versus the GUI. Now I spawn the GUI from the console. So we have all of this together. And that's super, super useful. And because it's in Tcl'2019, it's super easy to modify as I'm trying to figure out how to help people do QCA well, how to help me do QCA well. So that's one thing that it does. Another thing, this is a little bit, and I'm almost done. This is a little complicated to explain, but okay. In sets, basically you can be in the set or you can be out of the set. Or you can be partially in the set, that's a fuzzy set. So you're mostly in the set of rich people or something like that. A lot of people have always wanted sort of nominal level variables where you can have sort of QCA where you have something like race, where you're white, black, Latino, or Asian. Or here I have an example of you can belong to one political party, Democrat, Republican, Independent, I see you. That doesn't fit into the Boolean approach, okay? But people have tried to do it, they've broken the algebra, it doesn't, people want this. What I finally realized by splitting this out is now in the Tcl level, in the application level, I can simply convert between these multi-valued sets. I can convert the multi-valued sets into crisp sets. Okay? So instead of saying, oh, which member of a political party are you, Democrat, Republican, or Independent, then I just split it and say, okay, you're either Democrat, you're not a Democrat or you are, you're not a Republican or you are, you're not an Independent or you are. And then I can also classify certain combinations as impossible because you can't be both Democrat and Republican. And so this turns out it's just syntactic sugar. This is something people have struggled with for a long time. There are a ton of articles about multi-value QCA and is it good or is it not? And I've always been on the side, well, it's not, right? Because it's not Boolean. It's not set theory. But in fact, now I realize, oh, it's just syntactic sugar. And I can just convert at sort of a high level. And all the OCaml code, all the application domain doesn't even need to worry about it. So that's been super, super useful. I've solved a problem that a lot of people didn't really understand, and it's been a big argument. Okay, so implications. This is my last slide. What I want to argue is that Ousterhout's dichotomy isn't just about performance, but instead, scripting and systems programming languages offer different ways of conducting research, conducting inductive versus deductive research. And that we have a problem now in prioritizing scripting languages because you might have a mismatch. And certainly this is what's happening in the QCA world of almost all the software has been written in R or Python or some other high-level language, and it's sort of blocked us from understanding the analytic domain, understanding how QCA really functions. Okay? And yeah, and so there's this mismatch of thinking, oh, the scripting language can get us there. Maybe if you're smart enough, you'd be okay with it, but I'm not. And what I found is using OCaml has helped me work through a lot of these problems. at the same time, scripting languages are more accessible. One of the things that Ousterhout talks about in his scripting paper is casual programmers are going to be using scripting languages, and he's exactly right about that. So how do we do this? Because a lot of researchers like myself aren't trained as programmers, right? We pick it up along the way, and often we're pretty crappy programmers. So I have three possibilities here that we start thinking through. One is maintain the conventional split between the researcher and the programmer. Have the researcher hire a programmer to do it. But then there's a divide there. The other thing to do is continue working on DSLs. So maybe at some point I'll write a QC DSL. I don't know. I don't think so. I've thought about it. I don't think that that's going to happen. But there is also more work towards sort of high-level systems programming languages like Rust. OCaml might fit in there as well, although it's not all that easy to shell out. And then the thing I really want to emphasize is thinking more about sort of the distinction between the GUI doing problems and the prickly planning problems. And thinking about that and really thinking about which language is going to support what I'm doing. And sort of picking the language appropriate to that. And indeed, that is what Ousterhout said. He says at the end of his scripting paper, he says, I hope that programmers will consider the differences between scripting and system programming languages when starting new projects and choose the most powerful tool for each task. And this was echoed by Andy Hunt, Dave Thomas, and the programmer as well. Program close to the domain. And this is what I think this dichotomy gives us, is figuring out how to program close to the domain that we're interested in. All right, I know I'm over time.
I'll take a couple questions.
So maybe more a comment than a question, because my job is to provide tools for researchers.
I'm sorry.
I think for me anyway, what's important is the known unknown dichotomy.
Yeah.
If I don't know how the user is going to use my tool, then I provide them with a scripting language. But there are cases where I know that there's things that they're going to have to put into the compiled code. And so what I tend to build are application frameworks with very small slots they can plug into. In the first talk I gave, when you looked at the structure of spectral, there was that big blue box, which was the user's data analysis pipeline for taking the event data that I have no control over the structure of and turning it into a bunch of parameters that the framework knows how to deal with. So I think there's room for both systems programs if you want. That chunk is like C++. And there's also room for scripting languages at the researcher end. And again, I think it's more like what Karl Marx said, which is from each according to their abilities and to each according to their needs. Was that Marx?
Yeah. Yep. I teach a lot of Marx.
There you go.
Yeah.
So,
I wouldn't disagree.
One more?
So I think one thing to consider is also business pressure. Even in the university setting, you have deadlines. I think one advantage of scripting languages is that you can quickly demonstrate success and then go from that. And even though you may be always interested in optimization, I think that gives you some more time and more resources.
Oh yeah, no question about that. What I would say is, I think that there can be, what I've seen is, I think the scripting language can end up hindering development though, because it's not letting you really think about your data structures in a fundamental way and your algorithms in a really fundamental way, because it's sort of handing it to you there. Oh, here's what already exists. Use these.
So you take technical debt, but you make more money and pay it back.
Well, there's a reason that I only started doing this after I got tenure.
One point in that is that there's expressibility in that you can't have in scripting languages. Yeah, sometimes the ability to express and reason and describe that is the essential element. The comment I was making earlier about mature optimization is really a question about, I don't know what the answers to these might turn out to be. I have to make room for that. Yeah, that's really what I meant.
Okay. Yeah, and I agree with that.
I think that also goes the other way. There's expressibility in some scripting languages that you can achieve in compiled languages, but with great effort and great difficulty, such as the ease with which you can create a TK GUI compared with what it might take to do it in Motif, X, Qt, take your pick. And so that's another place where I use scripting languages. I want a GUI, and I'm not gonna spend a week or 2 weeks doing a Qt GUI when it'll take me a day or two to do a TK one.
You have really complex systems and you're building them, and then over time, they get shipped, and you get legacy, and now you want to try to fix something, and you realize only later something emerged where you needed to change. That's the part of your optimization struggle. It shows up a lot with long-lived or complex, and I encounter that much of my career, and that's the thing I usually worry about most when I build something. It's actually that space.
I agree. We're going to have to close this for right now, but I think it's clear that Claude, your talk has generated a lot of interest. You're going to be around at dinner, of course, and we'll be up in the hospitality suite later. So I think there could be some pretty interesting conversations to continue. Next up, I want to bring up Don Porter. Don, I would say he needs no introduction, but I'm sure there's some people who don't know him here. Don has worked as an electrical engineer in the National Institute of Standards and Technologies Applied and Computational Mathematics Division since earning his doctorate from Washington University in 1996. Don's a charter member of the Tcl' core team and is likely best known for his role as the Tcl' release engineer. He rolled all the releases for the last super long time. He's an active maintainer, contributed to many areas of Tcl', including script and expression parsers, namespaces, command evaluation, and I/O engines. This is a blow-away statistic. He's responsible for about a quarter of all check-ins in the entire history of Tcl' development. So this is like Mr. Tcl now that Ouster had stepped back, right? Anyway, Don's here to talk about the state of Tcl. Please give him a round of applause.
Just hearing that bio, I wrote that a couple of years back. I'm not sure that statistic holds up as much as it once did, but there's an awful lot of commits in there, and a lot of them are maintenance type things. But anyhow, so that covers actually a lot of my opening commentary was going to be who I am, why I'm here. This is a talk I pretty much give every year now. It's kind of a descendant of the talk which all used to be titled The Active State of Tcl, when we would have a representative of active state here to talk about how the language had evolved, but also customer statistics and are they getting downloads from Windows or from Linux and all kinds of corporate stuff like that I don't have any of that to share with you. So always, since I took this over, it's been a little bit of a different character of a talk. I think that talk in turn descended from Ousterhout's original talk when he would give at each of the conferences, and he would have his famous Ouster votes, and people would express their opinion about what they'd love to see, and we would hear once again that we really needed printing on Windows, and still never would seem to happen. So that's what this talk's about. Those of you who are perennially here, it's going to look very familiar. I don't have a lot of innovation, but hopefully at least a few bits of updates that might be of use to some of you. So general outline I'll talk about. This is just to keep me organized. I wanted to start with some updates to the core team membership. And I'll start off with, this is actually correcting for an oversight that I had last year. We received a retirement letter of resignation from Joe English back in January of 2018. And when we got to the conference in October, November of 2018, and it happened so long ago, I forgot to mention it. So we didn't mean any disrespect, but we do wish Joe well on what he is doing with his life these days, and we thank him for all of his many contributions to the Tcl world with his time on the team. On the flip side of that, we have, this is, I guess, the time to make a formal official announcement that we have 2 new members of the core team this year. Mark and I agreed to claim this happened in July because neither of us can really remember the exact date, but we did extend invitations to both Mark and to Kevin Walzer, and they've both been very important in maintaining and really advancing the state of TK, especially on the Mac platform. And we were fortunate they both agreed to come and join in. So that's very good, and I hope I'm not going out of... yeah, you picked up the cue. And then, of course, we have our dirty dozen of existing team members who are continuing. So we're at a total of 14 right now, which seems to be about where we stand. We lose one, we gain one, we lose one, we gain one. We seem to go along pretty well. So continuing on, often you mentioned in the intro, I'm the release manager of Tcl and TK and associated products. And so usually what I fill most of this talk with is release information and release announcements and what's happened in the last year. And so here's the release we had in the last year. When we were at the conference here about a year ago, I had essentially this slide in place, but instead of a release date, I had coming soon because we were really trying to get this out the door and we were just getting with the last little bits of cleanup done. So if you were here at all last year, you've already heard me go over what these new things in Tcl 869 were and TK 869. Now this is a year in the past, so you've all been working with this stuff for a year. There's really not much to be said here, I wouldn't think. But then we get down to the bottom here, and we were really trying to put enough Mojave support into TK that we felt we could release it. That was one of the things sort of holding back the release last year. And shortly after the conference, we got it where we wanted it, and I was putting it all together and pushed it out the door, and I don't know, was it minutes later when the alarm came back? What did you do? And I had totally botched some aspect of the Mojave TK implementation. So following the release of Tcl TK 869 in November, we had the quick release of TK 8691 also in November, where I had to repair this botch that I introduced because I didn't know what I was doing and I was not working on the platform where it mattered. So sorry for that, but I think time heals all wounds, and so we're moving on from that. But yeah, I had disabled one call, and that one call was in a branch where it was only effective on Mojave and later. So I'm testing on my more obsolete Mac at the time and never caught the problem. So that's where we were in November of 2018. What about the rest of the releases since then? Oh, we didn't have any more releases since then. That takes us to now. I'll just mention more about this later, but I'll just mention this is the second year in a row that I've told that same joke, that I had plans for more releases and I got one done in a year. So I regret that, and I'll have more to say on that. Now find ourselves that, again, we're trying, conference really gets you going. It puts a little stamp on the calendar, says get something done by now. I had hoped to have these releases out at this point, but the fact that they're in progress, I think, is good. So here are the releases which are lined up on the runway ready to take off. Tcl and TK 8610 are available in release candidate number 1 format. We've been through RC0 about a month ago. Got a lot of great feedback on that, a lot of good improvements. Now they're at RC1. The aim is to make these a real release on November 21st. They've been at RC1 for maybe 2 or 3 days now. Already have had some feedback come out. There will be an RC2 at least, which will become the release, but November 21 is still looking like a good target date. This date was actually proposed by Mark because he had just put in even more of these many TK improvements for Catalina, and a handful of them, I guess I would say, were ambitious enough that we were hoping to get broader testing before we really pushed it out and felt we couldn't take it back again. So that's why this is an RC1 rather than a release at this point. The highlights of what's in these releases, top of the list are the many improvements to TK, especially on Catalina. If you didn't see Mark's talk, that's very useful. Let me summarize this very quickly, because when he was up here and showing the widgets on his system and saying, in some important cases, those numbers were being reached, and we needed something more powerful. Normally, we would like to keep things like that out of point releases, push them off to the next minor release. But when things are failing, you got to get it out. So, I think I'm going to leave it. Oh,
What kind of failure is a double click not being recognized?
right. I do want to mention Tickle, which is a bundled package with our source code releases. We have bumped to a new minor for iTickle 4.2. Those of you who are considerable Tickle users, I think you'll want to try this out. I think you'll be very happy with the big performance improvement on memory processing when you have large numbers of objects. Sergey Rester has contributed this, and depending what you're doing, it can be thousands of times faster. Now, this is his performance benchmark suite, which of course is meant to demonstrate that. So maybe your case won't show that, but there are some potential big improvements there. There's also a new feature for the info variable method for your iTickle objects. There's now a scope option, which I think you had, Brian, you had been asking for some time. So now it's available. Lots of bug fixes, all the bugs you can fix in a year. The other release, which is teed up on the runway, is 8.7A3. It's out in its first RC0 configuration. This slide, except for the release date, also aiming for November 21. And besides this number here, is exactly the slide I showed a year ago. So these are new things in 8.7, which are still unreleased. So we have not had a release of 8.7 since 8.7 Alpha 1, which was almost 2 years ago now. So we've got a lot of new functionality ready to go out the door. When I made this slide a year ago, the red things seemed to me like the things that were either big, sheer, great new features, or changes that you might want to take a good look at while we're still in alpha, because it's possible they might be disruptive. So you want to don't let this go by and get surprised when it becomes 8.7.0.
Are all of the changes that were in 8.6 also in 8.7?
They are.
Yeah. Okay.
Yes, the time rate command in particular.
Yeah, I was just looking on the website, there's no mention of it anywhere on like, the documentation. I guess that just hasn't been updated yet.
So you're looking on the www.ticklelang.org website?
I'm looking at the bookmark on my browser. Let me see where that goes. It goes to, www.tickle.tk man.
Okay, are you looking?
Tickle 8.6, I tried both, and there's no mention of time.
Tickle 8.6 you looked at.
Yeah.
Look at Tickle 8.6.10. That's the online 8.6.10.
Oh, cool.
Which will slide into the 8.6 slot when the release
There's a
goes.
time rate command there. Excellent.
There you go. And one of the reasons we did, in a sense, backport time rate to 8.6 is because we wanted to use it as a tool to compare how is 8.7 performing compared to 8.6. We needed the same tool in both camps. This was also the same a year ago, a whole bunch of new commands, subcommands, options in 8.7. I'm going to blow through quickly. This was also here a year ago, pointing out that some of the changes in 8.7 are essentially bug fixes, but they were disruptive enough that we wanted to actually have a discussion about them before we're just putting them in there. Some things are being removed in anticipation of even more things being removed in Tickle 9. So if any of you are in love with the identity encoding, you need to find a new partner before we move to 8.7. Similar things along those lines. And then now, just extended this, even more new stuff in 2019. And I tell you, the amount of tips going in has just been remarkable. You've been a driving force behind a lot of it. There you go. So some more new commands. some more functionality in Tickle Test. Someone put cookies in our HTTP. See what else strikes. This might be the oldest tip to still successfully go in. And it's been baking for I don't know how many years. And eventually things, the fullness of time came about and it was brought in still more. And here we had even more new commands. Those of you who are coroutine enthusiasts might like to look at corow probe, corow inject, some string manipulation, some list manipulation, more link bar types, operators for string comparisons that can't be confused with number comparisons, some floating point tools like isNaN, isNormal, FB classify, that'll help you do some of your finer IEEE floating point work. So let's see, is that the end of my 8.7 tail? Yeah. So a lot going in and trying to get it out the door. So help us get it out the door by trying the release candidate. So we can get you all of that goodness in a real honest to goodness release. And here, I guess, I don't know if we need a drum roll for this or not, but this is the first alpha of the first release. In its first release candidate is online now for you to try and enjoy. The aim is to also get this out on November 21. Now, I don't know how busy I'm going to be on November 21, so if some of this pushes back a day or two, forgive me, but I really want to get each of these out so people can start seeing how these new minor and new major releases can work for them in the work that they've been doing and the work they want to do going forward into the future. Most of this is a year old. A few things are new. Since last year, we've had some of this, some more work on expanding from 32-bit limits to 64-bit complete support. In particular, we put support in for regular expressions. Your indexes can now be 64 bits in length. So that's very helpful as you're trying to really push some of these things to their limits. Do I have more on this? Oh, okay. The feature set here that's gone into 9, this is in addition to everything that was in 8.7. And some of the things in 8.7, see if I can come up with a good example. The idea of having Tcl'9 and Tcl'8.7 in development in parallel is that what we're trying to do is get Tcl'9 out. But as we discover new features in Tcl'9 need assistance for people who have been writing in Tcl'8.6 to get there, the idea is to put into 8.7 those migration tools necessary to bridge the gap. So that's why they're being developed in parallel. That's why they'll be taken to beta at the same time. They'll be taken to final at the same time. So the idea is that eventually you have 9.0.0, 8.7.0, both out. And for folks who have an established body of code, migrating up through 8.7 to 9 will be a better path than just trying to go to 9 directly.
How long would it 8.7 do?
I'm not seeing a great example leap out at me, but if you want to talk more about that, come and find me and we'll discover one. Okay, so I mentioned that I've been unable to get lots of releases out on a regular basis, and there are good reasons and bad reasons for that we don't need to go into. But I think in order to make the next coming year different, I'd like to put out here a very sketchy, approximate roadmap that around March 1st, we'll do another round. Around July 1st, we'll do another round. And when it comes time to come to a conference again in the fall next year, we'll do another round. So the idea here is by saying that here publicly, if it's getting to late February and you haven't heard anything at all from me, give me the little nudge and say, you know, we were really hoping that we'd have another release on March. And I think that accountability, if nothing else, will increase the likelihood that we have some more toys to play with through the year.
By release, you mean production release or?
I mean 8.6.11 plus 8.7 alpha 5, it would be 9.0 alpha 3, it would be. So to get all of those out. At some point, the alphas become beta. I feel comfortable as a release manager pumping out alphas without a lot of accountability. I think I need a TCT vote for us as a team to declare, okay, it's feature complete, we'll go to beta. So unless something like that happens, they'll just continue to be alphas. And at that point, I should probably say something about when will 9 be done. Since I've been so bad at predicting the number of releases I can put out, I'm going to be even worse at saying when it will be done. But what I can say is there's a handful of things I think need to be in 9.0 before I'm happy with it. I think we need full 64-bit support where we have 32-bit limits. I think we need to be able to support the entire Unicode character set. And I think we need to have enough opaqueness put over our interfaces so that continued development can happen without tripping up on implicit interface guarantees. Once those 3 things are done, I'm happy to call it 9 and let further improvements go into 9.1, 9.2.
So basically, hiding private interfaces allows development to be faster.
Not have so many open structs. We've had a devil of a time suppressing the interp result. And the more of those windows we can close from the get-go, the better off we'll be.
Interpreters always the guts to take a hash, they believe in the guts to take a launch.
Yeah. A lot of people use Fossil, right? At least you've heard enough about it this week, you know what I'm talking about. Tcl' and TK are developed in Fossil, and we use the branching capabilities of Fossil quite a bit. We have many active branches, which lets me do these releases. There's a branch called Core 8.6 branch. That's where we fix bugs. That's where the 8.6 point releases get released from. We have, for Tcl', something called Core 8 branch. This is where the 8.7 releases come from. It's only called Core 8 branch as a hedge. Some wacky reason we needed 8.8. We can branch 8.7 off and continue with 8.8. I'm not predicting that. This is just an insurance policy, so to speak. TK doesn't have this branch because the TK trunk is where the 8.7 work is happening. To date, there isn't a TK9. Welcome to start one if we need one, but so far the aim has been to have TK 8.7 be an exemplar extension that you can build it against 8.7 headers and load it into Tcl' 8, or you can build it against Tcl' 9 headers and load it into Tcl' 9. You have one source code base which serves both execution environments. And it's this strategy we think which will let extension authors bridge those 2 worlds so we don't end up with a dichotomy of a whole world of Tcl' 8 over here and a whole world of Tcl' 9 over here and no crossover. Some other language communities have tried that and suffered pain for it. So we're going to try something different. So the tickle trunk is what's producing the 9.0. And I don't know how I'm doing on time. That's really all that I've prepared. One of the purposes of this talk is to try to say, well, what's happened in the tickle world in the last year. I focus on releases because I do releases. So usually what I try to do at the end here is open up the floor. People who know of something that I'm not thinking of just because I overlook it, feel free to shout out what's happened in Tickle or in TK that you think was remarkable. Is there anyone who wants to offer anything? Okay. I think that's all I have then, so thank you.
All right, thanks. Thank you, Don. That was a really good update, and this guy is carrying a lot of stuff. Did I see a question or something?
Don is up to 27% of all check-ins.
All right.
All right.
All right. Only 83% to go. 73%. How much? Donald's got what? 15%. So we've got 42% of the Tickle check-ins represented by these two guys. No, these two. That's what I'm saying. Okay, next up, we're going to bring up the Tickle core team panel consisting of Andreas Kupres, Kevin Kenny, Brian Griffin, and Don Porter. I've introduced Kevin and Brian and Don, so I want to introduce Andreas. Andreas is a senior developer at SUSE. He was previously at Hewlett-Packard Enterprise, and before that, a senior Tickle developer at Active State. He has a master's degree in computer science, is a member of the Tickle core team and the Tickle release manager. He's also the primary author of more than 25 modules and extensions, including TRF, or TRF, and MemChan, and a key person who's causing these conferences. So please welcome, we have a couple more people here. Please welcome the Tickle core team. Take it over, y'all.
Okay. I guess as a panel, it was also called Tickle core team roast. Roast. So it is basically a bit of an open question and answer session. Questions from the yes, from over there.
I'd just like to say, having seen Mark's presentation yesterday, that I'm delighted that he's up there.
I would like to second that.
Well, could I say that I'm delighted to be here? And I showed up here never having met face-to-face any member of the TCL community. And you're great.
So at a high level, could you state kind of like how 8.6, 8.7, and 9, like where things would be going? Like especially between like 9 and 7.
Well, I mentioned the three things I want to see before 9 is done. I think of 8.7 as a migration aid. I wish I could have found what I was looking for. I think I've got some good examples in that list of 8.7 features where there's a tip which actually proposed changes to both 8.7 and to 9, where the changes in 8.7 are meant to give you an assist to getting to the 9 changes. I should have had that example in my pocket. I didn't, and I still don't.
Yeah, what Joe English used to call retro forward compatibility.
This is a great example. The example is the work that's been done on the Unicode. So, for example, in 8.7, we will have proper support for doing stuff with surrogate pairs, which means that you'll at least be able to move non-BMP characters through Tickle and get them actually so that they will display in TK and things like that. But it's not going to be complete because there will still be operations that are wrong with them. Like things like string length.
Yeah.
Whereas in 9 that should be all fixed.
How much time do I have to stop using the deprecated interfaces before it's too late?
If you are satisfied continuing to use Tcl'8,
No,
you're not. I would say try what you're doing with the Tcl'9 release. That's one of the reasons for getting an Alpha 0 release out, is to find out where your sticking points are. Maybe you already know.
Coding on the stuff since, for 2 decades, and so.
Sean?
Have we thought about what we want the package interface to be like for 9? Because I imagine that's one of the areas where we really going to want to tighten down on how one interacts and provide proper mechanisms for all the dirty little acts people have today, or have we not gotten that far yet?
I tend to hear multiple discussions in that question. One of them has already come up on email, on the core mailing list, which is we're now finally putting out something that has the Tcl'9 name on it. And it does what it does when it installs. And the question is it going to keep doing that through the entire life of Tcl'9 releases, or are we going to change our minds? So one of the questions is installation layout. In particular, the semantic versioning movement, which we have a tip on, which is pending. That tip has, in my mind, 2 parts. One of them is this rule of what semantic versioning numbers should mean, giving us a set of the requirements we have to conform to. But the other half was layout issues. So there's a piece of that puzzle. I think you're probably talking more about package command or some alternative command for managing code in and out.
Well, I'm also thinking what would provide in the way of sample extension, how AutoConf interacts with core, what information is exposed, a ton of things.
I have not myself spearheaded revolutions on those. And in my mind, that's not one of my 3 things I need to become 9. But I wouldn't get in the way, I don't think.
Yes, if somebody wants to contribute improvements, we welcome them.
For me, one of the things in these package interfaces would be that we should think about tooling, I think, which could be in the core to help package maintainers, builders, or basically where instead of each package having to know the file system layout, that the core provides a tool and the package builder says, install this package, you have this shared library, this Tcl file, it is this name, this version, and then the tool puts it wherever it's needed. That would be an interesting thing. I don't know how much that would be seen as good or an okay thing from the community. The thing with Tcl packages that we have this long, big set of legacy stuff going back to the first, let's say, I believe, expect, which was just plain configure, and then came configure with TIA macro set. There was no real support for pure Tcl packages, and so we have there, for example, the Tcl with army knife tool. We have my kettle build system. I believe there are other pure Tcl things, and I don't see people. If something new comes, like tooling in 9, I don't see people who use the legacy stuff to actually convert to that, or only a very small part. So in that sense, it is like the XKCD with the standards. You have 13 standards. Oh, let's make something which is unified, and then you have 14, and so on. So there's that also to think about.
Is there any way that we can make it possible, now that we've got a way of tacking stuff onto the Tcl, put Tcl config sh, put headers, put everything that's necessary building against that Tcl in with the library?
You'd have to do that at install time because some of the paths are unknown till then.
There is this Tcl': package config command, which didn't really see uptake.
But, and to answer his question, one of the reforms of Set-Theoretic was packing the library file system onto the back of the DLL.
Yes.
There's nothing that will keep us from also putting Tcl' in there and then providing a means to either introspect into that and pull that file out during the AutoCaml process.
Well, in fact, if we've packed the library file system in there, we have Tcl' inside there, don't we?
No, well, we could, I can put that in the original tip.
Yeah.
But that's brilliant because that keeps us from having to install it somewhere. Meaning that you don't even need an install Tcl' anymore. You would be able to, if you've got a sample of the DLL.
That's right. That's the point of truth. And you can't split them up, get the wrong ones confused with each other.
Right, and then obviously, we're at an early stage. We clearly need better tools to fabricate a new VFS so that somebody that is building a Tcl', building an embedded Tcl' can augment our VFS with their own.
Yeah. Yes.
Behind Sean, are you wanting to talk? Okay. Okay.
I got a question. One of the reasons from going from 8 to 9 is that you can break things. So what actually is broken? Are you breaking in 9? And how much time is there to break more things? And are there more things we're wanting to break?
I believe that was on his first slide, at least for octal stuff and some other things, if you want.
Well, yeah, I saw the list, but I wasn't clear how many of them were breaking changes.
At least for octal one was.
Well, yeah, I know.
Yeah, octal is breaking change. Actually, the
size
Unicode
code
support is breaking change.
Okay. And are the making things opaque, I imagine, or breaking changes?
Yes, and a lot of the 64-bit stuff turns out to be breaking changes because so many of the interfaces have different types.
Okay.
So that's breaking changes at the C level rather than.
Yeah, but what about at the Tcl level? Is there more at the Tcl level?
We're not particularly planning to break very much at the Tcl level. Because we don't think there's much at the script level where there is a mistake. There are a few places where I think we'll be withdrawing certain commands and things like that, where in practice it's turned out to be
this one is still starting up.
Okay.
I activated.
Yeah,
that's right.
It's there.
Oh, I see. It's fading in.
Yeah. There's a few things that are clearly mistakes that should probably be withdrawn, such as unload.
I think it was the last time I was here 4 years ago, I queried people for things that ought to get removed. And I think I've still got that list around somewhere.
Simply looking over it, I think the next variable resolution reform might be something.
Oh, right. Creative writing.
Yes, except that's all certainly going to fix people's
Yeah,
bugs.
that is a breaking change that is likely to fix more bugs than it breaks, even if it were unannounced.
Let's see. There's examples of stuff that's likely to go would be string byte lengths. You almost certainly don't need string byte lengths unless people. As far as I'm aware, I am the only person who's ever actually correctly used that. And this is despite being aware of what a lot of people have been doing. And I was using it to generate C literals, which contain strings that Tcl was going to consume. And that's a very, very unusual thing to be doing.
Just picking up on your question, are we done breaking things? I don't think we are. I think there are more things that can break. Some of them will be harder sells than others, and some of them will have to tip vote. But there's an awful lot of examples in the documentation where documentation says this isn't a good thing to use anymore. We should get rid of it someday, and it's someday. One that comes to mind is the magic command named BG error.
We've had a better tool available for 15 years now, interpret BG error. But people can then use BG error. So that might be a bridge too far. Maybe it's too disruptive, but that would be the sort of thing I'm thinking about.
But it's, again, I still think it's not going to be that many big.
Right, it's mostly things that, a few changes to C code and recompiling is the biggest single thing because of the widening of the data types.
Yeah, that's actually the really big change for most people.
That would be basically native integer int to byte, I think.
That's in 8.7.
And conversions to size T and,
this is
that one.
This is in 8.7.
But that one is huge.
Yeah.
That's the one which actually, despite its weird naming, we'd actually started doing some of it already, but it's without announcing it, but it's a little bit bad. But yeah, that they're using size and so on is I tried once in 8.4 to work out what it would look like. That branch was a disaster.
Given that I see no questions, maybe one for me. What are the three things you wanted to see in 9?
I would like the 32-bit limits, all the important ones to go away. I don't need to lift the 32-bit limit on the return code. I'm okay with that one.
I'd be fine with an 8-bit limit.
But anything that sizes something, which could be a container. I want those all gone. I want the complete character set Unicode to be supported. And I want as few open structs, public structs as possible.
Yeah. Regarding the open structures, there was the question about the Tcl'2019 and how it came, the hash lookup in the free object and so on. And that was a direct consequence of the fact that the customer who wanted the feature also said none of the open structures can be changed at all. And well, it affected Tcl', and the only way was to have this side table associated, because I could not change Tcl' in itself and have the information stored directly.
Yeah.
So these are
that,
the type of things where the open structures are really bad then for us.
right, and that turns out to cascade into quad code, because from outside the Tcl library, we don't have access to the TIP280 information about provenance of strings, and get some of the answers wrong about source code locations.
Yeah, and so this is definitely something we should see into cleaning up in 9.
I hope that by pushing the alpha 0 out the door and sort of waking people up, that, okay, we're not just shooting the breeze anymore. This is really coming.
Yeah. As far as I know, there's also Sergey Brewster Cedrus working on some new Tcl'2019 implementation. I don't remember. It might actually even be for Mentor.
Okay.
But I haven't heard recently about it.
Yes, Sergey has got a lot of good stuff that but he needs to be encouraged to break some things into manageable pieces. Because we can't just go to his branch.
No, yeah. He tends to have very, very big patches which are commingling 3, 4, 5 things.
Only that few.
Yeah, I didn't want to go too high.
So would it be fair to say then that Tcl'9 is not about changing the language in a significant way? It's about cleaning up the technical debt from all these years of Tcl'8 development.
I'd say that's correct, because
Yes.
because where we've had significant changes to the language, which we had in 8.4, 8.5, and 8.6, we've always been able to do it in a forward compatible manner.
Yeah.
And so we haven't really had to introduce a lot of breakage to move forward.
I think that's
Time
a,
is the one where, that's where we actually changed the language itself.
Yeah.
That was a huge, huge thing.
Yeah. So I would just like to say, having not been here for a number of years, that's a major change in emphasis from when I last talked about Tcl'9 with people. What I remember is talking about all of these amazing things we could do, blue sky, that would morph the language in breaking ways. This seems like a lot more sensible and a better emphasis.
And really it has been more that some of the things that we want to do can't be done while we're going crazy accommodating some of these legacy.
Yeah, it makes a lot of really good sense.
But, some of the things we want to do can conceptually be done at a point release.
Mm-hmm.
And we're getting to the point where we don't want to do them that way because we want to get 9,
right?
Make 9 happen.
Yeah. Cool.
I think I mentioned to you privately, and I'll just say it again so people can overhear. The aim moving from 8 to 9 is that most scripts either won't need a change or they'll need some small change. And after that small change, you'll have a new script which will run in both 8 and 9. So that hopefully when this migration is done, there's a body of code out there which is happy to work in the 8 world and the 9 world. So we don't have the kind of discontinuity that's hard to get past.
Yeah, oh, by the way, another breakage is we do not plan to continue to support TBC Go.
Yeah, that's good. Yeah, not a chance that that's going to be.
Okay. I had to think for a minute what that even was.
I still haven't figured out, what is that?
There are tools which let you capture Tcl's internal bytecode, save them to files, and that'll break in Tcl'9.
That's fine.
I am okay with that.
Bytecode change in Tcl'9?
What's that?
Is the bytecode subject to change in Tcl'9?
Yes, we want to get rid of the dual path operations where we have 8 and 32-bit versions of addresses.
Will Tcl'9 make it the case that the bytecode is not an API and is free to change from one point release to the next?
That's why we intended to support TBC log, because that's the only place that it's actually exposed other than the unsupported assembler.
Okay.
Mm-hmm.
And, well, and the unsupported logic that views the bytecode.
Yeah.
So TCL scripts will continue to run for the most part, but C modules or anything like the C may require.
The C extensions will be more involved.
Right.
There will be migrations to contend with.
Right. We want to get to a state where the same extension will compile to run against 8.7 or 9. That may require source code changes in the extension to accomplish it.
So for any of the changes that are in the core in the private C API or C pieces, are there going to be warnings, 8 and 7? People will see then that this is deprecated or you won't be able to do this in 9.
Quite possibly.
The no deprecated macro. There's a define you can set. No deprecated, or Tcl no deprecated, something like this. Announcements has been pretty good about keeping that up to date. That if you make use of that when you're building 8.7, it'll shut down a lot of things which are going to disappear in 9. So you can even encounter that way rather than getting the 9.
Yeah, and we're probably going to have to do more macroification along the lines of Tcl size T.
Mm-hmm.
To make sure that the types that change between 8 and 9 have got macros defining them, so that you can have source code that compiles against both.
Right. It's source code compatibility that we're seeking. Binaries out the window. I could say a little bit about the Tcl object type encapsulation, because that's the example I'm the most familiar with. It's helpful.
or I can save it for offline, whatever you. Now, I put it in there because that ties back into how we're going to do typical object type, so, yeah.
Yeah, so if you've written a Tcl' object type, you know that you are directly poking into the fields of the Tcl' object struct because it's an open struct. And we want to shut that down if we can. And so in Tcl' 8.7, it's already in 8.7, there's a whole set of new routines that give you access to the same fields, but through a function, instead of directly probing.
Setters and getters.
Yeah, pretty much, yeah.
Setters and getters and a constructor.
Right. And so the 8.7 migration step is convert my direct accesses to these functions. These functions will be in 8.7, they'll also be in 9, but they're free to have a different backend in 8.7 than they have in 9, or maybe 9.1. Right. That's sort of the opening of the evolutionary possibility.
But then in 9 is where we take the step of hiding the structure, so that if you're not using the functions, the code stops working. And this is what Joe English meant by retro forward compatibility, is that you put in the old release the stuff that you would have done if you had had perfect foresight, so that somebody can change their code on the existing release and have it continue to build moving forward.
No, I think it's great because they'll enable the ability for you to refactor back in pieces without having to worry about people touching
We have all kinds of architectural concepts that have been thrown out over many, many years. The Hydra idea of let's tackle the shimmering problem that people run into with let's not have a two-legged stork, let's have a stork millipede or whatever the right monstrosity is to invoke at that point. And having the freedom to innovate behind the curtain.
Yeah, although my preference is not have a hybrid, but have interfaces.
Make the intent explicit rather than trying to guess it from the structure.
Well, a lot of our shimmering problems come from the fact that so many of our data types look like lists. And if you use L-indexer for each of them, you just shimmered them into a list and lost your dictionary structure, for instance. And since it is possible to do in the implementation, it's possible to do indexed access to a dictionary. If we went to object types that support list API baked into the object type, there's no need to ever shimmer a dict into a list.
Actually, I just thought of something. What if the list command would take a dictionary and just return a copy, not actually change that value, but it made a copy of the dictionary you produced as the key value list, because it's going to get thrown away after 4 each is done with it.
Well, but that's the thing is you just had to make that copy. That's the expensive part. And well, I'm sure Don is looking at me significantly because I know he's done a significant amount of preliminary work on immutable data structures.
Yeah.
So
I'd love to get those going, but first I have to bring down a curtain so I can say, pardon my dust and work behind the scenes.
Right, and he and I can slug out interfaces and immutable data structures among ourselves.
I'm pro interfaces. Interfaces are good.
Okay. All right, a big hand for the Tcl' team. Okay, next we're going to do the work in progress session. So we have 5 people sign up. So we're going to have 5 minutes for each person to talk about their work in progress. The first person, David Simmons, to talk about EdgeScript. David, coming up.
I think everybody saw my talk yesterday. I am actually going to be releasing that for people to take a look at. That'll probably be available in about 2 weeks, maybe a week. The information for that's on the little USB stick you're all going to get. And I'm really just looking for feedback and obviously anything that I've done that may be valuable for the Tcl community to think about as you're looking forward, and language is also interesting. But my primary focus is, I just want to reiterate, on the target market of IIoT and edge-based compute and all the complexity of deploying in those spaces and managing it. So that's really my focus, and with that, trying to unify how package management with Fossil and SQL-like kind of technology works. So that's my brief summary. I'll take any questions, or I'll switch off to someone else.
Any questions for David?
Okay.
All right. That's awesome, David. That was like 1 minute for your lightning round. Okay, great. Next, Brian Griffin is coming up to talk about WWIP. Brian.
What I have is not a work in progress, but a worry in progress, or a Windows worry in progress. I just wanted to show you something. Hopefully this will come up all right. Okay. Hope everybody can see this. So this came about through a testing problem that we had on our product, where one of our regression tests was 3 to 5x slower on Windows than on Linux. And so I spent a long time digging into this, trying to figure out what changed to cause this problem, or what happened, so what's going on. And I boiled the problem down, and it can be demonstrated with this pair of simple Tcl scripts. So right here, we create a server. So this is just a server script. And all it does when the client connects to it is it reads stuff from the client and echoes back a random number. The client, when it connects to the server, spits out a starting message, reads whatever the server sent to it, and sends back a random number. And so these two client servers, they're just pinging back and forth, sending short messages as fast as they possibly can. Okay? Really straightforward. So I'm going to. So these windows on the left are Windows, just shells to the Windows layer. The ones on the right are Linux. It's running on our WSL, but it's Ubuntu Linux. Okay, and for this case, the particular version of Tcl is not an issue because the code involved hasn't changed in a long time. But anyway, I'll start up a server, start up the client. You can go over here and look. From a CPU perspective, you can see these top two lines. There's the client and server using 6 to 7% CPU. They're not really CPU intensive. You can look at the network traffic. So combined transfers of 20, 30K bytes per second, total of 55. I've seen as high as in the 60s, 60 to 70 total at times. Okay. So why is that a problem? Let me stop this. Same exact scripts running under Linux. On the same hardware, because it's right on the machine, under WSL, which is supposedly using this base OS, Windows is base OS.
So the same Windows.
Same OS, but it's Linux. It's the Linux build of Tcl'2019.
Yep.
Right? Let's go look what's going on. Same program sending the same bytes back and forth. Instead of 50, 60 bytes per second, we're at 377. I've seen this go over 400. And so there's your 3 to 5x performance difference. why? So it's an issue with the event loop and the way the event loop is written. And I've started exploring as to how to redo it. I haven't quite figured out a way to rewrite the Windows event loop. But this seems to me like a really big bottleneck in socket handling in the event loop.
So that's what that IOCP, a lot of stuff on IOCP in my talk is all about this very problem.
But as far as I can tell, the Windows implementation of the notifier has been the same forever. And it seems we've always had this known issue with our GUI and our applications being just more sluggish on Windows than on Linux, even though our simulator performance itself is identical on a Windows machine and an equivalent Linux machine.
Is the problem you're seeing in just the network throughput, or is where else does it manifest? Because I mean, depending on how much.
It's just the response time in turnaround response time on socket communications, on the socket events.
That's got a very specific solution. That is exactly what the IOCP stuff I was talking about.
So that's my big concern, and insights would be welcome.
If it is polling, which is what that looks like the worst case scenario where it's polling the event. It's not using.
It shouldn't be polling, but it is.
Is it using
So the other.
weight?
1 minute, Brian.
Okay. Well, I don't know how to statistic cover. There's like 7 threads running on the Windows side, and there's only 2 threads on the
thing you're
Linux side.
looking for is to go and look in the event loop if it's calling WSA wait event on the socket.
No, it's not.
Then it's going to be, if it's not
No, it's
even
not.
doing that, it's going to be the worst case scenario.
It's not. That's not using it.
There's sort of 3 levels of implementation. And
Well, the whole notifier has to be rewritten and all the socket interactions and stuff.
Well, if it's calling wait event and not WSA wait and using event handles on the socket, and you're not using it, you have to put this in. But it's a pretty straightforward fix on events.
It's doing a wait on off. There's a pipe involved.
Okay,
And
so it sounds like
wait on off.
Anyway, I'm very familiar with this problem. I'm happy to help.
Cool, that would be very helpful. All right, next, Trey Jackson, reflecting on 8.4 to 8.6. Trey.
So my name is Trey Jackson. I work at Mentor Siemens Business. And for those of you who know Phil Brooks, I work with Phil. And Phil and I just, this isn't so much a work in progress, but a work in completion. We just spent off and on the last 2 years porting from 8.4 to 8.6. And I just wanted to just give just sort of a update, probably more for the maintainers, just to let you know what we went through. And I think it was atypical, just based on when I was here 2 years ago. I was talking to people about, oh, we're starting this porting. Oh, it should work fine, everything should be faster and great. And kind of. So, and then a little bit about Tcl' hash table. So, we're successful. We've been shipping for 2 quarters now, and no customers complaining. So first, Calibre. Calibre is the tool that I work on. It's basically for computer chip validation, the design validation. It does physical, circuit, reliability, a bunch of stuff. The people run it on their Intel, Apple, Samsung, Sony. Everybody runs our software. We want everyone to run. A large number of people run our software on their computer chip designs before it goes to the fab. So that they can make sure that the design is going to do what they want and that they don't have to find and fix bugs after it's in silicon. So, Calibre's the use of Tcl'. I work on the GUI for debugging results, but we also use the GUI for configuring and running Calibre. And then Calibre itself, which is a large batch process generally, uses Tcl' as both for some internal flow configuration and the customer. It's an extension language for the customer, so the customers are actually writing some Tcl' scripts to basically do some custom device recognition of their designs. So, and in Tcl 4, Calibre was not built very ticklish. It wasn't just built as an executable. We just package require everything. We had a huge number of libraries that were smashed together in a big static library, and that was all linked in with Calibre. And so that's just, we did things that way for some reason. I don't know. Don't know why, but that was where we were coming from. Don't know what's going on. There we go. So Calibre's history, we started about 94, a long time before I was there. I've been there 12 years. We started with Tcl 8.0, I think, in 98, and upgraded 8.4 in about 2004, and have been there ever since until literally 2 quarters ago. In 2015, we began a little bit of a process of just making sure we could compile against Tcl 8.6, but we didn't actually start really working on it until 2017, and they finished mid-2019. It's a large project, 30,000 files, 18 million lines of code. Tcl specifically, about 1,500 files and 2 million lines of code. Large number of projects with different technical leads all over the globe. My team happened to be probably the largest impacted because I'm in the main GUI team, and a lot of other stuff is non-graphical. So their uses of Tcl are more simplistic, and we've used a lot of iTcl and widgets that way, and so we just had most exposure from that. And we didn't have a big pressing need to move. Yes, Tcl 8.4 is ancient, but there was nothing that was driving us that, oh, we will get this from Tcl 8.6. And for the GUI especially, I knew it was just going to be work with, there's no big GUI thing, oh, now we can do blah, blah, blah in Tcl 8.6. At least I'm not aware of that. So it was kind of hard to get all those different projects and all those different technical leads to start working on it, because they're like, why are we moving? Well, there's some reasons, but nothing was like, yes, you'll do this. Our external exposure, 1,000 customers. We were going to have at least 2 years of a code base that needed to work on 8.4 and 8.6. We don't know how many customer scripts there are, but luckily, most of the stuff is pretty simple that customers are using. Okay, what did we encounter? Well, BLT, if any of you can remember back to when BLT was something, we used it all over the GUI, and it's not supported in 8.6. There's some replacement packages for some of the graphical stuff, but other things were not. So I had to rewrite those. XML packages changed. That wasn't that much of a big deal, but it was something. Tcl precision for outputting numbers, just kind of disruptive, because a bunch of QA and customers are just seeing numbers come out in a certain format, and now it changes, and it just throws customers for a loop. So that's been an issue for us, and we try to get our people to do the right thing, and just when you're printing things out, use a format, and then you're guaranteed that it'll come out the way you want it. I don't know that everyone did that, but we've moved on. And then we had some weird crashes. Package requires struct set and struct list in the wrong spot, wrong being somewhere, and our application will just crash. Just trying, well, what is causing the crash? And yes.
Struct set and list have 2 implementations, pure Tcl and also, I believe, a C implementation via Tcl-libc. Do you know which of that was involved?
I don't. No, I don't know which one.
Okay.
So, and we just was like, okay, I can't reproduce this outside of our crazy environment. So just, hey, I'll move it around, problem solved. So I don't know, I can go look into that. There are just some small changes in shimmering between 8.4 and 8.6, and Phil has been in touch with people, and the answer was, oh, don't do string match, do string equals, and do some other things. So we think we've mostly fixed that. We don't see any problems right now, but I think some customers may experience that going forward. And then a weird one, Tcl get double. We were calling in certain flows without actually ever creating a Tcl interpreter. And in 8.6, that just causes things to crash. So as soon as you create an interpreter, it works. So there was some static or not static, but there's some initialization that was expected to be there. I don't think that my colleague filed a bug for that. Oh, and then iTickle. We have a lot of iTickle and a lot of iTickle code, and you can see I just put some examples in red, and we don't do this anymore. You could have a list of iTickle code of this and a method, and that used to work. I don't know why it was put in a list, but it worked, and we had a bunch of it all over our code because someone liked doing that. That no longer worked. And then a val of a list of a callback, which might be an iTickle code, and a list of arguments used to work, and now it doesn't because it doesn't. Again, it's just things got more strict, and our code had some people that just coded in a way that no longer worked. And then I believe the same thing, if you did tickle eval, if you basically passed a callback, there was a list of iTickle code into C++ and then made a tickle eval of that. That caused a crash. Okay, so just, again, it was just cleaning up our tickle code, not a bug, but it was just kind of weird. Okay, and then the look and feel and performance. So we found a number of performance problems. At one point, the GUI, when we first started, was pretty unusable in terms of, when it was mostly related to iTickle and some using tickle preserve and tickle release. And we got a fix put into Tickle, and that was great, and that resolved 80% of our problems. There was a time when we were using a mega widget with the tabbed windows, and we had a test that popped up 100 tabbed windows, and before they come up in about, I don't know, maybe 2 seconds. After that, you could just count 1, 2, 3, 4, 5, and just watch the tabs just slowly come up. There's still a couple of things that I think Sergi's fixed, and we're trying to figure out how to. It sounds like we just need to work with him to get smaller deltas to push in. That was what I kind of got from you guys. He just tries to push in big change sets. And I don't know how he's worked on some things. I don't know how acceptable they are. I haven't looked at them from that point of view.
Recent commits that got into 4.2 and are in the release candidate are from him, and they
Yeah.
help performance on those iTickle things.
Yeah, that's great. So the GUI's back to being performant. Grid and pack changes, there are just some changes. It's more strict. And then the geometry managers, just something changed in it, and paned windows come up differently. And sometimes they'll come up showing, one pane at 10% and another pane at 90%. And that's, not the end of the world, but it's a challenge to fix, because you would say, okay, well, what's your size? And say, oh, my size is such and such, some number. Okay, I want it to be bigger. But it's still that same number. Well, so I now have a loop, some silly loop of, go through 10 times and adjust until you get pretty close to the number we want. Okay, now you're done. So there's just some weird look and feel things that changed, and we've worked around them, but they're kind of a pain.
One more minute.
Thank you. The radio button changed from this nice diamond. We think it was nice because that's what we were used to. It would grow with the size of the radio button. Now it's just a little dot. It stays the same size regardless of for example, the font size. So if you have a huge font, it's still a tiny little dot. Where the diamond is scaled so nicely. So we've adjusted internally. And then the font change, just switching from the old way fonts were grabbed to using XFT, that just threw everything off. And I have some people that are just so used to the old fonts, and I don't think they look as good, but we actually compile now to use the old font. Tcl'2019, we use those. So that was just some of the pain. The impacts, wrote about 600 lines. This Tcl is pretty easy to replace the BLT that wasn't provided by the non-graphical BLT stuff. We still have about 300 locations where there's, if we're in Tcl'8.4, do that. If in Tcl'8.6, do this. And then, just lots of boilerplate changes and QA tests, updates. But it's hard to know when we're done. We just, about 2 weeks ago, found a spot where the test passed on the window, but it was I think it was another SASH thing where the grid just didn't repack properly, and so it wasn't visible. The widgets existed, so the test would exercise those widgets, but you couldn't see anything. Now for something completely different, just to wrap up, Tcl' hash table. We like Tcl' hash tables. We're using it in C++. We have one application. In one application, we're using Tcl' hash tables to basically find out if we've seen this geometry before. We read in hundreds, thousands, millions of geometries, and based on criteria, have we seen this before? If so, mark it special. Okay, in one degenerate case, we're creating thousands of hash tables, one at a time. We create it and then just erase it, clear it out, and create a new one. And the core case, in that flow, we had 8 tables with 1 million buckets and 2 with 4 million buckets. So these were getting huge, and they were holding between 1 and 10 million entries, respectively. And then the search distance. Luckily, the Tcl' hash stats was awesome. It was, okay, I see what the problem is. The 10 million entry had a search distance of 7, so it was really getting slow. And then the 1.5 million entry table had an even larger search distance. And we just, I don't know what to do, and it just appeared that the Tcl' hash sizes are very distinct, going from 1 million buckets to 4 million, and then 4 million seemed to be the top. Well, we needed a fix, so we just dropped in a Qt and a Q hash, and no other changes, just dropping in a Q hash, we got a 30% improvement. So just something to think of when we're moving to larger structures being possible of having things scale a little more cleanly. And this is a weird degenerate case. Hope people don't do this with our tool, but it was pretty painful. But there was another cleanup that we did that reduced it by another half, but the hash table was a significant part. All right. Thank you.
All right, thanks. Thank you, Craig. Next up, Kyan Ogilvy will talk about V-tables in Tcl'.
So I think a lot of us were here for Richard's excellent SQLite internals talk. One thing that I got quite excited about was the V-tables facility, which is really exposing anything you want as a dynamic table that, when you look at it, some callbacks determine what you see. So in the same way that Unix views everything as a file, this is a way of viewing everything as a table, which is a cool trick. It's the sort of trick that I enjoy doing. And actually, the interface to do that is pretty straightforward in C, but it means you have to write C, and the barrier to doing one of these is just a little bit higher than I think a lot of the useful use cases make feasible. So I thought it might be cute to expose that functionality through to a Tcl script to be able to produce a vtables driver. So I started doing that with a Tcl object. So you instantiate one of these things, which is essentially a driver with methods for each of the callbacks that you would implement in C. You populate those, and that registers that vtable module in SQLite, and you can go ahead and query it. So imagine like a simple case. So you've done your instrumenting of your Tcl program. You've got call graphs, you've got timing information and things like that. You could have a vtable that does introspection back into the Tcl interpreter and says, these are my procs. So it's proc name, the arguments, and proc body if you wanted to, and do a select from timing with this proc, and then you join it across to the proc table to get out the proc arguments. It's a trivial example, but you could do that or plug in things to go and query REST interfaces, or really whatever crazy thing. And what I'm sort of aiming for is, no way is it going to be performant. Like let's not make that mistake. This is the wrong way to do it if you've got something with millions of records. But I think it'll be a useful way to be able to query and draw together different things, ask interesting questions of types of data that you have available. If you've ever used Linux or Unix with /proc file system, where in true keeping with the Unix philosophy, everything's a file and you can access it with your normal shell scripting tools, that becomes actually tremendously powerful. So this is the same concept, just applied into database tables. So just an announcement that this is going on. If anyone's interested in following where this goes, and if it does actually go anywhere or having any inputs, then come talk to me.
Great. Thank you, Kyan. And our final work in progress talk is Roy Keane talking about XVFS. Roy.
So XVFS is something I've been working on for a while to augment Sean's work with ZipFS. It's basically the extension or extensible virtual file system. It's meant to, this guy's gone, but it's meant to enhance our Rube Goldberg machine. So when we build TCL right now, we have the library libTCL, and we have a bunch of TCL scripts that, you know, if you build TCL Wapp, you'll not have the clock command because those files live outside the library. The goal with XVFS is twofold. It's to add the machinery for making extension capable of inserting their scripts and other resources that may not be scripts, like encodings or message catalogs, any kind of thing that can be represented as a file with a defined size, into the extension, mounting that up in a known place, which has been added by tip 430, ZipVFS stuff, mounting that up and then making that available to the interpreters in that process. So the way it works is by creating basically resources, like David was talking about. You insert those resources into the object, into the relocatable object before you do your final linking, and then there's the machinery that hooks it to the TCL file system mechanism, and then you can access it just by loading that shared object, or it doesn't have to be a shared object because it's an object file, a relocatable object. You can have it included in your static archive. So you can have like a libTCL.a, you link to your application. It also includes your VFS. You can have a statically linked application that links statically to TCL and includes its VFS. Not just that, but any other extensions that use TCL or XVFS will have their resources included in that file system as well. So it's split into two parts, basically a client-server mechanism. This is to help improve efficiency with the way TCL file system works, which is basically, it's not like a mounting system. The TCL file system, basically, you claim arbitrary paths. So in order to make that more efficient, in the core, we have the core of XVFS, which will, this is the idea anyway, it's not how things are, or nothing that's been officially proposed. In the core, we have something that allows you to register your sub-file system into that handler. And it'll just be one single TCL file system handler for that namespace, and it'll then have a hash table lookup into your particular dynamically or statically loaded extension. And this, the main benefit is people will quit breaking the install of TCL in distributions, and you'll have simpler, more traditional style distributions of what people expect there to be in a library, which is just a library file. I think Will Duquette was doing something similar when you included the lib.tcl as an eval thing. This extends that out to any kind of file. That's it. Any questions? Oh, there's Will.
Rube Goldberg approves.
At least this is a standardized Rube Goldberg. Consistency is better than quality, at least 80% of the time. This is very consistent.
More importantly, consistent, correct.
Yeah. Is that it?
All right, great. Thanks all of our work in progress talks people, and actually spoke with the management of the hotel, and dinner is ready. So I want to head out there and fill up your plates and go to the banquet. Andreas has something
before, on the desk or outside are the burnt memory sticks, so everybody can take as the number basically on the sheet, and please do not forget to check out that you have taken a memory stick.
Okay, great. Thanks, everybody. We will have the banquet now, and then the hospitality suite will be open afterwards, and we will resume tomorrow morning at 9 a.m. Thank you.